everyone, welcome to our cryptocurrency full course by Simplilearn. What if I told you money is changing faster than ever? Cash, banks and traditional finance are being challenged by a whole new world. Cryptocurrencies like Bitcoin, Ethereum and many more. So in this full course, we will break down everything you need to know about digital revolution. You will learn what crypto really is, how blockchain works, what wallets, mining, trading and DeFi mean, and how all these pieces fit together. Crypto isn't just for techies anymore. It's becoming part of everyday. Finance and skilled people in this space are in huge demand. And by the end of this course, you will understand how cryptocurrencies work and how to make smart, confident moves in the world of digital money. So guys, if you're ready to geek out on blockchain, explore the future of money and become a crypto pro, hit that like, subscribe, and let's dive into the world of cryptocurrency. Before we begin, if you are interested in growing your career in blockchain, then the Master Certification is a great way to start. The Professional Certificate Program in Blockchain by Simplilearn is the right choice for you. This is a 4-month live interactive online program from Simplilearn in collaboration with IIT Kanpur. The program offers interactive live virtual masterclasses delivered by IIT Kanpur faculty, gain hands-on expertise through integrated labs and real-world blockchain projects, and a lot more. The core advantage of this program is you gain Certificate of Honor on completion of this course with Simplilearn and IIT Kanpur. So whether you're switching careers or looking to upskill, this course is the perfect choice for you. So guys, hurry up and enroll now and you can find the course link below.
Meet Frank and Daniel. One day they decide to go for a trip to Venice. They made a budget list for all their expenses like residence, flight, etc. They thought of making their bookings online from a site that offered discounts to the first 10 visitors on that day. While making their respective flight bookings, Daniel's transaction failed, and he missed the offer going on. On the other hand, Frank paid his share very quickly and easily, and became one of the 3 lucky draw winners. Daniel was surprised and asked Frank how he could make the transaction when Daniel himself could not. To which his response was, "It's simple. I used Bitcoin, a type of cryptocurrency." Daniel was confused, and he asked what cryptocurrency is, and since when has it been in use? Frank stepped up and explained to him. Cryptocurrency is a virtual or digital currency that works on blockchain technology, and is designed to work as a medium of exchange online to buy goods and services and make payments, which was introduced to the world first in 2013 by Satoshi Nakamoto. Daniel felt that it sounds similar to other online payment options. He asked what makes it so different. Frank explained, cryptocurrency is decentralized and free from any third-party interference, which means it is not issued and controlled by any government or central authority, unlike other payment systems that banks or governments are handling. And that's why a cryptocurrency transaction never fails. There could be many reasons for why Daniel's transaction failed, like he may have exceeded his transfer limit, or his account must have been hacked, or there could have been some technical issue with his bank server, or maybe due to high transaction fees imposed by the bank. But on the other hand, cryptocurrency charges almost no or very low transaction cost. There is no limit for making transactions. In fact, you have 24/7 access to your money. There is no extra delay or extra charges on making international transactions. And the best part is that anybody can use cryptocurrency without the hassles of paperwork. All you need to do is create an account on any digital wallet of cryptocurrency. This is what makes cryptocurrency different from other online payment options. Daniel was impressed by cryptocurrency, but he wondered how it works without the control of an external authority. Upon research, he found out that cryptocurrency works on blockchain technology. Blockchain is a set of blocks that record information of transactions, like who made the transaction to whom, the amount of trade in the form of a digital ledger that is distributed across the entire network, meaning the data is replicated and stored on each node across the entire blockchain network, making it more secure and impossible to change, hack, or cheat the system. Then it is verified and validated by every node to proceed with the process of making the transactions. The crypto in cryptocurrency stands for cryptography, which is a method of using encryption and decryption to secure the data in the presence of any third party with ulterior motives. Now Daniel was completely aware of the whole technology and concept behind cryptocurrency, and was influenced by Frank to adopt cryptocurrency in his daily lifestyle too. He did that by booking his ticket. but sadly, no discount. Like Daniel, cryptocurrency has influenced and impacted an enormous number of people worldwide. Due to this increasing popularity, new companies like Meitu and PayPal are coming forward and investing in cryptocurrency every day. In 2018, Malta, an island located in the Mediterranean Sea, south of Italy, was titled Blockchain Island, as it led to the economic stability of the nation. Many fintech companies like Binance and OKX have already begun to take advantage of Malta's financial incentives and have moved their headquarters to the blockchain island. So, here is a question for you. Which hashing algorithm does cryptocurrency use? A. Script. B. Ethash. C. SHA-256. D. None of the above. Please give it a thought and drop your answers in the comments section below. 3 lucky winners will receive Amazon gift vouchers. Cryptocurrency is revolutionizing finance and banking around the world. Thanks to cryptocurrency, now anyone with an internet connection can trade, spend, and borrow money around the world, and nobody can stop them. People like Bill Gates, co-founder of Microsoft Corporation, and Elon Musk, CEO of Tesla, support cryptocurrency, as it is much better and secure than physical money and also holds a great future for the world's economy. And on the other hand, some people think of cryptocurrency as a bane to the world's economy, like Warren Buffett, CEO of Berkshire Hathaway, and Ajay Banga, CEO of Global MasterCard, feel that cryptocurrency is a platform of criminal activities and will destroy the world's economy. Well, one thing is clear, that this conflict is going to stay put for a little longer. Meet Susan, an aspiring painter. She wishes to conduct an online painting exhibition for all her digital artworks. However, as the exhibition is online, she is worried that her paintings won't be secure, as anyone could easily forge or replicate them. Her friend Mark came to her rescue with an idea of NFT. He suggested that Susan could buy NFTs for all her paintings, as NFTs are trustworthy, easily transferable, and will also maintain her ownership rights on her artworks. Susan had no idea what NFTs were, so Mark stepped ahead and explained it to her. NFTs turn your digital assets into one of a kind by creating a unique digital signature, which defines the ownership of your assets, and that can be bought and sold for real money, cryptocurrency, or any other asset, like a non-fungible token, aka NFT. Non-fungible tokens means that they are not interchangeable, and each of them represents unique assets owned by a specific person. On the other hand, fungible tokens are interchangeable and can be divided into smaller units to form the same value. For example, a $100 bill is fungible, as you can exchange it with 5 $20 bills or 2 $50 bills. But the painting of the Last Supper is non-fungible, as it cannot be generated in bulk. Even if it is copied, it will not be authentic. Each NFT contains distinguishable information like who owns the digital asset and who sold it, making them distinct and easily verifiable. As it is impossible to forge such a certificate, it will secure her painting's originality. After learning what NFT is, Susan was curious to know how exactly NFT works. NFT basically creates a blockchain-based digital certificate for your digital collectibles, including games, music, art, and many more. This certificate gives your artwork a unique identity. The underlying technology and the programming language used by NFTs are the same as other cryptocurrencies, such as blockchain and the programming language Ethash or Script. NFT majorly exists on Ethereum blockchain, a distributed public ledger that records all the transactions. However, NFT is quite different from these cryptocurrencies. Bitcoin and Ethereum are fungible tokens, which means if you trade Bitcoin or Ethereum for one another, you will have the same value or item in return, basically money. On the other hand, NFT is a unique token. Therefore, if you try to trade it, you may end up with something completely different in your hands. CryptoPunks is a remarkable example of NFT. It enables you to buy, sell, and store 10,000 collectibles with the proof of ownership being stored on the Ethereum blockchain. After exploring how NFTs work, Susan was convinced and bought NFTs for all her paintings. Due to this, her artworks were secured from any kind of forgery and also gave her artworks a particular value. This contributed to increased sales too, as everyone was easily able to buy the artwork without any fear. All in all, her exhibition was a complete success. Similarly, NFT has proved itself to be a boon in the lives of many others, like Jack Dorsey, the CEO and co-founder of Twitter with his very first and famous tweet, "Just setting up my Twitter." and Vignesh Sundarasan, famously known as Metakovan, who bought $69.3 million worth of NFT art on Beeple. Owing to its increasing popularity, people are now willing to pay hundreds of thousands of dollars for NFTs. NFT has enhanced media exposure and special perks for aspiring artists like Susan on social media. This popularity of NFT creates new opportunities for new art platforms, motivating people to buy art from internet platforms and promoting copyright or originality of digital assets. Ever wonder if there's an easier way to complete transactions without having to deal with online wallets, banks, and third-party applications? Well, it's possible thanks to blockchain. Here's everything you need to know about blockchain. Imagine 4 friends, Jack, Ted, Sam, and Phil, meet up for dinner. After they're done, Jack pays the bill, and all of them decide to split the expense amongst each other. Now, on the next day, when Phil sends his share to Jack via online money transfer, the transaction goes through without a hitch. Then, Ted and Sam send their respective shares to Jack, but their transactions don't go through. The failed transaction cites some issues at the bank. That's when Jack comes to know about the many ways a bank transaction could fail. It could be due to technical issues at the bank, one of their accounts were hacked, daily transfer limits being exceeded, and sometimes additional charges, like transfer charges, associated with transferring money. To solve these problems, the concept of cryptocurrency came into existence. Cryptocurrencies are a form of digital or virtual currency that run on a technology known as blockchain. Thanks to blockchain, cryptocurrencies are immune to counterfeiting, don't require a central authority, and are protected by strong and complex encryption algorithms. And in a market of more than thousands of cryptocurrencies like Litecoin, Ethereum, Zcash, and so on, one reigns supreme: Bitcoin. Now, let's go back to our previous example and have Phil, Ted, and Sam send Jack 2 Bitcoins each as their contribution to the previous night's dinner. Let's assume Phil, Ted, and Sam have 3 Bitcoins in reserve, while Jack has 5. First, Phil sends 2 Bitcoins to Jack. A record is created in the form of a block. The transaction details between them is permanently inscribed in this block. This record also holds the number of Bitcoins each of the friends own. So, after Phil's transaction, Jack has 7 Bitcoins, while Phil has 1. Following this, Sam and Ted send 2 Bitcoins to Jack. A new block is created for each of these transactions. These blocks hold the transaction details as well as how many Bitcoins Sam, Ted, and Jack have in reserve. These blocks are linked to each other, as each of them takes reference from the previous one for the number of Bitcoins each friend owns. This chain of records, or blocks, is called a ledger, and this ledger is shared among all the friends, which acts as a public distributed ledger. This forms the basis of blockchain. So, what happens when Phil has only 1 Bitcoin left, and he tries to send 2 more Bitcoins to Jack? The transaction will not go through. This is because all his friends have copies of the ledger, and it's clear that Phil has only 1 Bitcoin left. His friends will flag this transaction as invalid. A hacker will not be able to alter the data in the blockchain because each user has a copy of the ledger. The data within the blocks are encrypted by complex algorithms. All of this is made possible with the help of blockchain technology. Blockchain can be described as a collection of records linked with each other, strongly resistant to alteration, and protected using cryptography. Now, let's have a closer look at the Bitcoin transaction between Jack and Phil and find out how it works. Every user in the Bitcoin network has 2 keys, a public key and a private key. The public key is an address that everyone in the network knows of, like an email address of a user. The private key is a unique address that only the user has knowledge of, something like a password. First, Phil passes the number of Bitcoins he wants to send to Jack, along with his and Jack's unique wallet address through a hashing algorithm. All of this is part of the transaction details. These details are encrypted using encryption algorithms and using Phil's unique private key. This is done to digitally sign the transaction and to indicate that the transactions came from Phil. This output is now transmitted across the world using Jack's public key. With this, the message or transaction can be decrypted only by Jack's private key, which only Jack has knowledge of. Different cryptocurrencies use different hashing algorithms. while Bitcoin uses the SHA-256 algorithm. Ethereum, which is also a famous cryptocurrency, uses one known as Ethash. This transaction and several other similar ones are taking place all around the world. These transactions are validated and then added block by block. The people who validate these blocks are called miners. For a block to be validated and added to a blockchain, miners need to solve a complex mathematical problem. The miner who solves this first adds the block to the blockchain and is rewarded with 12.5 bitcoins. The process of solving the complex mathematical problem is called proof of work, and the process of adding a block to the blockchain is called mining. With this, Phil and Jack's wallets are updated, just like every person in the network who has completed a transaction. Now that you know about blockchain and its important concepts, time for a small quiz. What is the concept of blockchain that ensures data cannot be altered by any of the users within the network? A. Public distributed ledger. B. Proof of work. C. Proof of stake. D. Hash encryption. Let us know what you think is the right answer in the comments below. 3 lucky winners will get Amazon gift vouchers. Details are mentioned in the description below. Let's have a look at how Walmart uses blockchain to provide its customers with better service. Walmart was facing problems in delivering quality products to its customers. They were facing a high return rate and large amounts of refunds due to their products' bad quality. They were unable to determine the point of failure in the supply chain, which started from farm to storage to transportation to processing all the way to the customer. Then, Walmart adopted blockchain technology. With blockchain, the quality of the goods at each step was permanently inscribed within a block. For example, when a customer flags a product as damaged, it can be correctly identified where the product got damaged in the entire supply chain, thus helping Walmart to identify the problem areas and fixing them. And this is just one of several ways blockchain is used in real-life applications.
The market is really taking off, with the total value of cryptocurrencies hitting an incredible 2.27 trillion, according to a recent update from Binance. It's fascinating how blockchain technology, the underlying foundation of cryptocurrencies, has transformed the way we look at finance and transactions, offering decentralization, transparency, and security like never before. Cryptocurrencies like Bitcoin and others are changing how we think about money. They use technology called blockchain, which makes it possible for people to trade directly with each other without needing banks or any other middlemen. This means that anyone with an internet connection can access financial services no matter where they are in the world. In this rapidly evolving currency, Binance has emerged as a key player. But what exactly is Binance? Over the past 3 years, Binance has been a big player in the world of cryptocurrency trading. It's been super popular and consistently attracting the highest volume in both spot trading and derivative trading. Today, we will be your guide through the exciting world of Binance. So in this video, we will be covering everything you need to know. What is Binance, how Binance works, and cryptocurrencies on Binance. So buckle up and get ready to learn more about Binance. Alright, so what is Binance? So Binance is a major company in the world of cryptocurrency and the world's largest cryptocurrency exchange based on how much trading happens there every day. They offer a variety of services including buying and selling of over 500 different cryptocurrencies, then ways to make money from your crypto holdings without actively trading, that is often called passive income, then advanced tools for experienced traders. With almost 190 million users from over 180 countries, Binance is a popular platform for people interested in cryptocurrency. Binance goes beyond just buying and selling crypto. They provide various options for investors to earn passive income on their holdings. This could involve staking, that is locking up your crypto for rewards, or participating in DeFi, that is the decentralized finance applications directly through the platform. For example, imagine you have some dollars, some US dollars, and you want to buy a Bitcoin. You would go to the Binance website or app, create an account and deposit your dollars into your Binance account. Once you have funds in your account, you can use them to buy Bitcoin or any other cryptocurrency supported by Binance. After the purchase, the Bitcoin will be added to your Binance wallet, which is a secure digital wallet used to store your cryptocurrencies. So this was about Binance. Now let's understand how Binance actually works. So Binance is like a big digital marketplace for cryptocurrencies. It offers a bunch of services like letting you trade one cryptocurrency for another, or even buying cryptocurrencies using regular money like dollars or euros. It supports different ways to play like bank transfers or credit cards. When you want to trade on Binance, it keeps tracks on all the buying and selling happening on the platform using something called the order book. This is just a list that shows who wants to buy and who wants to sell at different prices. So let's say you want to buy some Bitcoin with your dollars. You go on Binance, find the Bitcoin trading section, and you will see a list of people who are selling Bitcoin and at what prices, and also a list of people who are buying and at what prices. You can choose the prices what works for you and make the trade. Binance also has some fancy features for more experienced traders, like borrowing money to trade, that is margin trading, then trading contracts for the future price of cryptocurrencies, future trading which is called, and even trading directly with the other people like P2P trading. So this was about how Binance works. Now let's have a look at the next thing, which is cryptocurrencies available on Binance. Binance offers a vast selection of cryptocurrencies catering to both established coins and newer ventures. Some of them include Bitcoin, Ethereum, Pepe, Cosmos, Dog-V-Fat, Voyager Token, Solana, Polkadot, and Wormhole. So this information is for the educational purpose only and should not be considered financial advice. Before investing in any cryptocurrency, conduct your own research and understand the inherent risk involved in that. So, as we wrap up our look into Binance, it's evident that this platform has been a game changer in the world of cryptocurrencies. With its strong features, user-friendly services, and focus on safety, Binance has become a go-to choice for many around the globe. As cryptocurrency space continues to evolve, Binance remains steadfast in the mission to empower individuals and institutions to participate in the future of Binance.
Hey everyone, welcome to this new video of Simplilearn on what is Phantom. But to understand Phantom crypto precisely, let's take an example. Imagine that Alice wants to send money to her friend Bob, who lives on the other side of the world. Instead of using a slow and expensive traditional method, Alice uses Phantom cryptocurrency to send the money. Now, Phantom's fast and secure blockchain technology processes the transaction in just a few seconds, and the money is transferred directly to Bob's wallet. Bob can then easily exchange the Phantom tokens for his local currency and access the funds. Overall, Phantom cryptocurrency offers a reliable and efficient way to send money anywhere in the world without relying on intermediaries or worrying about delays or high fees. Now, technically speaking, Phantom or FTM is a cryptocurrency that operates on its own blockchain platform. It aims to provide a fast, scalable, and secure infrastructure for decentralized applications and smart contracts. Phantom was designed to address some of the common issues associated with blockchain platforms such as high transaction fees, slow transaction speeds, and limited scalability. It uses a technology called Laces protocol, which enables faster consensus and allows for parallel processing of transactions. The Phantom ecosystem also includes several other components such as virtual machine for executing smart contracts, a decentralized exchange for trading cryptocurrencies, and a staking mechanism that rewards users for holding and securing the network. Overall, Phantom aims to provide a reliable and efficient platform. So now that you know what is Phantom, let me tell you how it works. So Phantom basically works on DAG or Directed Acyclic Graph. In DAG, there is a set of systems in a network who constantly interact with each other back and forth about transactions that they have. Using this concept, they agree on what the ledger is and what data should be stored on them throughout the time. This confirms the finality of the transaction and makes sure it's time effective. Preceding that, Phantom works with consensus mechanism. Now, Phantom follows a special proof of stake model, Laces. Laces only have 50 validators, and to become a validator, you will need to at least take 1 million Phantom coins, which is currently a lot of money. But you can definitely delegate your Phantom coins to any other validator whom you trust, and that validator can actually participate in DAG on your behalf. And you can then easily earn rewards, and to make that possible, you can also stake as low as 1 Phantom. However, you must select a lockup period, because the longer you stake your token, the more rewards you get in return. Now, to understand the functionality of Fantom, let me take you through the tokenomics of Fantom. Now, did you know that popular blockchain project Fantom is using an innovative model to grow its ecosystem? With nearly 3.2 billion FTM tokens in circulation, the project has adopted an inflationary approach that decreases as more users join the platform. To further incentivize your adoption, the platform using a whopping 20% of the total inflation rewards for nodes, while giving the rest as incentives for users contributing to the overall growth of the network. These incentives include negligible transaction fees and rewards for users who actively participate in the network's development. So, why not join the Fantom network today and start reaping the benefits of this exciting ecosystem? Well, let me tell you, Fantom tokens were distributed in the following way: 40% token sale, 30% market development, 15% advisors or contributors, and 15% Fantom team and founders. So, now the question arises, how to buy Fantom? Now, you can buy Fantom on decentralized exchanges like eToro, Kraken, Bybit, and Mexi.
Recent developments in the crypto industry have given us access to a brand new financial and technological environment. The world learned an inventive method for modernizing traditional financial systems, which are frequently rife with a wide range of problems. For example, liquidity pools and other novel ideas had a lasting impression on the cryptosphere, and this is what has brought us here. Hey everyone, welcome to this new video on Liquidity Pool by Simplilearn, to give you a complete idea of Liquidity Pool and how it's connected with the crypto world. But before moving on, please subscribe to our Simplilearn channel and hit that bell icon to get updated on more such interesting videos. So first, let's have a look at what we're going to explore in this video. First, you will get an idea about what is decentralized finance, or DeFi. Then you will understand what a liquidity pool is. Following that, you will understand the difference between the liquidity pool and ordered books. Then you will get a broader perspective on how exactly liquidity pools work, and what are the regulations of the liquidity pool. And in the end, you'll get a gist of the pros and cons of liquidity pools. So let me take you through decentralized finance first. Decentralized finance, or DeFi, is a new financial system that is built on safely distributed ledgers, much like the ones used by cryptocurrencies. DeFi reduces the service charges that banks and other financial institutions impose. Anyone with an internet connection can use DeFi, and users can hold their money in a safe digital wallet and transfer money quickly. Basically, by giving people access to peer-to-peer digital trades, DeFi threatens the centralized financial system. And crypto assets are locked into the contracts, referred to as liquidity pools, by users of DeFi protocols so that others can use them. Well, now that I've mentioned liquidity pools, let me explain what exactly a liquidity pool is. A liquidity pool is technically a pool of crypto tokens secured under a smart contract. And these tokens provide decentralized exchanges with the necessary liquidity they require. Basically, the term liquidity refers to the ease with which one can swap a crypto token for another. Because so many financial transactions occur within the DeFi ecosystem, such simplicity is crucial. But this raises the question of how liquidity pools differ from ordered books. To understand how liquidity pools differ from ordered books, let's look at the fundamental building block of electronic trading, which is the ordered book. Simply put, the open orders for a certain market are gathered in the ordered book. The system that matches orders with each other is called the matching engine. The ordered book and the matching engine are the primary components of any centralized exchange, or CEX. This concept made it possible to communicate information efficiently and enabled the development of intricate financial markets. DeFi trading, however, carries out deals directly on the blockchain without needing a central entity to retain the funds. In terms of ordered books, this creates a challenge. Gas fees are incurred for each interaction with the ordered book, making the cost of executing transactions significantly higher. Additionally, It makes it very expensive for traders who act as market makers and supply liquidity for trading pairs. Above all else, however, most blockchains cannot handle the throughput needed for the daily trading of billions of dollars. But liquidity pools solve each of these problems with ease. So, now that the definition and purpose of the liquidity pool are all clear, let me walk you through the working of liquidity pools. As discussed before, in a normal liquidity pool, users are encouraged and rewarded for staking their digital assets in the pool. Rewards may take the form of cryptocurrency or a portion of the trading commissions paid by the exchanges where they pool their assets. And here's an example of how it operates. A trader using SushiSwap to invest in a BTC to USDT liquidity pool. Step 1, go to SushiSwap. Step 2, find the BTC USDT liquidity pool. Step 3, deposit a split of BTC and USDT to the BTC USDT liquidity pool. Step 4, receive BTC USDT liquidity provider tokens. Step 5, LPTs should be deposited to the BTC USDT staking pool. After the agreed upon amount of time has passed, you'll be given the sushi token you pledged to keep it safe. It can be for a set period of time, like a week or 3 months. The original BTC USDT pair would be compensated with a percentage of the commissions received from exchanges on that liquidity pool. In addition, by staking your LPTs, you would receive sushi tokens. Now that the working of the liquidity pool is in front of you, let me give you a gist of the regulations of liquidity pools for your investments. The investment fund manager needs a license to build a pool. In addition, regardless of the jurisdiction, an investment fund license is required whenever the pool is actively sold or promoted to clients. Some cryptocurrency liquidity pools circumvent the issue by presenting themselves as community-owned and distributing governance tokens. The entire community holds the ownership. Thus, regulators won't be able to go after the owners in court. However, there is a significant amount of risk associated with joining such pools. Well, now that the concepts of the liquidity pool are all clear, let me give you a look over the pros and cons of the liquidity pool to give you a better understanding. The liquidity pool makes trading on the DEX simpler since transactions are carried out at current market prices. Whereas it goes against the idea of decentralization that a small group controls the pool of funds. People can use it to lend money and get paid in prizes, interest, or an annual percentage yield in return for their cryptocurrency. On the other hand, due to lax security measures, there is a risk of hacker exploits, which could cost liquidity providers money. It uses publicly accessible smart contracts to maintain the transparency of security audit information. But on the contrary, there is an exposure to temporary loss. This occurs when a change in the price of your assets that are held in a liquidity pool results in an unrealized loss, as opposed to if you had just kept the assets in your wallet. Well, this was all about liquidity pool and its related concepts. Hey everyone, we all know Ethereum has undergone a significant update, one dubbed as the single most significant event in crypto history. The update would completely restructure blockchain technology, the world's second largest blockchain infrastructure. After an event known as the merge, the blockchain network, which presently uses the proof of work algorithm that drives Bitcoin and other cryptos, will move to proof of stake consensus. Top crypto fund Bitwise Asset Management has hailed this upgrade as the year's most intriguing narrative in the digital asset market. So, here's a video by Simplilearn on Ethereum merge to understand how this new evolution of Ethereum will affect and grow the crypto world. In this video, we will learn what is the Ethereum merge, followed by the benefits of the merge, and then we will put light on what will happen to ETH2, and at the end, we will understand the relationship between these upgrades. So, the first thing is to understand Ethereum merge and why it came into existence. The merge brought together Ethereum's initial execution layer and its newest proof-of-stake consensus layer, the beacon chain. It made it redundant to mine cryptocurrency, which used a lot of energy and allowed the network to be protected with staked ETH instead. Adding greater scalability, security, and sustainability was a very exciting step toward achieving the Ethereum mission. In the beginning, mainnet and the beacon chain were sent separately. Proof of work continued to be used to secure the Ethereum mainnet, which includes all of its accounts, balances, smart contracts, and blockchain information, while beacon chain operated in parallel using proof of stake. Now, these two systems came together for the first time during the merge, and proof of stake eventually took the place of proof of work. But this raises the question of why exactly it came into existence and the benefits it provides. The two most important issues that Ethereum merge primarily focuses on are energy consumption and scaling. Ethereum's proof of work era ended with the merge, ushering in a more environmentally friendly and long-lasting Ethereum. Energy use for Ethereum decreased by an estimated 99.95%, making it a green blockchain. Find out more about the energy uses of Ethereum. Also, the merge paved the way for more scalability improvements that would not have been feasible under proof of work, moving Ethereum one step closer to reaching the full scale, security, and sustainability described in its Ethereum vision. But now that Ethereum merge is active, what will happen to ETH2? Now, the phrase ETH2 has been phased out. There is just Ethereum now that ETH1 and ETH2 have been combined into a single chain, eliminating the need to distinguish between the two Ethereum networks. To limit confusion, the community has updated these terms. First, ETH1 is now the execution layer, which handles transactions and execution. And ETH2 is now the consensus layer, which handles proof of stake consensus. But these terminological updates solely affect naming standards. They have no impact on Ethereum's objectives or development roadmap. Well, now that we have understood the existence of Ethereum merge, now is the time to understand the internal relationship between these upgrades. So all of Ethereum upgrades are connected in some way. So let's review the connections between the merge and the other enhancements. First, the merge and the beacon chain. Well, the beacon chain is now officially the replacement consensus layer for the original mainnet execution layer as of the merge. Since the merge, the Ethereum mainnet is secured by validators. Mining based on proof of work is no longer an accepted block generation method. Instead, validating nodes that have staked ETH in return for the ability to participate in consensus proposed blocks. Future scalability improvements, like sharding, are made possible by these modifications. Second is the merge and the Shanghai upgrade. The merge upgrade does not include several anticipated functionalities, such as the ability to withdraw staked ETH, to streamline and optimize focus on a successful transition to proof of stake. The merge, which will allow investors to withdraw, is scheduled to be followed by the Shanghai upgrade. And the third one is the merge and sharding. Before the merge, efforts on sharding were initially intended to solve scalability. However, with the popularity of Layer 2 scaling solutions, switching from proof of work to proof of stake first became more important. Plans for sharding are rapidly changing, but given the development and popularity of Layer 2 technologies to scale transaction execution, the focus of sharding plans has shifted to determining the best method for distributing the burden of storing compressed call data from roll-up contracts, enabling a rapid increase in network capacity. Without switching to proof of stake first, this would not be viable.
So we are going to discuss a little bit about what could be the kind of steps or what could be the ways that you can be a blockchain developer. And before going into the discussion of what are the ways for that, first we must need to understand who is a blockchain developer itself, because there are quite different terms that being used. Like some of you maybe have heard about smart contract engineer or blockchain engineer or blockchain developer. So these are different terms terms that's being used interchangeably. So along with it, we must need to know the main understanding and the terms that are being used and what is the meaning of being a blockchain developer. So moving forward, we are going to discuss a kind of what could be a type of blockchain developers, on which side you can focus, and then you are going to explore some of the steps that how you can become and how you can be planning your journey to become a blockchain developer as your career. So we'll be moving forward in terms of also just exploring a little bit about the market. There was the salary range that's being provided and a kind of, you can say, obstacles that is for someone who wants to learn blockchain development or who wants to learn this technology. So this is a kind of our whole agenda that what we will be discussing in our today's session. So first of all, let me first move forward with the kind of questions that who is a blockchain developer. So initially, what I would say, whenever you want to achieve something, or whenever you plan to get yourself into as a part of your career, as a part of your next role, first of all, you should understand some of the questions, and you should ask yourself a few questions: who, what, and why you want to be to be that position. So that's very important. First of all, you do try to understand who you want to be, like who is a blockchain developer, who is a kind of position that you are looking for. Then what are the ways to become that specific professional in the market, and then why also you should know that why you are looking forward to be yourself, be a part of this industry or be a part of this domain. That's quite very important questions that you should ask yourself, not going to answer anyone, but ask yourself and satisfy yourself with these answers. The reason is that is going to compose your whole goal or whole motivation for your whole career journey. In the terms, let's say, if you know that why you are planning to be a blockchain developer, what is your reason to be in this industry, what is your main motivation, you will be stayed on the whole track, and you can plan these things in a real way, or you can say in a kind of, you will have some timeline that you wanted to achieve, that you wanted to be in this domain. So make sure that you do ask these three questions before getting into any XYZ technology. It's not just related to blockchain. It's a general kind of three questions that I usually make sure that I am clear enough why I'm going into this direction. So that's just my personal opinion, or a kind of my personal belief that I should know that, okay, why I wanted to be there and what could be the ways and who I am going to be. So as a part of this whole series, we are first going to explore the questions that is, who is a blockchain developer? So starting from, if you are just discussing about a blockchain developer, it is presumed for sure that you are well versed with the technology itself, or with the working of this technology, why it exists, why it came into the picture, what is this buzzword everywhere, and why this is booming a lot. So as a whole, it's being assumed that you should know what is the blockchain technology. So if you talk about the technology itself, the core functionality, or you can say the core features of it, you are well aware of it. So implementing and designing that whole blockchain network is something that a blockchain developer do as well, like how you design a whole network, how you implement and support a network also, and then coming towards creates and optimizes blockchain protocols. And the very last thing that you go with is how you develop dApps and smart contract applications on the blockchain network. It's very important to understand those terms. If we talk about the dApps, dApp is a kind of like distributed applications that we use these terms quite often when it comes to blockchain developer. You may have heard from someone like, okay, I'm looking for a dApp developer, someone who can develop a dApp for me. It's something like we are talking about applications that needs to be developed on the top of blockchain technology, and it could be any blockchain, like public or private, any blockchain. So that is very important. If you understand these kind of acronyms and you really know the meanings of these acronyms, that's also very that's something that matters a lot. So dApps is something that you are going to have those applications built on top of blockchain, and that's one of the part that blockchain developer do also. And then come towards the next part, that how do you develop these dApps using like writing some smart contracts using any programming languages that we'll be exploring in the few slides afterwards. So coming towards like how you write a smart contracts, what are those kind of programming languages that is needed for you to know and to be well versed with this, so you know the how you are going to make it technically feasible for your whole career and to get your next role. So coming towards what could be the type of blockchain developer you can be, because what we discuss is quite a lot of different things. If you notice, the very first part that I mentioned was that how you can like designing the network, implementing and architecturing the solution. That's one part of it. Then we talked about another aspect of how you can like security and optimizing the whole app development, and then writing the smart contracts and developing the applications itself. So if you focus on the sides, it's being divided into two sections. One is a core blockchain developer who actually works into the underlying blockchain architecture, or you can say working on the consensus algorithm, that how these things going to be working. So that comes under the core blockchain developer. And then another part that's important is the blockchain software development, or you can say dApp developer, who is going to develop the application that's being used or that's being built on top of that blockchain technology. So if we talk about the whole blockchain development cycle, or you can say the layers, is you have one blockchain hosted on which you are going to develop your blockchain application. So first, you should be clear enough what kind of blockchain that you are going to adopt. It could be a public blockchain, it could be a private blockchain, or maybe a kind of hybrid somewhere, consortium or hybrid blockchain. And then coming towards finding the right talent for the type of blockchain that you are working on. Then that's the next part of where software developers, or where you can say developers in general, lies into. That's the next part of blockchain developers, that how you're going to write those smart contracts or kind of chain codes, and how you're going to make those applications work on top of blockchain. So when we talk about first thing, that is core blockchain developer, they are the one who are going to work on the core features of the blockchain network itself. So if you focus on the category of the blockchain that you will be selecting, let's say if you are going to go for the public blockchain, for Ethereum or kind of any application that you wanted to host on public blockchain, so that's a kind of different thing. You know your consensus, you know everything that's already running into the network. But when it comes to a private or enterprise-based blockchain, you have a quite different architecture. It's quite bulky, it's quite vast. Like you have to work around what kind of network you wanted to build into, how many organizations will going to participate into the network, what will be the consensus mechanisms that will be used, then how you're going to set up, like let's say if you're talking about Hyperledger Fabric, you have to architect the whole thing, like participation of endorsing nodes and CAs, and let's say how its whole MSP is going to work, and then the consensus mechanism, and how it is going to be committed to the ledger after going through this whole endorsement policy. So there is quite a lot of network part that needs to be done in terms of private or enterprise-based blockchain, which is not that much required when it comes to any public blockchain. So that core blockchain developer are the one who is responsible for working on those side of how these network is going to be built into. So if you just explore a little bit about Hyperledger Fabric network administration, that's something, a separate role that's being required for the organizations who develop on top of Hyperledger Fabric. It's not that they expect the programmers to do the whole networking and whole architecting at the base layer, but they expect the network network part is something that they expect someone else who have the required expertise in that aspect. So that where is the core blockchain developer come into, like when you talk about the architecture or working on this consensus algorithm and how you're going to set up the whole blockchain network. That is one part of the blockchain developer that you can be. Now, the next part, that when it comes to software development side, this is where the programming comes, like how you are going to develop your application that is going to work on the top of that specific blockchain. Let's say if I decided that I wanted to build an application that is going to be hosted onto a public blockchain. So it's a public blockchain application. So I want a dApp for that. Like I want to build an application. So definitely you don't need to work onto that underlying core blockchain layer, setting up the network and these kind of stuff. What we usually do is that we directly go towards writing our smart contract logic. Once we understand the whole architecture, whole flow of our solution, that okay, what kind of smart contracts we are needed, at what stage we are needing that smart contracts, and what is the whole flow of information from one end to another end, and who are the participating entities and all these stuff. Once you have a very clear idea of that, you go into developing those applications in terms of writing your core code, core program into the core programming side. Then it comes to writing your smart contracts, and first you're going to use a test network, let's say. So you're going to host it on a kind of like test network for Ethereum, or then you are going to move into a mainnet. So that's a kind of things that's mostly on the side of blockchain developer, that how you are going to write your code, compile it, and deploy it itself onto the blockchain network. So coming towards that, what kind of responsibilities and the usual and the major responsibilities that needs to be covered by a blockchain software developer is smart contracts, writing the smart contracts, or you are required to develop the whole distributed applications. So the reason of mentioning this develops the distributed application is that just writing the smart contracts is not something you do only. You should know that about what will happen when you are going to deploy your network, and how you're going to check up all these gas fees and a lot of stuff that happen there once you deploy your smart contract onto the blockchain network. So that's where this blockchain software development come into. And then the last part of it, that how you work on this front and back end application. So we have a kind of some middleware APIs on which we work. Let's say if we are talking about specifically Ethereum-based development, we use a web3.js to interact with our smart contract and to talk to our front end also. So that is the library that you are expected to write the code and know that how you're going to interact with these two layers and act as a middleware, and how you're going to write that specific kind of HTML code which will link to your smart contracts easily. And the same thing that follows if you're talking about any other blockchain, let's say in terms of private blockchain. So in Hyperledger Fabric, when we are developing an application, for that middle layer specifically, we have different kind of SDKs that we use. That's being provided, let's say, by a Fabric SDK. So you are bound to be use like kind of Java SDK or Node SDK or any kind of new SDKs that being provided to them. Let's say Python is in line as well with them. So these are a lot of things that's also involved, that how your middleware will work to talk to a front end for your blockchain-based application. That also comes under the blockchain development or kind of how you're going to work as a software developer or the core technical team for your blockchain development side. So coming towards that, how do you become a blockchain developer? Now, that's not a question that I am going to give you rigid answers on that, and that's something that you should follow. But I believe that, as I started in the earlier part of our video, that you should know answers of these questions by yourself. How you're going to do that, or what you want it to be, and who you want it to be and what are the ways to be at this stage. So when it comes to how do you become a blockchain developer, so there are a few things that's being mentioned here. It's a few things I'm mentioning because it could be more than that. It definitely depends on the type of role that you are looking into, or on the type of organization that you are planning to like join in or targeting to be the next employer for them. So it's quite you can say quite varied options that how do you become a blockchain developer, but that's one of the, you can say, core answers that's everywhere if you found the ways of being a blockchain developer. So the very first part that's very important is the programming language, because as we discussed, the part of being a software developer is that you should know a kind of programming language of writing the code into the blockchain, into this blockchain whole network. So some of the programming languages that's being mentioned here, it's like Java, C++, JavaScript, Go, Python, and C#. So as a whole, I would say that is very important for being a blockchain developer is you should be well versed about the basic programming paradigms and how a whole object-oriented programming work, like the base pillars of object-oriented programming. The reason is that's something quite similar when it comes to those programming languages. So if you talk about any of those programming languages, it's not something that you are expected to know all of them. Definitely, no one is not expert in all of these programming language. But if you are well versed with any one of them, or let's say any two of them, you are expected to write your code or understand the main you can say main rules of writing any programming language, because you are already well versed with any one of or any two of them. That's very important part, that this is the core of a programming language that you should know. Now, how it works into writing a blockchain-based development, it's something that you are going to learn when it comes to any kind of blockchain development course or any kind of session that you will be joining. So that's something that you will be learning as an advanced aspect of it. But the base, if you know, you are that's going to help you a lot in terms of your next journey for the blockchain development. So coming towards the side of writing programming language or the side of software development on top of any blockchain application, there is also one programming language that started with the smart contracts or with the existence of Ethereum. It's Solidity. So Solidity developers are something that they are exclusively expert in writing this Solidity code or Solidity smart contracts. That is being said because Solidity itself is a contract-oriented language, okay? But if you just get yourself into, or if you just go through a little bit of how it works or a journal view of it, you will notice a lot of things that is very common and a lot of concepts that is very related to object-oriented programming. Like if you talk about how you create a class in object-oriented programming language. So that is the same thing that we follow, like how you create a contract in object or in Solidity itself. Then we have few of the concepts that's very much similar to it. We have inheritance in contracts. We have abstract classes, interfaces. Then we have a kind of aspect that how you encapsulate things, like the encapsulation aspect of it. So a lot of things, how you use a constructor also. So there are a lot of common things that is very much similar to what we already know in object-oriented programming language. So for those of you who are a kind of confident or kind of comfortable with any of the programming language that we just discussed, you will be able to understand Solidity very much easily. One of the different thing that you will find in Solidity is that how you are going to play around with a kind of wallets with a kind of addresses, how it is maintaining, connecting to a wallet or maintaining an address like say smart contract address itself, and then how it's going to hold some ethers. So there are a lot of things or some of the terms or keywords that is different when it comes to Solidity. And obviously it is expected to be, because that is something that makes it unique. So these are the things that is different when it comes to Solidity based programming language. So if you are comfortable enough in writing Solidity based code, or you can say you are well versed with any of the programming languages that is in OOP, that's object oriented programming, you will ace the Solidity side very easily. So you can start understanding the concepts and writing those contracts in kind of Remix IDE, that is a browser-based tool. You don't need to install anything, and you can just start compiling and trying out your first smart contract very easily by just installing a kind of like MetaMask wallet or something. So that is the very core part of blockchain development side. First is the programming language, and then the very next part that I told you already, that is fundamentals of object-oriented programming language. So we know that how this is related to a blockchain-based development, that how you write a kind of functions, how you get the details for your users, and how you use some functions to send and receive payments, and let's say how you create an abstract contract, or there's a kind of how you write some interfaces for your contract. So some very of the concepts that we already know in object-oriented programming language, it's quite, you can say, similar to what we have in Solidity. Then we have a kind of flat and relational databases, or you can say that to understand the main concept, that how that RDBMS work or the flat databases work in terms of, if you know this kind of file storage or data storage, you will be easily understanding that how we are talking about the importance of blockchain technology itself, and how important this technology itself. The reason is that if you talk about blockchain-based technology as a whole, it's just a kind of data structure, or you could say a technology which works on storing of data, that how do you store data, and then the architecture or the flow of storing the data, that is how it makes it different, that how you're going to store it. Like either it's in a distributed network, either it's in a kind of, you have a ledger that is decentralized, there is no central authority. So these are some of the things, if you understand the main concept of flat or relational database, you will be easily understanding these kind of things about data structures and how it's being storing this data in terms of blockchain, and how it is unique to any other databases or any other data structures also. So one of the major things also that's written here is that you have to have some understanding about data structures, like let's say stacks, linked list, queues. So these are some of the data structures that we have. So if you understand some of them, that's very important, that it is linked to blockchain in the way that blockchain itself is also a chain of blocks that is linked together. Like it's a kind of linked list, and every block is containing the hash of previous block. So it is chained together. So kind of it is linked together. So it works in the same way that we have linked list. So that's one of the reason, if you understand those data structures, the way how blockchain works at its core of a data structure, it's going to be very easy for you, and you will be able to understand that how this works in a kind of data structure perspective. And then about some of the knowledge of web app development. So that's a very common thing that when you talk about any kind of development side. So if you know that how web and mobile application works and how you create these applications. And apart from it, because the concepts that, let's say if you create a mobile applications and you want to expose some APIs to get data onto a mobile application, that's something very much same that we do in blockchain development also. So these are some of the concepts that you are being expected to know when it comes to becoming a blockchain development. So the very last part of this this points that how do you become a blockchain developer is the peer-to-peer networking. That's something that I already mentioned in the type of how you understand the core concept of blockchain technology in terms of storing the data. And then it comes to the networking side, it's really important. Like, let's say those of you who are coming from, let's say, a very old and very basics of computer science, you must have heard about client-server architecture. So what client-server architecture do? We have a server to which all the clients report to. For any of the requests, for any of the things, whatever being accepted or whatever being provided by the server, those clients receive and work on it, and they will be able to perform next steps on it. So client-server architecture is something that is centralized, like we don't have any relation with one client to another client, but all of those clients are linked to one server, or let's say more than one server, but those servers are the one who is controlling and who are the managing authority. But when it comes to a blockchain-based system, we don't have that aspect of centralization. It is a core decentralized network that's being also said as peer-to-peer networking. Why? Because all the peers talk to each other and can see the transactions, whatever others are seeing also. So that's the core part of blockchain development side. If you understand those terms, if you understand that how these things work, that is one of the major thing. And then we talk about some of the acronyms that's very important. Like, let's say that is P2P. And one of the things that I mentioned earlier is dApps, related to distributed applications. That's also very important. And very last, third acronym that I wanted to mention is DLT. So what is DLT? DLT is distributed ledger technology. So if you talk about a blockchain-based technology, or you are trying to understand this technology as a whole, you are expected to know that, okay, what is DLT itself? Because it is a very important question. Most of those who are just newly entered into this field, they know the core, they know the very advanced level of blockchain, but they are not well versed with this term that's said as DLT. It is a very important term. If you just focus on this term, it's an umbrella term. Like, we have a lot of different technologies under DLT, and one of them is blockchain technology. So blockchain is a DLT, okay, but we have other technologies that comes under DLT as well. Let's say we have hash graph, we have directed acyclic graph, that is DAG. Then we have, let's say we have another technologies that we work into. We have Hedera hash graph and blockchain, and many of those technologies that comes under DLT. It's very important to understand that the core of DLT is the ledger is distributed. Like, it's going to work in a decentralized way, in a peer-to-peer manner. But how it's going to store the data, like the storage of the data, it's different. Not all of those technologies store the data in blocks. So it's not all DLTs are blockchain, but at its core, the blockchain is a DLT itself. So that's a very broad and umbrella term that you should know as being a potential blockchain developer. Make sure that you are clear enough about these terms and you are well versed about where and why you are using these terms. So these are some of the prerequisites that we discuss, that, okay, how you want it to be, how you do becoming a blockchain developer, what is a blockchain developer itself. I believe at this stage of this session, you are clear enough about two of this. What you want it to be, like who is a blockchain developer? So who is what you want it to be, like what could be your next role, and then how do you become a blockchain developer? So these are, as a whole, is just a core steps. And then you can extend your research, you can extend your plan and make your, you can say, whole journey that how you wanted to reach a specific goal in terms of becoming a blockchain developer and getting yourself into this whole ecosystem. So let's move into the very next step that says the very first step. If we have got all our prerequisites, that's clear. We know what we want it to be. We know how we are going to be at this stage. So the very first step, if you notice of this whole system, is the first thing that you understand the basics of blockchain. So to whoever usually asks me this question, I would say that as a whole, that's very important to you to understand and to go backwards to the point where this technology started. So for the blockchain, if we talk about the very first white paper, or you can say one of the white paper that started gaining the traction for this blockchain-based technology is Bitcoin. So what you do, you go towards this Bitcoin white paper and try to read it and try to grasp the whole concept, what's being written and why it came to in existence and how this technology played an important role in the whole in this whole system that's being proposed in that white paper. And that stage, I wouldn't expect you to be a master of blockchain technology and even to be clear of all the terms that's written there. But after reading that specific white paper, you should be just clear enough what is this technology, what is the potential of this technology, and either I am interested or not. Like let's say either I am convinced with what this technology has done to this whole payments ecosystem and everything. So if you are a little bit clear enough at this side, you are very good to proceed further. And then what you do, you proceed further with about understanding the core terms or core concept of blockchain technology. Let's say we have different types of blockchains. Public blockchain, private blockchain, then we have hybrid blockchain. So coming towards understanding the terms, if you understand the base term of blockchain, then you move forward with, let's say, public blockchain, that is Bitcoin. And after going towards Bitcoin, you go and check in the history, the next step and the next revolution came into the terms of Ethereum, how Ethereum came into, what was the reason for that, and how it changed the whole game of this blockchain ecosystem. So there you are going to explore a lot of things in terms of this blockchain-based technology. The reason of that is that with Ethereum ecosystem, we had a lot of things that came into the picture which was not there earlier. We got the way that how you can automate your business process in terms of those smart contracts. And then using that smart contracts, the scope of this blockchain technology extended and it is being explored that you can use this technology out of this payment ecosystem or out of this financial services. We have a lot of, you can say, potential of using it in different ways, or you can say in different use cases. So there come the potential and the power of this technology. And if you explore a little bit of the whole journey of Ethereum, you are going to find a lot of things that's very interesting. The tokenization aspect of it, the mining process, that how it changed up to the latest trend that we have in now in 2022. So that's very important part of the whole journey of learning these core of this blockchain-based technology. And then coming towards the base, let's say hash, that how this cryptographic hash is used, how the system is secured, what's the kind of encryption that's being used. So you can go through and play around with some of the, you can say, demos and illustrations that's been provided using that how your data is encrypted, how you cannot change a block and it will break the chain. So a lot of things that you can explore at this step. And you know, okay, there is some mining that's being provided, some consensus that's happening, and the reason of that consensus also. And the next part of knowing, after knowing those kind of terms, is that how you explore these things, let's say Ethereum, Hyperledger, Hashgraph, or Corda, R3 Corda, that's very important as well, and other solutions that is built on top of layer 1 solutions. That's, let's say we have a lot of layer 2 solutions into the market now, but that's another very extended form of blockchain. So as a base, what we do is that you explore, starting with Bitcoin white paper, then you move toward Ethereum based blockchain, and then you go and explore a little bit of Hyperledger Fabric. And if you are at the stage of understanding Hyperledger Fabric, you can look up into the R3 Corda as well. So a lot of things you are going to explore in this whole journey, and you will going to understand the basics of this blockchain itself. So if you talk about this whole steps that we have in this whole system, in this whole systematic way, it is started from prerequisite. If you are done with prerequisites, we are now moved towards step 1 that we have already done, that says the concepts of blockchain. And the very next stage is that you understand the economics behind cryptocurrencies and blockchain-based technology. So that's the part that is very important. You understand the whole economics in the term of the usage of blockchain technologies in crypto world, and a lot of it on the side of how it works in terms of issuing some kind of tokens, and then we have token standards, how you write these tokens, and the important and the and you can say how the price is, how you're going to increase your price for tokens. And then we have the next era that we know that right now we just passed is this NFTs, that how NFTs came into the market and what is the best use case of it. So a lot of things you are going to explore in terms of security, that says hashing, that says the kind of hashing algorithm that's being used, and the digital signatures, knowing that how this works as a core. And then the consensus mechanism also, let's say proof of work, proof of stake, why it's being used, or why there is some transaction that being happened from proof of work to proof of stake. Knowing the benefits and disadvantages for each of them, it's very important also. So that's one of the things that needed to be on the side of, you can say, more into the side of security, or more into the side of technical aspect of blockchain. The other part is that the economic side. On the economic side, we have the understanding that the miners, or you can say the validators who validate the transaction, are being incentivized. So it is very important for you to understand that how you are going to be like, is there some calculation that's being happening? It's something, some halving is done, and after that, what's going to happen if it's finished, the block reward is finished, so what's going to be happen with Bitcoin? So that's some of the questions that if you explore, that's going to have some, you can say, some interesting facts that you are going to explore in this whole journey. Along with it, it's very important that you try to understand about private blockchain also. If you are exploring it, try to going to as a whole, not just go through towards public blockchain and you don't know the difference between private and public. So if you're talking about private blockchain, you should try to explore a little bit what happens with the validators who validate the transaction in a private blockchain. So who is being rewarded, what kind of reward is being given. So you can read out some of the use cases or some of the success stories and case studies that's been published to, let's say, onto the official website of Hyperledger Fabric or Linux Foundation, or official website of Ethereum Foundation itself. So a lot of things that you are going to find out on their own official website. And for further, you can say, latest up-to-date trends and happenings into the industry, you can watch out to some of the videos, let's say, and videos in terms that what's being happening and what's being announced by their like say co-founders, founders, or any of the speakers who participated into the conference, because that's also very one of the interesting part of the conferences. If you join that or if you follow some of the blockchain latest conferences, some of the very biggest, you can say, announcements or biggest change that's been happening into the ecosystem. They announce usually there into the conferences also. So you can follow up to the conference to understand and to, you can say, follow the trends, what's happening into the industry as well. So the very next step, that is how to understand how cryptocurrencies work. That is also very important. The reason is that when it comes to the blockchain-based ecosystem, it started with the very first use case is the financial use case, is how you can eliminate a middleman and do some transaction peer-to-peer. Let's say Alice and Bob, they don't need anyone in between and they can do the transactions without any one of them. So that's very much important to know that if we are removing the middleman, who is going to do our transaction then? Definitely, we do have at the core, we have this blockchain based system, let's say Bitcoin, who is going to do this transaction for us. And if you just go backward in terms of the middleman, we are going to have some validator or miner who's going to mine our transaction. But a lot of things that are changed when it comes to peer-to-peer transaction when it compared to the traditional and current banking system or financial system that we have. So that's very important to understand how this cryptocurrency system works. If you send the money from one account to another account, let's say in terms of ethers, or not only in ethers, if you are trying to do some transactions and you are having, let's say, some tokens or something, then you will be able to do this transaction very quickly, and you will be able to understand it very quickly how this thing is very different to the traditional system that we have. So that is also one of the very important step of this 4 steps or 5 steps journey. So you start with the concepts of blockchain-based technology, and then you understand the economics behind it, in which you explore the kind of like security aspect of it, the cryptographic algorithms that's being used, and who will be rewarded and how the reward will be done, and then you understand that how these cryptocurrencies work, and the last thing is that you're getting on some hands-on experience. And then when it comes to now at this stage, at the 4th stage, I believe you have a clear idea about the technology. You know the strong use case of this whole technology so far that we have. You are well versed with the technical terms that is being used in this whole, you can say, in this whole technology, or what kind of consensus or encryption or encryption algorithms or mining, why it's being happening, and the whole flow. Okay. And if you are clear enough at this stage, you are now able to getting yourself onto some hands-on or onto some coding aspect of it. So for this kind of writing some programming and some smart contract, you are now able to start your journey as a blockchain developer. So this stage is very important for a kind of how you are going to select what kind of programming languages that you want to be, like what kind of blockchain development you want to be. Let's say it's private blockchain, public blockchain, and then you will decide that, okay, I want to write a smart contract, or I want to write a chain code in Hyperledger Fabric. That's also the choice that you made initially. And then you write your smart contract, and you know that, okay, if let's say you are writing it on Ethereum-based blockchain, you are going to publish it on Ethereum-based network. So let's say in terms of test network or in terms of mainnet, you can publish it on the Ethereum-based blockchain. And then let's say one of the major things that's written into the whole journey, what I appreciate, it's not that you do the work from your end and you expect the things to happen like magically from the employer end or from the end of hiring you. What is the best way is that if you make something, if you have coded something, even it's a very small application, try to show off to others that what you have made. By showing off means that you can convince other that you have the right talent that is required for this specific programming language. It could be in any way, like it could be like either you go for having your own GitHub profile, maintain your own GitHub whole GitHub portfolio that you can provide to others. So that's the kind of all your programs they're written. You have all your files that you can provide to others just to know that okay, what kind of smart contracts that you can write. But also you can write some articles out of it. Let's say if you are writing a code in Solidity programming language and you came up with an issue of how you're going to, like, you explored some different ways of error handling. Like you have different functions in Solidity, right, for error handling. And from your own experience, you find out some amazing way of doing error handling in Solidity that saves some gas fees, and you believe that's a better solution out of what you have been already being provided over the internet. What you can do, you can write a complete whole article on it on the basis of, okay, this is my personal finding in my whole journey. I found out this is the best way, and I encountered these issues, and to resolve this kind of problems, I tried fixing it in this way. I wrote this code, and that's how it worked. So what will happen? Others will know your problem solving skills. Your skills of writing a good and solid smart contract, that's very important. So never underestimate the line of code that you have written or the application that you have created. It might be very small for you, it might be something that's not convincing for you, but for other, or let's say to others that who are looking up to as a candidate for you, as a candidate to you, maybe it's going to be something that's very big for them. So try posting whatever you have learned, whatever you have made. You can also do some participation in hackathons. Let's say you can participate and team up with others and create some very, you can say, convincing and solid application in a hackathon. That's also going to add on a lot in your portfolio, and that's also it's very valuable when it comes to being this whole blockchain development journey. So it's not something that I would say only in blockchain development journey, but for any of the development side, it's very important that until you create something, you are not going to learn it in that way. So try getting your hands dirty as early as you can. And then once you are at this stage that you created a solid application, you can just go and post it somewhere and create and maintain your own portfolio so that you will be able to portray to others what you have made. Okay. And then that is very important again. I would say the whole blockchain ecosystem or this whole blockchain based technology, it's evolving very fast. So the developments or the happenings in this industry, it's very quick that you don't know that when what will happen. So the very important part is that you keep yourself updated with whatever being happening. It's not about just keeping yourself updated. Let's say who adopted Hyperledger Fabric for their problem, or which bank adopted R3 Corda and they are working on a solution with partnering with, let's say, Swift is now working with blockchain-based technology. It's just the high level that you should know. But at the core, you should be knowing what's happening inside of this blockchain industry itself. One of the very common and latest trending news that we had in the past few weeks is the merge that happened in Ethereum from proof of work to proof of stake, and how they merged this whole layers in the Ethereum ecosystem. So the reason of understanding and keeping an eye and keeping yourself updated is that this technology is evolving very fast, and even the solutions and the startups that's being built into it, it's quite you can say quite quick. You cannot expect anything to happen maybe into the next few weeks, but there's some very amazing happenings or amazing startups that's being built upon on top of, let's say, any financial ecosystem or for any industry. So try to keep yourself updated and how you do that. So it's up to you. You can follow some of the latest trending articles that's publishing some news on blockchain, or you can also just find out some of the solid connections on LinkedIn and get connected with them, follow them on Twitter, so that you know the latest news, what's happening there. And that's one of the reasons that's important, that you visit and write some articles, visit the blogs as well, and be a part of this ecosystem. Always make sure to put your input, to add your input wherever you feel you can. Let's say if today, after today, you know that, okay, I wanted to be a blockchain developer, and you are looking for some of the articles, and you have a quick thought that, okay, no, this is how it should be. No, I believe that this ecosystem is like growing, so scalability is something that's very important or something. You can put whatever you know and whatever your thoughts into a comment. Don't ever feel shy, because that's how you are becoming to a part of this whole ecosystem. Now, the very important part is what we will be discussing next, because how you become a blockchain developer, we discussed it. And then comes to what kind of obstacles do you face when it comes to learning blockchain-based technology. So coming towards the part is that how difficult or easy this programming language is, something that related to what kind of issues you face. Okay. So first of all, that's very common, and I believe it's most of us face this issue, that the outdated content. Let's say if you are working on Solidity-based programming language, and if you are reading and following an article, but it was written for a very old version of Solidity compiler version, but you have followed the whole exact program, and your program is not working on that latest version, because maybe something has changed and they've made it work in another way for the latest version. So this is very important. The content that you are following must be latest. It's not a very old content that you are following, or it's not something that you can say already outdated. Okay, so that's one of the obstacles that we would say into the Solidity or into the blockchain based journey, is that the tutorials you follow or the content that's being written there, maybe the issue is being resolved already, but you are following some content, some tutorial that's very old. And one of the second aspect is very common again, is the lack of quality content. Okay, so the major thing is that most of the places where you will see that, okay, you will be a blockchain developer in 6 weeks, in 2 weeks, you will be a smart in 4 hours videos. So a lot of videos that you will be able to see that. It's not that they will not give you the right content, they will definitely give you. But the quality content is very important. And also, after getting this content, what you do afterwards is also very important. So the investment from your side as a learner or as a potential developer in this field is still there. Don't just expect things to happen in a magic way once you follow a tutorial and you believe that, okay, I created this application, now I am a master and I look forward to the opportunities and I believe I will be getting hired somewhere. Hopefully you will be, definitely, but how you can make your place in the industry is that you try to create something and then make some updations on it. Let's say now we have a lot of layer 2 solutions also. So try to explore many of those solutions, or many of those you can say some of the SDKs that's into the system, or some of the tools that's now just came in this whole blockchain based development side. So that's also very important for you to learn from a quality content, not from old content. Now that's another very you can say one of the very attractive part of blockchain based development is the salary of a blockchain developer. So coming towards the average how much a blockchain developer earns is something around if we talk about in USD, it's different definitely. So it starts from 100K per annum. Okay, it's just a starting. I wouldn't say it's an average, but it's more of a start. But it definitely depends upon the size of company that where you are looking for and where you are aiming to. Let's say for a startup, it's going to be a different, or a kind of a big organization is going to offer you a different rate. But when it comes to blockchain based development to any other core tech development, let's say .NET or C Sharp or even just Java as well, we have a slight difference in the range that of the salary that's being provided. So the blockchain based developer or blockchain developer is usually highly paid. And one of the core reason is not that the technology is booming only, but also the supply and demand thing. When you talk about the blockchain ecosystem or blockchain based developers, the supply itself is like very small and the demand it's like very huge. So if we talk about the demand outgrows the supply a lot. So demand is growing very rapidly, but the supply of the development or the supply of the developers is not very high. That's why it's one of the highest paid when it comes to any of the development side of into this whole software development side. So which companies and how companies are using blockchain-based technology? Again, that's a very common thing. That's IBM, Microsoft, and they are using in a different way. Let's say for trade finances, and we have some countries that they are using. Let's say Australia and Estonia is very famous. You can explore a little bit about Estonia's case study, how they have revolutionized their whole health ecosystem, the smart card that they have for their citizens or for the residents. And then we have a lot of things that's also evolved in Dubai also with their Smart Dubai initiative. They have gone paperless with the initiative of paperless Dubai. So a lot of things that's happening in different regions. It's not just one or two countries. Most of the countries, China has also used this technology in a lot of different ways. So you can explore with how these technologies work in different countries and different companies, just to have a better understanding of the potential of this technology. And if you are convinced enough that, okay, this technology is very booming and the support from the government is very high, then you are satisfied what you are doing and where you are investing your time. That's very important. And you are motivated enough, you are going on a right track, you will be able to do it very easily and very happily. So that's a little bit of what we can discuss in our today's session related to how you can be a blockchain developer, who is a blockchain developer, and what are the steps to becoming a blockchain developer. So this is about our today's session, but we have different courses in our Simplilearn course as well, in our Simplilearn training programs that you can follow and that you can look up to. So you will be able to understand better of what's being provided by Simplilearn as for this blockchain-based technology. So I wish you all very good luck. Thank you so much for sparing your time for this video. In case of any comments and questions, just feel free to post it on this Simplilearn YouTube channel, and the team will be able to get back to you on the queries that's being posted. Thanks a lot for joining in. We'll come back for another video.
Now let's take a look what's in it for all of us today. We will be talking about what is Ethereum, the features of Ethereum like cryptocurrency, smart contracts, Ethereum virtual machine, decentralized application and its uses, and decentralized autonomous organization. We'll be also looking at applications of Ethereum and a demo on smart contract deployment on a locally running Ethereum client. Now, what is Ethereum? Ethereum is a blockchain-based computing platform that enables developers to build and deploy decentralized applications. So basically, Ethereum is a platform where we can build applications which are not run by a centralized authority. You can create a decentralized application where the participants of that particular application are the decision-making authority. So here we can see Ethereum allows us to build and deploy dApp applications. Now, what are the typical features of Ethereum? Ethereum allows you to use its own cryptocurrency called ETH. It allows development and deployment of smart contracts. It provides you the underlying technology, the architecture, the software which understands smart contracts and allow you to interact with it, which is called Ethereum virtual machine. Then it allows eventually to create consolidated applications called decentralized applications, and also it allows you to create decentralized autonomous organizations. Now let's talk about Ethereum cryptocurrency. ETH is a cryptocurrency that runs on Ethereum network. Basically, it is the fuel which is running the Ethereum network. It is used to pay for the computational resources and the transaction fees for any transaction to be executed on a Ethereum network. Like Bitcoin, Ether is also a peer-to-peer currency. Apart from paying for transaction, Ether is also used to buy gas, which is used to pay for computation of any transaction you make on a Ethereum network. Also, if you have to deploy a contract on Ethereum network, you will need gas and you would have to pay for that gas in ethers. So gas is the execution fee paid by a user for running a transaction in Ethereum. Ether can be utilized for building decentralized applications, for building your smart contracts, and making standard peer-to-peer payments. Now, what is a smart contract? A smart contract is a simple computer program that facilitates the exchange of any valuable asset between two parties. It could be money, it could be shares, it could be property, or it could be any other digital asset which you want to exchange. These contracts can be created by anyone on the Ethereum network, and primarily the contract consists of the terms and conditions mutually agreed between the parties, between the peers. And the primary feature of a smart contract is that once it is executed, it cannot be altered, and any transaction done on top of a smart contract is registered permanently. It is immutable. So even in future you modify the smart contract, the transactions correlated with the original contract does not get altered, or you cannot modify them. So for the verification process, smart contract is carried out amongst the anonymous parties of the network without the need of a centralized authority. And that's what makes any smart contract execution on Ethereum a decentralized execution. It provides the transfer of any asset or currency in a transparent and a trustworthy manner. As the two entities are totally unaware, their identity is secure on the Ethereum network. Though the transactions once successfully done, the accounts of the sender and receiver are updated accordingly, and thereby it generates a trust between the parties who are transacting using the Ethereum network. Now, what happens in traditional system of contract? In traditional systems of contract, you sign an agreement, then you trust a third party, hire a third party for execution. Now, the problem is that in such an engagement, the data tampering is possible. Now, if we talk about the new smart contract, the agreement is coded in a program. Now, result is not verified by a centralized authority. It is verified by the participants on Ethereum based blockchain network. Now, once a contract is executed, the transaction is registered and it cannot be altered or tampered. So it removes the risk of any data manipulation or alteration. Now, let's take another example where Jack has given a contract of $500 to Elsa for developing his company's website. Now, the developers code the agreement of smart contract using Ethereum's programming language. Now, the smart contract has all the conditions, the requirements for building the website. Once the code is written, it is uploaded and deployed on the Ethereum EVM virtual machine. EVM is a runtime compiler to execute your smart contract. Once the code is deployed on the EVM, every participant on the network has a copy of the contract now. Now, when Elsa submits the work on Ethereum for evaluation, each node on the Ethereum network will evaluate and confirm whether the result given by Elsa is done as per the coding requirements. And once approved and verified, the contract worth $500 will be self-executed and the payment will be paid to Elsa in ethers. So John's account, the person who had gone into a contract, his account will be automatically debited and Elsa will be credited with $500 in ether denomination. Here we will now take a look. We will do a demo, small demo on a deployment of a smart contract. So in order to execute our smart contract, we will need two set of softwares. Ganesh and Truffle, and we will show you in the demo how to install these two softwares on your machine. Now we will be giving a demo on the following smart contract. This is a smart contract where we are writing a simple contract of a greeter. We have a variable called greeting, which we will be initializing using a constructor, and then in our demo we will be showing how you can change the value of the variable greeting using the set greeting method and read the value using the greet method. This is the other contract where we will be defining that whoever is deploying the contract on the blockchain network is always the owner of the contract. And then we have defined certain mandatory functions in order to kill the contract on the Ethereum network. So only the owner of the contract can kill it. Now let's talk about what is an Ethereum virtual machine. Ethereum virtual machine is designed to operate as a runtime environment for compiling and deploying Ethereum based smart contracts. Basically, EVM is the engine which understands the language of smart contracts which are written in Solidity language for Ethereum. EVM is operated in a sandbox environment. Basically, you can deploy your own standalone environment which can act as a testing and a development environment, and you can n number of times test your smart contract, deploy it, verify it, and then once you are satisfied with the performance and the functionality of the smart contract, you can deploy it on the Ethereum mainnet. Now, any programming language in the smart contract is compiled into the bytecode which the EVM understands. This bytecode can be read and executed using an Ethereum feature called Ethereum virtual machine. So basically, EVM machine understands the bytecode. So one of the most popular languages for writing a smart contract is Solidity. So once you write your smart contract on Solidity, that contract gets converted into the bytecode and gets deployed on the EVM. And thereby, EVM guarantees security from cyber attack. Now, how does EVM work? So suppose A wants to pay B 10 ethers. The transaction will be sent to the EVM using a smart contract for a funds transfer from A to B. Now, in order to validate the transaction, the Ethereum network will perform the proof of work consensus algorithm. The miner nodes on the Ethereum will validate this transaction, whether the identity of A exists or not. A has the relevant amount of balance to transfer 10 ether to B, and will validate the transaction. Once validated, the ether will be debited from A's wallet and will be credited to B's wallet. And during this course, the miners will charge a fees in order to validate this transaction and will earn a reward. Now, all the nodes on Ethereum network execute smart contract using their respective EVMs. Now, how does proof of work works? Every node in the Ethereum network has the entire history of all the transactions, the entire chain. It has the history of smart contract, basically the address at which the smart contract is deployed, the transactions associated with the smart contract, and also it has the handle to the current state of the smart contract. Now, the goal of the miners on the Ethereum blockchain network is to validate the block. For each block of transaction, miners use the computational power and resources to get the appropriate hash value by varying the nonce. Now, the miners will vary the nonce and pass it through a hashing algorithm. In case of Ethereum, it is the ethash algorithm. This produces a hash value which should be lesser than the predefined target as per the proof of work consensus. If the hash value generated is less than the target value, then only the block is considered to be verified and the miner gets rewarded only then. Now, when the proof of work is solved, result is broadcasted and shared with all the other nodes in order to update their ledger. If other nodes accept the hash block as valid, then the block gets added to the Ethereum mainnet blockchain. And as a result, the miner receives a reward which as of today stands at 3 ether, plus the miner receives the transaction fees which has been generated for verifying the block. All the transactions which are aggregated in the block, the cumulative transaction fees associated with all the transactions is also rewarded to the miner. Now, do you know, in Ethereum, a process called proof of stake is also under development, and it is an alternative to proof of work. It is meant to be a solution to minimize the use of expensive resources spent for mining using proof of work. Now, in proof of stake, the miner is actually the validator, can validate the transactions based on the amount of crypto coins he or she holds before he or she can start the mining. So based on the accumulation or the repository of crypto coins with the miner beforehand will give him the higher probability of mining the block. Now, however, proof of stake is not widely adopted as of now as compared to proof of work algorithm. Now let's understand the concept of gas. Now Ethereum virtual machine has a concept of gas, and why do we need it? So like we need fuel to run car, in the same way in order to run application on Ethereum network we need gas. Now what is gas? To perform any transaction on Ethereum network, a user has to make a payment, has to shell out ethers in order to get the execution done, the transaction done, and the intermediary monetary value is called as gas. On Ethereum network, gas is a unit that measures the computational power required to run a smart contract or a transaction. So if you have to do a transaction which is updating the blockchain, you would have to shell out gas, and that gas will come with a price in ethers. Now how is the gas fees calculated? In Ethereum, the transaction fees is calculated in Ethereum using the below formula. For every transaction, there is a gas and the correlated gas price. So the amount of gas required to execute a transaction multiplied by the gas price, you generate the transaction fees. So gas limit on Ethereum network refers to the amount of gas which is used for the computation and the amount of ether a user is required to pay for the gas. Now here we have a screenshot from the Ethereum mainnet where the cost of transaction is being shown. So if you see for this particular example transaction, the gas limit was 21,000, the gas used by the transaction was 21,000, and the gas price was 21 GUI, which is the lowest denomination. So 21 GUI into 21,000 gave you the actual transaction fees, which is 0.000441 ether, which is approximately 0.21 cents as of today's ether market value. Now this transaction fee goes to the miner who has validated the transaction. To understand the gas limit and the gas price in a better way, let's consider an example of a car. Suppose your car has a mileage of 10 kilometers and the price of petrol is $1 per liter. Then driving a car for 50 kilometers will cost you 5 liters of petrol, which will be worth $5. Similarly, to perform an operation or to run a code on Ethereum, you need to spend certain amount of gas like the petrol, where each gas has a per unit price called gas price. Now if a user provides less amount of gas to run a particular operation, then the process will fail and the user will be given a message of out of gas. And GUI is the lowest denomination of ether which is used for measuring unit of a gas price. Now how is Ethereum's mining different from Bitcoin mining? The hashing algorithm is the primary difference. The Bitcoin uses SHA-256, Ethereum uses ithash. The average time taken on Bitcoin for mining a block is 10 minutes, whereas in Ethereum it is 12 to 15 seconds. As of today, the mining reward for Bitcoin is 12.5 BTC, but for Ethereum it is 3 ethers plus the transaction fee, the accumulated transaction fee for all the transactions for a block. Now, as of 23rd July, the Bitcoin value was $7,667, whereas 1 ether stands at $466. Now here we have a screenshot of an Ethereum reward which has been given to the miner of the block. Now as you can see, here is the breakup of the reward: 3 ethers plus the total accumulated transaction fee of all the underlying transactions in this block, which is 0.0666 ethers. Now what is a decentralized application? Now let's compare it with our traditional applications, our traditional websites which are currently running. So for example, when you log into Twitter, a web application gets displayed which is rendered using an HTML page. Now the page will call an API to access your personal data, your information which is centrally hosted. Now it's a simple process. The front end executes a backend API and the API goes and fetches the information from a centralized DB. Now if we transform this application application into a decentralized application, then now when you will log in, the same web application will get rendered, but it will be calling a smart contract based API to fetch the information from the blockchain network. So the API gets replaced with the smart contract interface, and the smart contract will fetch the information from the blockchain network, which is its backend. And that blockchain network is not a centralized DB, it's a decentralized network where the participants of the network, the miners of the network, are validating, verifying all the transactions which are happening using the smart contract on the blockchain network. So thereby any transaction or any action happening on a Twitter kind of application which has been transformed will now cannot be claimed as a centralized transaction. It will be a decentralized transaction. A DApp, a decentralized application, consists of backend code that runs on a distributed peer-to-peer network. It is a software designed to work on an Ethereum network without being controlled by a centralized system, and that is the primary difference. It provides the direct interaction between the end users and the decentralized application providers. Now, an application qualifies as DApp when it is open sourced, its code is there on GitHub, and it uses a public blockchain based token in order to run the application. A token acts as a fuel for the decentralized application to run. DApp allows the backend code and data to be decentralized, and that is the primary architecture of any DApp. Now let's discuss what are decentralized autonomous organizations. DAOs is a digital organization that wants to operate without any need of a hierarchical management. It wants to operate in a decentralized and a democratized fashion. So basically a DAO is an organization where the decision making should not be in the hands of a centralized authority, but it should be in the hands of certain designated authorities or a group of designated people as a part of authority. It exists on a blockchain network where it is governed by the protocols embedded in a smart contract, and thereby they rely on a smart contract for decision making. All the business decisions are driven by the smart contracts, or we can say a decentralized voting system within the organization. So any organizational decision before being taken has to go through the voting system which is running on a decentralized application. So how it works? People add funds to the DAO because DAO requires funding in order to execute and take decisions. Based on that, each member is given a token on a percentage basis which represents the percentage of shares of that particular member in the DAO. Now those tokens are used to vote in the DAO where the proposal status is decided based on the maximum votes. So every decision within the organization has to go through this voting process. Now let's take a look what are the applications of Ethereum in real world and where it is getting used. So as we have seen with DAO, voting systems are adopting it. The results of the polls are publicly available where it ensures a transparent and fair democracy by eliminating voting malpractices. It is getting adopted widely in a banking scenarios and banking systems. With Ethereum's decentralized system, it is becoming very difficult for hackers to have unauthorized access, and it also allows payments on a Ethereum based network. So banks are also using Ethereum as a channel to make remittances and payments. Shipping. Deploying Ethereum in shipping helps tracking of cargo and prevents goods from being misplaced or counterfeited. So basically Ethereum is providing you the provenance and tracking framework for any kind of asset required in a typical supply chain. Now with Ethereum's smart contract, agreements can be maintained and executed without any alteration. So any industry which has fragmented participants is subject to disputes and which requires and digital contracts to be present, then Ethereum can definitely be used as a technology for developing your smart contract and digitally recording the agreements and the transactions based on those agreements.
So let's get started for a demo on how to deploy an Ethereum smart contract locally. So in order to deploy a smart contract, we will be first installing Ganache client, which allows you to host a local Ethereum client on which you can deploy your smart contract. So as we are working on the Windows environment, when we are downloading the Ganache setup, we can also download Node in order to install Truffle on our machines. Now, as the node has been downloaded, we will install node. So now node is successfully installed. Now we are going to install Ganache locally. Now we will run Ganache a little later. Before that, we will perform certain steps, or we can run Ganache and see. So once Ganache is up and running, I'll show you the interface, how it looks. So when Ganache is brought up, it automatically creates 10 accounts with pre-funded balance of 100 ethers. It is running on localhost port number 7545. Now, as you see, there is no transaction or anything which has currently happened. So the current block is 0, which is the Genesis block. There are no transactions and there are no blocks as of now. So there are no transactions in block which have been generated. So using this Ganache client, now we will be deploying our Greeter contract. Now, as we have installed node, we will be installing Truffle. Truffle is the utility which allows us to compile and deploy Ethereum contracts. Okay, now once Truffle is installed, we need to create a directory called Greeter. Now we need to run the command truffle. Now once we run this command, truffle by default creates a package structure which has 3 folders called contracts, migrations, test, truffle.js and truffle config. Now we will be writing our smart contract called greeter.sol and we will compile and deploy. Basically, our greeter.sol will be under contracts folder and we can our contract is created and it is lying under contracts folder. Now we need to add another file under migrations folder called as deploy contract.js. So we will name it as deploy contract. Now in this deploy contract, we need to put line of code. Now in this file, we are asking Truffle to deploy our newly created greeter.sol file. Now in the greeter contract, we have a constructor. We are initializing the greeter contract with a value hi hello and we are passing a gas value. So this gas is currently at a higher limit and we know that this gas value, the contract will get executed. But otherwise, you can also evaluate the gas value of a contract using Remix. Now, once this file is being saved, you go to the truffle.js and make the following entry. Now here we are telling Truffle that our localhost Ganache client is running on localhost at port number 7545 and network ID can be anything, though the current Ganache client is running on port network ID 5777, but we have kept it open that we can connect to any network ID. Now after this step, I need to go back to my command prompt and say truffle compile. Now, if you get this error, if we are getting this kind of error in Windows, then need to do one quick fix. We need to go to the users directory and rename truffle.cmd to truff. So I'll go to my C drive users update homing him just now here. Now instead of truffle, I have to say truff. Now there might be certain compilation warnings. We can ignore that. Now my contract is being compiled. Now I need to run the next command, truff migrate. At this stage, my smart contract is deployed and now you can see This is the step, this is the place where the contract has been called, and this is the transaction where the default value of my variable greeter has been set to hi hello. So we will see. Now I need to run command truff console to interact with my contract. Now as on my truff console, I can check at what address is my contract deployed. So my contract is deployed at address 0x37, which matches with the address 0x373. Now I need to check the default value which I had set while deploying my contract. So this is my value, hi hello. Now I can change the value to something else, because in my greeter contract I have a method called set greeting. Now when I'll be performing this action, a new block will get generated and the block count will increase from 4 to 5 because I'm making a change on the blockchain. As you can see now, a new transaction has been created. This was the gas used. This is the default gas price in Ganache, and block number 5 is being mined. Now I can reread the value of the variable. Now it will return me the latest value, which is change greet value. So this demonstrates how to use a Solidity contract, how to compile it, deploy it on a locally running blockchain network. You can connect multiple nodes to this Ganache client, and all the nodes should be running on the same network ID, should have the same network ID, but they can be running on a different machine. So here we can see all the other details, the block, the transactions which have happened. If I perform the action again, block number 6 has been generated, has another transaction associated with it, and I can get the latest value.
In this video, we will explore Ethereum mining and will go through some of the fascinating concepts and components revolving around it. First, we will have an introduction to Ethereum. Then, we will understand what is Ethereum mining. Then we will explore why should we mine Ethereum. We will look into the types of Ethereum mining. And then we will understand how the Ethereum mining process works. Then we will explore how exactly to mine Ethereum. Then we will discuss, will the proof of stake transaction kill proof of work? And then finally we will find out, is mining Ethereum profitable? So without doing much ado, let's get started with the video. Let's bring you up to speed on Ethereum. Ethereum is defined as a blockchain-based computing platform that enables its developers to build and deploy decentralized applications and make sure all the transactions are cryptographically secured in the network. Ether is the cryptocurrency of Ethereum, used to build decentralized applications, smart contracts, and make standard peer-to-peer payments. Ether basically acts as fuel for the Ethereum network. It tracks and facilitates all the transactions. So that brings us to what is Ethereum mining. In simple words, Ethereum mining is a process of creating and adding a block of transaction to the blockchain network of Ethereum. It uses the proof of work consensus mechanism for mining Ethereum. All transactions taking place in the Ethereum network needs to get approved by the miners. Miners is a community of people using a hashing script Ethash to solve computationally hard puzzles for successfully mining the blocks of transactions in the Ethereum blockchain network, which helps secure the network from attacks like hacking or manipulation of identity. Now let's understand why we need to mine Ethereum. The primary goal for mining Ethereum is to make money. Ethereum mining turns the act of securing the network into a relatively complex but profitable business. Also, miners receive a certain amount as a reward for mining each block of the Ethereum blockchain network, including the transaction fees paid by the users. Thus, Ethereum mining benefits each and everyone participating in Ethereum blockchain network. So, what are the types of Ethereum mining? Ethereum mining can be performed in three ways: Ethereum solo mining, Ethereum pool mining, and Ethereum cloud mining. In Ethereum solo mining, you will get rewarded only if you solve the puzzle and mine the Ethereum block first. Since here you are competing with many people and companies, you have to be very good at your work. Also, solo mining is only profitable when you have plenty of resources with you, like 100 plus graphics cards. And in solo mining, having so much equipment may use a lot of electricity and space, leading to high electricity bills, and not everyone has a considerable amount of area needed. Ethereum pool mining is the easiest and fastest way to get started with Ethereum mining. In this, you work along with other people together in a single pool, and if someone from the pool gets the hash code correctly, they share the reward among everyone in the pool. We should consider a few important factors before joining a pool, like pool size, minimum payout, and pool fee. Pool size determines the number of blocks you find in the Ethereum network, and it shares rewards. As the number of miners increases, the chances to get rewards also increase. Minimum payout is the minimum amount of Ethereum you need to mine before it gets credited to your wallet. And pool fee is the amount you need to pay to continue using the pool. This amount is percentage based on the amount of Ethereum you're mining. Ethereum cloud mining, you pay someone else with the equipment to mine Ethereum for you. You pay some amount of money as fees to them for investing their time and resources. And in return, they provide you with the reward they gain by the mining Ethereum. But this technique of mining Ethereum has some pros and cons too. Pros, you're not responsible for any equipment damage. You don't have to acquire all the necessary equipment and look for ample space to store it. You can sit back, observe the market, and enjoy the reward for your investment in Ethereum mining. Cons, if the Ethereum price drops, then there is no way you are getting your money back. The money you invested or the fees paid to the miner is lost. And you can't ask the other person to change the equipment according to your concern. Ethereum cloud mining is considered a safer way for mining service providers to guarantee a profit for the resource they have purchased. Now let's understand how the Ethereum mining process works. Ethereum mining follows a specific set of steps to function. Step 1. A user requests a transaction with the help of the private key of his digital wallet account. Then the request is shared worldwide with the Ethereum network. Next, the requested transaction is added to a list of pending transactions that needs to be added to the Ethereum blockchain network. Step 4. The miner then verifies and validates the requested transaction and perform a complex mathematical puzzle on the transaction data. Step 5. Once the request transaction is verified and it stores a copy of it in Ethereum, the process of proof of work begins for the respective block. Step 6. When the nodes of the Ethereum network verify that the checksum of the state of the miner's block matches the checksum of the updated state of Ethereum after execution of all transactions. Step 7. Only after that the block is added to the Ethereum blockchain network. Step 8. On successfully mining the block, it rewards the miner with some amount of Ether in their wallet. The block reward of Ethereum is 3 Ether. And step 9. The requested transaction is approved and credited to the respective wallet or wallets. Each transaction is mined only once, but every participant of the Ethereum network verifies it. This makes me curious about how to mine Ethereum. Tools you will need to be an efficient miner for Ethereum on your personal computer are an Ethereum wallet to store all your currency earned, GPU drivers or graphics card with a minimum of 3 GB RAM, a mining software suitable according to your hardware like GPU, and a compatible operating system, Windows 7 or 10 with 64-bit. Before getting started with mining Ethereum, you need to create an Ethereum wallet to store all your Ether. Trezor Model T and Ledger Nano are the most reliable and secure wallets in the market of cryptocurrency. Installing GPU drivers or graphics card after creating your digital wallet, you need to update all the hardware, that is, drives in your system. You can use two types of graphics cards. They are AMD graphics card and NVIDIA graphics card. Claymore is considered the best software for mining Ethereum on GPU drivers. Now, we need to follow a few set of steps to get started with mining. Step 1. Download the latest version of Claymore Dual Miner for the operating system. The latest version is Claymore 11.0. Step 2. Click on the latest version for Windows and download the zip file. Step 3. Extract the files of Claymore 11.0 to a folder on the desktop for easy access. Open the folder to have a look at the files. Step 5. Right-click on Start and then on the Edit option. Step 6. Edit the start.txt file and add these lines. Step 7. Choose your desired pool from these recommendations. You can also find better search results than these according to your region. Step 8. Type in your pool address instead of mining pool address. Step 9. Save your start.txt file with your new updates. Remember, while saving, select Type as all files. And step 10. Once you save, click on the clay.bat file to begin mining Ethereum. Now let's explore, will the proof of stake transition fail proof of work? The newly introduced concept of Ethereum 2.0 roadmaps plans to upgrade to proof of stake consensus algorithm in which it will provide all existing miners of Ethereum network with a limited time to earn a return for their investment. This is expected to be launched by the end of 2021 or the starting of 2022. It was supposed to be launched by October 2020, but the history of delays regarding this upgrade is worth talking about. Nobody truly knows when Ethereum 2.0 will be completed and introduced to the crypto mining world. Now, when we know all about Ethereum mining, this makes me wonder if Ethereum mining is profitable. The profit of any crypto mining majorly depends on the cost of electricity in that particular area. As a rule, anything below $0.12 per kilowatt consumed in an hour is considered profitable. You can mine Ether and turn it into a vital source of income by analyzing these figures like hash rate of Ethereum, block reward, number of blocks per day, and the coin price of Ethereum. You can also use an Ethereum calculator to figure out the daily revenue, basing it on these factors. Or you can use this formula too. The predictions are made that the Ethereum price can rise and become more stable in the coming few years. So it is an excellent opportunity to invest in and save in Ethereum.
In this video, we're going to cover all important concepts and components related to proof of work. First, we will have a quick introduction of blockchain, and then we will understand what is proof of work. Then we will look into how it works, and after that, we will explore why it is actually needed. What are the issues faced by proof of work? And last, we will look into the blockchains working with proof of work. So, without further delay, let's get started with the video. But before that, let's have a quick introduction to blockchain. The term blockchain refers to a decentralized database that is made up of sequential blocks that contain recorded data. The database is backed up by a network of self-contained participants known as nodes. Now, let's understand what is proof of work. Proof of work is a decentralized consensus method that requires network participants to spend time solving an arbitrary mathematical puzzle in order to prevent the system from being hacked. It is widely used in cryptocurrency mining for validating transactions and mining new tokens. It helps in the processing of peer-to-peer transactions securely without the need of a trusted third party. It also requires huge amounts of energy at scale, which only increases as more miners join the network. Now, let's have a look at how proof of work works. The right to add new blocks to a proof of work blockchain is provided to individuals who are willing to expand computational resources to solve cryptographic issues. The participants competing to add new blocks are referred to as miners, and the process is referred to as mining. Miners are the ones who execute proof of work. Miners use their computational power to locate a valid block when a piece of information, such as a transaction, needs to be added to the blockchain. This is accomplished by locating a hash that meets the network protocol specific requirements. In cryptography, a hash is the outcome of a hash function. It converts any format or size of data into fixed size numbers. The protocol established a level of mining difficulty that is algorithmically adjusted so that the time it takes to obtain a proper hash averages about 10 minutes. Miners can sometimes locate multiple blocks that satisfy the protocol's requirements at the same time and split the chain in two. Well, because there can only be one accurate chain, the protocol must account for these circumstances. Miners will initially continue to mine on both chains, but once another block is discovered on top of one of the two prior blocks, that chain becomes the canonical chain, and miners are economically incentivized to discard the other blocks. Now, one of the advantages of proof of work blockchain in terms of security is their resilience to civil attacks. A civil attack occurs when one player in the network generates many false identities in order to get an unfair advantage over other network participants who only have one identity. 51% attacks occur when a single user takes control of more than 51% of the network's resources and hence has control over the adding of new blocks. Well, now we know how proof of work works. Let's dive down deeper and explore why do we need proof of work. So majorly, proof of work is required for security and fraud prevention, as well as trust. Proof of work is intended to prevent users from printing coins they didn't earn or from double spending. If users could spend their coins more than once, the currency would effectively become worthless. Proof of work ensures that independent data processors, or miners, can't lie about a transaction. Linking a block with the proof of work hash of its predecessor results in tamper resistance because the hash of each block is an ingredient in the hash of the following block. Any changes in the chain will affect the final proof of work hash as well as all block hashes in between. So the deeper the altered block, the more computational effort needed for tampering. The first miner who discovers the proof of work answers publishes the solution to the rest of the network. And when a new block is discovered, all nodes are notified. We check the answer twice before moving on to the next block. And P.S., if correct, the block miners earn the transaction fees and the block reward. The protocol only accepts the longest chain as valid and authentic. A fake chain is impractical in the long run since a miner's chances of receiving the block reward are minimal. Other miners will continue to extend the valid chain quicker than the tampered chain over time. So moving on, let's have a look at the other side of the coin as well as understand some of the major issues with proof of work. First, it has a negative impact on the environment. Second, the 51% attack can be used against it if miners gain control of 51% of the hashing power. They will be able to determine what is true. Aside from the enormous cost of price, there is no mechanism in place to punish any malicious miners. And fourth, because every node must process every transaction, it does not scale properly. While sharding the network may boost efficiency, it also reduces security. And this was all about proof of work. Let's explore the best blockchain networks working with proof of work. Bitcoin is the largest and the very first blockchain to adopt proof of work and work with it. Ethereum is next, working with proof of work, though it is aiming to switch to proof of stake, which we will talk about in a coming video. Then comes Bitcoin Cash, which is an extension of Bitcoin and follows the same structure, thus it also works on proof of work. And then comes Litecoin, which is also an altcoin of Bitcoin. And then comes Monero, another cryptocurrency serving similar purposes as other cryptos.
So let's get started and understand what is a smart contract. What's in it for us today? Let's understand why do we need a smart contract? What is a smart contract? Usage of Solidity for building smart contract, advantages of smart contract, blockchain implementation of smart contracts. We'll look at certain examples of voting and digital token. And also we will take another use case of how smart contract help us do crowdfunding. Now, why smart contract? Now, let's take a look traditionally how contracts used to happen. If suppose two parties, A and B, have to get into a contract, they will utilize the services of a third party whom they have to trust and get the contract executed. Now, with the introduction of smart contracts and the technology which is evolving, removes the dependency on defined condition. Remittance. If any remittance of either of the parties have to happen, then it's a manual process. Approval, workflows, processes, and these manual processes take time under traditional contracting system. But in a smart contract, as the conditions are predefined, pre-embedded, as soon as a condition is met, the remittance happens automatically. Either of the parties who have to be credited with an amount is credited automatically, and that is the primary advantage of using a smart contract. Transparency is not available 100% in traditional contracts. The transparency is bound, peripheral between the parties and the entities and the intermediaries involved. As compared to smart contract, transparency is 100% available 24/7 online. Anyone can go and review, audit and validate the transactions executed by the smart contracts. Archiving. Archiving is a big difficult problem for traditional contracts, as most of the transactions are paper based or the records are maintained offline. It becomes very difficult to maintain and identify the traceability, provenance of all the transactions which have happened in a traditional contract, whereby in a smart contract it becomes easy, as all the transactions have happened through the smart contract. There's 100% traceability available. From the provenance point of view, you can trace the transaction from its day one, the point of origin, till present day, and archiving is automatically happening. The log, the audit, the transaction history is automatically getting generated. Security definitely is a concern in traditional contracts, as the intermediaries are involved, manual processes are involved. Security can be compromised at any level, at any stage. But in a smart contract, the security is maintained through cryptography, mainly through public key infrastructure, the public and private key infrastructure. It is a very secure way of maintaining security and cryptography of the transactions using a smart contract. Cost. Yes, traditional contracts are expensive. The cost of transaction is high as compared to smart contracts, as the middlemen are involved. Smart contract, the cost is low as we don't have any intermediaries, and only the cost of transaction is charged by the underlying infrastructure of the blockchain network which is running the smart contract. Signatures, it's a manual process. All the transactions are signed manually and verified manually, but here in the smart contracts, all the transactions are digitally signed using the private key of the entities and can only be decoded by the public key shared by the parties involved in the smart contract. So in a nutshell, smart contracts give us n number of advantages. The primary advantages are listed here, and these are the advantages which enforce us to move towards an economy and to a system where we start using smart contracts for our transactions to avoid any disputes, to keep the transaction cost low, thereby giving the advantage to the end consumer. Now, what is a smart contract? Let's consider a real life example where you are taking out a chocolate from a vending machine. You deposit a $2 note in a vending machine. After that, you hit A1 button, which is mapped against the chocolate bar that you want to buy. As a result, a lever in the vending machine moves and pushes out the chocolate. So basically, A1 button is programmed to the lever in order to move the chocolate out. Now, a smart contract is very similar to to a vending machine. It eliminates the need of an intermediary in case of the vending machine is replacing a direct seller and allowing you to make a purchase without a middleman, and it eliminates the need of escrow services. Now, smart contracts are self-executing contracts which contain the terms and conditions of an agreement between the parties and the peers who are involved in that agreement. So the terms and conditions of an agreement are written in a piece of code and it is executed on a blockchain based decentralized platform. Now these agreements facilitates exchange of any digital asset. It could be digital currency, it could be shares, it could be property, or it could be anything which you want to transact. So a blockchain based decentralized platform gives you a democratic system where the transactions are authorized by the majority of the participants and the identity of the participants is also kept anonymous. Now let's consider an example where Rachel is at the airport and her flight is delayed. But this inconvenience could have been beneficial to Rachel, as smart contract insurance would ensure she is given a compensation for the flight's delay instantly. So just imagine there is a smart contract which the insurance company has already deployed and it's monitoring the flight's delay. Rachel has already taken that insurance for delay in flights. So as soon as that condition is met for a delay of flight above X amount of hours, for example 2 hours, then in that case the insurance company will automatically get that trigger and Rachel will be credited with that amount for which she is insured in her account. So let's see how smart contract can be helpful here. So AXA flight delay insurance is one of the examples of Ethereum smart contract. AXA is an insurance company. The smart contract is linked to the databases that record flight status. So that smart contract is connected to the databases. It is fetching that information and evaluating the delay. It enables automatic compensation when there is a delay for 2 hours or more. So that is the condition. When the flight delay is beyond 2 hours, then the insurance contract will get executed and Rachel will get paid. So a smart contract is created based on the terms and conditions. So condition compensation is equal to flight delay is less than 2 hours. Based on the code, smart contract holds the company's money until a certain condition is satisfied. This smart contract is submitted to the nodes on the blockchain network to their EVMs for evaluation. So EVM is a runtime compiler to execute smart contracts code. It is the brain. It is the electronic virtual machine which executes the smart contract. All nodes on the network executing the code using the EVM must come to the same result because all the EVMs would have the same copy of the smart contract deployed. So if the flight is delayed 2 or more hours, smart contract will be self-executed and the compensation amount will be given to Rachel, and that is the objective of the smart contract without involvement of any middleman, paperwork which Rachel has to do to submit, and then the insurance company going through the manual process. All that has been bypassed and Rachel has been compensated directly. Now let's understand why do we need Solidity for developing our smart contracts. Now here comes the important question. Which programming language does a smart contract use? There are two widely used programming languages for writing Ethereum smart contracts: Solidity and Serpent. However, on blockchain platforms, Solidity is widely used for implementing smart contracts, and this is what we are going to talk about in our subsequent slides. Now, Solidity is a high-level programming language used for implementing smart contracts. It enables to check the program at runtime rather than compile time. Solidity is a Turing complete language. It has all the conditions, all the while loops, for loop, operators, etc. which are there in any matured programming language in order to write your code, in order to write your conditions, if you have certain loop, if you have while conditions, etc. Now, what are the advantages of smart contract? As we have already discussed, there are no intermediaries involved. The process executes without the need of a third party. It's an automated process. They are automated with the code which eliminates manual effort for execution. It's a high speed, highly computive smart contracts which runs on programming code. The speed of its execution is higher than a traditional contract. As the data is stored in the decentralized system, the chances of modifying the data is difficult, and I would say more than impossible. Accuracy based on the requirements, terms and condition of a contract is recorded accurately. So as soon as any transaction is recorded, it is registered on a blockchain network and it is immutable transaction. No one can modify or make changes in any record which has been added onto a blockchain network through a smart contract. Now let's take a look at certain blockchain implementation of a smart contract. Using blockchain in voting process can eliminate voting malpractices. A centralized voting system faces a lot of problems when it comes to tracking votes. There could be manipulated identities, there could be manipulation in counting, and there could be biased decision making. A smart contract is introduced to eliminate all these malpractices. There are certain predefined terms and conditions which are already set in the contract. No voter can vote from a digital identity of any other voter. The counting is foolproof. Every vote is registered on a blockchain network and the counting is happening automatically without any interference from a third party or dependency on a manual process. So terms and condition, each ID should be attributed to just one vote. The validation is done by the users on the blockchain network itself. So the voting process can be in a public blockchain or it could be in a decentralized autonomous organization based blockchain setup also, but it is 100% transparent and every voting transaction is recorded. Result, every voter's vote get recorded on the ledger and that information cannot be modified. It is transparently publicly available for audit and verification. Now let's take a look at one of the examples of our voting solidity contract. So here we have our voting solidity contract. It is built in Solidity and I'll just give you a brief overview of what are the primary functions in this. So if we look at this particular contract, this contract gives you certain basic parameters like what should be the minimum number of participants or proposals which are required for voting. Then what should be the minimum amount of time for debate that needs to pass before the vote can be executed. Then the margin of votes for majority A proposal passes if there are more than 50% of the votes plus the margin. So basically we are defining what is the winning condition, what is the majority margin for any vote to be accepted. Then you have data structures where you are accepting the proposals, right? And then subsequently we are defining data structures for members who are participating in the proposals, who are submitting the proposals. We are fetching the addresses of the members. Basically this is the digital identity of the members who are submitting the proposals and etc. So the smart contracts basically allows you to create a voting system where you can add members, we can remove the members, you can change certain voting rules based on certain conditions, like if you want to increase the minimum quorum, if you want to change the debating period minutes or the majority rule changes. Then this is the function for submitting a new proposal for which the voting has to happen. So basically this example is about if I have to take a vote within a decentralized autonomous organization for a particular decision. So rather than a central authority taking a decision, you can have a voting mechanism within your organization to give a majority to your proposal. If you get the majority, the proposal is accepted, otherwise rejected. Then there are peripheral functions like check proposal code. Then there is a voting function. The actual vote happens, and for a particular proposal, you start increasing or decreasing the number of votes. Then you execute the proposal if the majority has been achieved. Now let's take a look on how to deploy a smart contract. So here we have our voting smart contract. Now we will take a look on how to deploy our voting smart contract on the Ethereum test network called Ropsten. This is our voting smart contract. Now, when you open Remix, you should also have MetaMask, which is a Chrome plugin installed. This is a utility in order to connect to the Ropsten testnet, which is an Ethereum test network. So basically you say ropsten.etherscan.io, and this is the Ethereum test network on which we will deploy our contract. So once you log in into the MetaMask, you will have an account created, and in that account you should have some test ethers already so that you can use them to deploy a contract. So when you create an account on Ropsten, you can buy certain ethers using the Ropsten test faucet. So when you reach this site, the Robson test faucet has already taken the address for the account for which you are raising the request, and you can raise request of 1 Ether. Now whenever this transaction will get processed, your account balance will get incremented by 1. So as I already have Ethers in it, I can utilize it to deploy my contract. Now in order to compile and deploy my contract, I have copy pasted it here, and if I go to my run, my remix has already communicated via injected web3 to the MetaMask and taken my account, which has 7.83 Ether. Now I need to do some settings. Now, as my contract is compiled, you can see it has taken all the contracts. You can see the drop down, and Congress is my major contract. Now, I will deploy my contract. So on the run section, you will be able to see in the drop down the name of the contracts which are there in my smart contract. Like I had owned, token recipient, then there's an interface, and there is a Congress. So I need to deploy my Congress contract. Now in order to deploy this contract, there is a constructor which requires certain inputs. So I can give certain values like what minimum number of proposals I need, 100, then minimum number of debates, 10, and margin of votes for majority. So I say deploy. Now as soon as I'll click deploy, it is going to request me for gas, because when the contract gets deployed, it will deduct certain Ethers from my account. So when I'll say submit, if you notice, now this transaction has got initiated on the Robson etherscan.io. I click on it. So this is the transaction on which the contract is getting deployed. It is taking time, and the contract is getting processed on the Ethereum network. Now once it will get deployed, we will be able to see the address at which the contract has got created and deployed. Now as you can see, my contract has got deployed at the address 0xcc. I can load it. Now this is the contract address, and this is the amount of actual Ether which was spent from my account in order to deploy the contract. Now there are certain attributes on the Robson Etherscan which you can go and check. You can verify and publish your smart contract over here so that others can also view the code and utilize your smart contract. And if you go and check your MetaMask, this is the transaction which has just been done in your account, and if you click, it will take you to the same transaction which we opened here. Now after you have deployed the contract, you can interact with your contract directly through Remix. Just to test your contract, all the pink members are the ones which make changes onto the blockchain, and all the blue ones are the ones which are only performing read operations. So in order to do any read operation, you will not be requested to spend any gas. So there will be no pop-ups for MetaMask requesting for gas spending. But if you do any of these pink actions, then you will be required to spend gas, as it will be requiring to make some changes onto the blockchain. So this was a example of a voting smart contract, and this will be available as a link for you to take a look at. Now all our other contracts which we will be covering subsequently will be deployed in a similar fashion on the Robson testnet. Now let's take another example. If you want to use smart contract to issue your own cryptocurrency or called digital token, you can use Ethereum based smart contract to create your own digital tokens for performing transactions. Design and issue your own digital currency. Create a tradable computerized token that can be utilized as a currency, share, or any asset which you want to transact. These tokens use a standard coin API, like in case of Ethereum, we have standardizations of ERC20, etc., which allows contract to automatically access any wallet for exchange. As a result, you build a tradable token with a fixed supply, and this particular platform becomes like a central bank issuing a digital money. Your smart contract becomes the bank issuing the money. So let's take this example here. So this is a implementation of a ERC20 token, which is a specification by Ethereum, and the primary attribute for this token is that you need to provide a name of your token, a symbol, the decimals to which you support, and the most primary is the predefined supply. So just like in an economy, you have limited supply of money, here also you have to define what will be the supply of your tokens, and it will be capped. That will be the supply. So you need to predefine these parameters, and then you create certain data structures within Solidity to keep a tab on the balances of the entities to which you are giving the tokens and how much allowance you want to keep per address. Then there are certain methods which you have to implement as per the ERC20 specification, like transfer, transfer from, approve and call, etc. So all these methods in a typical token allows you to do the transaction, send and receive your custom token among multiple parties. So this would also be available as a link for you to take a look. Now let's take another example of a use case for crowdfunding, using smart contracts to crowdfund your project. So suppose you want to start a business, and for a business you need a lot of funding which is required, but who would lend that money to someone whom they don't trust? How will you generate that money? For such problems, smart contract plays a major role. With Ethereum, you can build a smart contract that will hold a contributor's funds unless a given date or a goal is met. Based on the result, the funds will be released to the contract owners or will be sent back to the contributors. So basically you can create a crowdfunding project for yourself if you want to raise certain amount of money, and the contributors or the investors will give you the money, but the amount will be kept on hold till the time your project goal or date has been met, and accordingly the investor will get the token which you have developed for crowdfunding in hers or his account accordingly. Now centralized crowdfunding system has plenty of issues with management systems. So therefore, a DAO, a decentralized autonomous organization, is utilized for crowdfunding. The terms and conditions are transparently set in the contract. Every individual participating in the crowdfunding is given a token, and the token is credited to their Ethereum-based account. Now every contribution gets recorded on the blockchain, because when the token transfer has happened from the DAO to the individual investor, that transaction gets recorded on the blockchain network. So let's quickly take a look at the contract for a crowd sale also. So a crowd sale contract provides you the basic attributes like what is the goal of the funding, how much money you need to raise, what is the amount raised real time, you can keep a track, what is the deadline, right, and what is the price of the token in Ethereum. Basically what is your token amount in Ethereum. Then there could be that you might give certain tokens in reward, then you can have attributes for your reward, and then you have your methods in order to keep a check that once you have received the funds, you can withdraw the funds, you can check whether you have reached the goal for funding, and then you have the methods for transferring tokens from the sender to your own account. This particular kind of contract allows you to maintain and keep a check on amount of funding you have received or you want to receive. Have you achieved your target? Who are the investors in your token? How much percentage share belongs to your account and how much percentage share has been already been distributed amongst the investors, etc. So everything can be tracked. So the smart contract can build in such a fashion that there are methods and utilities available in order to run your entire crowdfunding.
Deploying smart contracts on a private Ethereum network. Objectives. By the end of this lesson, you should be able to set up private Ethereum blockchain, write Solidity programming codes, develop and deploy smart contracts on Ethereum test network, build an Ethereum-based property transfer application, create a marketplace application on Ethereum network. Private Ethereum network. Steps to develop private blockchain. All right, let's understand the steps involved in developing a private blockchain. The setting up of private blockchain can be done on Windows or Mac by either downloading the virtual machine and installing Linux operating system on it, or it can be done through AWS or Azure cloud storage. The steps and methods are common in both the options. Users using Windows operating system can follow these steps without AWS or Azure cloud storage. You need to install Geth for the operating system. You need to configure a Genesis block. You need to initialize the private network, create new accounts, create an autonomous private blockchain, Before we actually set up a private blockchain, let's understand what is a Genesis block. Genesis block. Genesis block is defined as the start of the blockchain. It is the first block of the blockchain network and the only block without a predecessor. The first block has a file called genesis.json, which is the file that comprises of the settings for your blockchain. The main parameters used in the block are config, difficulty, gas limit, and alloc. These are the important specifications that are used in genesis.json. Config. It is the main blockchain configuration and contains many properties which include chain ID. This is the chain identifier. It is an integer used to protect against replay attack. Replay attack includes the process of accessing the network without an authentication, network tapping, poisoning the network in order to get the details, and providing malware as the victim to the computer. The other properties, such as Homestead block and EIP 155 block, are added to the configuration network for connection to the main network. Homestead is the second major release of Ethereum. The value 0 means that you are using the said release. EPI 155 block. EPI stands for Ethereum Improvement Proposal, where developers propose ideas on how to improve Ethereum and contribute to this project. Alloc. This is used to allocate ETH to an address which serve as pre-funded accounts. Coinbase. This is also known as Etherbase. It is the default primary account. Initially, a warning message will be provided if the value is not set properly. Difficulty. This shows how difficult it is to mine a block. So for a private blockchain, it is better to set the value to a low number to ensure blocks are mined quickly. Extra data. It is set to default as per the client version if it is not provided explicitly. Gas limit. This provides the maximum amount of gas that can be used in each block. Higher the value, more are the transactions that can be used in the block. Mix hash. It is set to 0 if it is a new private network. Parent hash. It is set to 0. It is not needed for a new private network. Private Ethereum network. All right, let's set up a private Ethereum node. Follow the command I am executing in my terminal. This setup is an Ubuntu setup. Execute the following command in the terminal to set up Ethereum. The command will start reading packages and installed. In my machines, it is already installed. Hence, the message is showing software properties. Common is already the newest version. Okay, let's execute the next command. The following command is to download the latest stable Ethereum repository to your sources list. There you see, it has imported public key PPA for Ethereum. Now we'll update and install Ethereum on machine. Execute the following commands. It will start fetching packages. Wait for some time while it is reading packages list. Now, finally, type the following command to install Ethereum. Now we have to create a directory. Here, let's say I create a directory named private chain. I'll execute the command mkdir private chain. This is the directory where all your Ethereum files will be stored. Let's type ls to check the directory created. Now type the command chmod 777 private chain. This is to give 777 privilege to your directory. Now let's create an Ethereum account. Run this command geth and make sure you mentioned the directory in which you just created. Henceforth, all your command will have the mention of that directory through datadir command. Here I run geth-datadir private chain dev account new. There, it will create a new account. You get a message which says your account is locked with password. Give it a password and it will display the address of the account. Similarly, we will create another account. Great. So far we have created 2 accounts. Now, use list command if you want to see the list. There it will show you both the accounts with respective addresses. Once you have your accounts created, it's time to create your public blockchain. Let's go inside the directory we created earlier. As you know, the first block is Genesis block. So to start a blockchain, you need to create a Genesis block. So type emacs genesisblock.json. Here, you're creating a JSON file, which you're going to add to your Genesis block, which will be your first transaction in the Genesis block. For Genesis file, you need to have certain attributes. The first thing it needs is nonce. Nonce indicates the complexity behind the computation of block. Next one is difficulty. It defines the level of difficulty in mining the block. Then there is alloc. Here you will mention the account address you created and you will assign some ether to it. Mix hash. This field is similar to nonce. Combined with nonce, it shows the difficulty of network. Coinbase contains the account address of the miner who created this block. Next is the timestamp, which contains the time of the operating system when this block was created. In this case, it will be Unix time. Parent hash contains the hash of the previous block. Since this is the first block, there is no block before this, hence the value is going to be all 0. Extra data is optional. Any 32-bit data can be added here. The last attribute is gas limit. It is the gas limit of the block. All right, let's add values to these attributes now. Since this is Genesis block, I have kept the nonce to all zeros. Keep the difficulty low. And in the allocation, enter the account addresses you just created and assign some ether to those account addresses. In case you don't remember those account addresses, you can run account list command. Copy the address from the directory and paste it in the alloc and add some balances to it. Copy another address and add some balance to it as well. Mix hash, you want to keep it simple. So just add 256-bit all zeros. Coinbase will also be all zeros. Likewise, add values to the attributes as I am doing it. Finally, save the file. Now you can use a Genesis block and seed a private blockchain. Run this command to initialize the Genesis block. If you get error message like I've got here, open the Genesis file and correct the error and save the file. Execute the command again. There you go. The private blockchain is created with the Genesis file added to the first block, that is the Genesis block. Now go to the directory you created. Under this subdirectory Geth, you will find two subfolders, chain data and light chain data. This indicates that your private blockchain network has been created. Now, when you mine the block, you will see .ldb file added to the chain data folder. All right, without any further delay, let's start mining. We're going to mine the blocks in the private blockchain. Run this command. There you go. The mining has started. It will take some time to mine the first block, and while it is mining, you will add some ethers to your account. The account which will be used for mining will be your first account. You will find the ether balance will keep going up. The mining may last long. This will depend on the attributes set in the Genesis file. Here's what you can do if your system stops mining. Just go to the chain data folder and you will see the .ldb file. Great. So that's how you create private Ethereum blockchain and mine the blockchain. Then you can check the balances in the account. Let me give you a quick recap of the steps I had followed. Step 1. Execute the following command in the terminal to set up Ethereum. Step 2. Execute the following command to download the latest stable Ethereum repository to your sources list. Step 3. Execute the following command to create new Ethereum account to run smart contracts and transactions. Step 4. Create genesis.json file and configure the file with the blockchain parameters. Execute the following command. Step 5. Execute the following command to initialize the Genesis file. Step 6. Execute the following command to start the mining process. Step 7. Execute the following command to stop the mining process. Ethereum smart contracts. Smart contract lifecycle. Here's how the lifecycle looks like. The Solidity code is compiled to a bytecode and is deployed to the network of nodes referred to as a blockchain network. The deployed code can be interacted with by calling the contract using the contract's address. The code can be compiled using a compiler like Remix IDE. The compiled code generates the bytecode and abstract binary interface. The abstract binary interface contains all of the arguments used in the code. A combination of bytecode and abstract binary interface is deployed on the network, which can then execute the same. Let's look at the smart contract development process to start with the smart contract. Smart contract development. In order to start the process, first create the logical program and save the file using a .sol extension. Pass the Solidity file to the Solidity compiler, where the compiler compiles the Solidity source code and converts it into a bytecode. The bytecode is used to invoke deployment using Web3.js library function, through which the deployment takes place onto the private Ethereum blockchain. Additionally, the smart contract stores the ABI, abstract binary interface, and the contract address. The ABI is a .json file that describes the deployed contract and its functions. It allows us to contextualize the contract and call its functions. The address and the ABI of the contract are passed to initiate the contract, along with the parameters to call the contract methods. Lastly, it signs and passes Ether to perform the operation and gets deployed inside private Ethereum blockchain network. So the first thing you need to learn for the deployment is the programming language. In our course, we will teach you Solidity programming language. Smart contract development environment. Let's set up a smart contract development environment which will help you create and deploy smart contracts effectively on Ethereum test network. We are going to use Simplilearn's Cloud Lab for this setup. For those of you who don't know about the lab, let me show you how to access it. Go to Simplilearn's LMS and select Blockchain Developer Training. Click on the Labs tab on the left panel of the LMS. Copy or note the username and password that is generated. Click on Launch Lab button. On the page that appears, enter the username and password in the respective fields and click Login. There it is. Your Ubuntu virtual environment is ready to be used. Let me open the lab in the separate tab for a better view. Click on Ganache icon on the home screen. Once it gets open, click Settings icon and change the port number to 8545. Click Save and Restart button. Ganache will get refreshed and restart. If you look up the RC server, it is running on port 8545. Now, let me open the browser. The lab has pre-installed Chromium browser. In the browser, I have MetaMask Chrome extension already installed. I'll just insert the password to open my MetaMask plugin. There it is. If you can see, my MetaMask is connected to port 8545, which means my MetaMask is synced to Ganache. Hence, I can import some accounts from Ganache. Let me just show you how it's done. I'll click on Import Account, and then I'll go to my Ganache and copy the private key of one of the 10 accounts. Now, back in MetaMask, click Import Account, place the private key in the field, and click Import. The respective account gets imported in the MetaMask with a predefined 100 ethers. Now we need a code editor. You can use any code editor in which you're comfortable with. I'm going to use Remix IDE here. Since it is a web-based IDE, I'll open it in a browser. I'll search for Remix IDE in the browser and open the first link. There you see the Remix IDE, which comes with pre-written sample Solidity code. I'll just select the injected Web3 environment and hit Deploy button to deploy this sample contract. Soon, the MetaMask notification pop-up asking for confirmation. Click Confirm button and the contract gets deployed on localhost. Hence, you can use this setup to create, test, and deploy smart contract on local machine. Let me give you a quick recap of the steps now. Step 1. Open Ganache, change its port to 8545, and restart. Step 2. Open MetaMask and import an account from Ganache. Step 3. Open Remix IDE and set the environment to injected Web3. Step 4. Write a contract and click Deploy. Step 5. Click Confirm button in the MetaMask pop-up to confirm the transaction. Solidity programming. Introduction to Solidity. Solidity is a programming language used for Ethereum smart contracts. It is also referred to as object-oriented high-level language. The syntax of the Solidity is similar to JavaScript. The main purpose of Solidity is to enhance Ethereum Virtual Machine, EVM. Solidity is a statically typed programming language. Thus, every variable in Solidity needs to be explicitly defined with the type of variable. For instance, string, bool, int, etc. In Solidity, processes are verified at compile time. Comparison between memory and storage in Solidity. Before understanding Solidity, it is important to know about memory and storage in Solidity. Memory. Memory is a byte array which holds the data in it till the execution of a function. Memory starts with 0 size and can be expanded to 32 bytes by accessing or storing memory greater than the current size. Memory can be shrinked to keep the gas price as low. Thus, it is used to hold temporary values. It is erased between external function calls and is cheaper to use. Storage. This is a persistent memory that every account has in its storage. Storage is a key value store where keys and values are both 32 bytes. All the contract state variables reside in storage. It is persistent between function calls and quite expensive to use. Layout of a Solidity smart contract. A Solidity file is composed of the following 4 high-level details: pragma, comments, import, contracts library interface. Source files can contain contract definitions, including directives and pragma directives. Pragma. This is the first line of the code within the Solidity file. It is a directive that specifies the compiler version that the Solidity file uses. For example, pragma solidity _0.4.19 means that the code is compatible with version 0.4.19 and lower. It is a good practice to mention the pragma directive in the first line of the code. Comments. All the programming languages provide the facility to comment. Solidity also has the same options like single-line comments, multi-line comments. General value types. Solidity also has variables that refers to storage location which can contain values. These values can be changed during runtime. There are 2 types of variables: state variables and memory variables. General value types are passed by values. State variables. Variables declared in a contract that are not within any function are called state variables. They are the current values of the contract. Solidity also provides some data types that are used in other programming language. Arrays. Arrays are referred to as data types, but to be more specific, they are data structures that are dependent on other data types. Arrays are always referred to as group of values of same data type. Solidity provides rich array constructs which are used to store the value, run iterations, sort data, and search individual or subset of elements. Arrays in Solidity can be fixed or dynamic. Fixed arrays. These arrays have a predetermined size mentioned during its declaration. The fixed arrays cannot be initialized using the new keyword. They can only be initialized in line. An example of the fixed array is integer, open bracket, 5, close bracket, age equals, open bracket, integer, 10 in parentheses, comma, 20, comma, 30, comma, 40, comma, 50, close bracket, semicolon. Dynamic arrays. These arrays do not have a predetermined size at time of declaration, but their size is determined at runtime. An example of a dynamic array is integer, brackets, age, semicolon, double slash, array of integer with no fixed storage space allocated. There are some special arrays used in Solidity like byte array, string array. These arrays contain the corresponding variable types of data. Arrays example code. The example on the screen shows a sample code for the concept of array we learned in the previous slide. The example shows a contract defined as array example, which contains multiple arrays of different types as covered in the previous slide. Enums. Enums are value types that consist of predefined lists of constant values. They are passed by values and each copy maintains its own value. Enums cannot be declared within functions. Instead, they are declared within the global namesake of the construct. The predefined constants are assigned consecutively, increasing integer value from 0. Enums are one way to create a user-defined type in Solidity. They are explicitly convertible to and from all integer types, but implicit conversion is not allowed. Enums example code. The example on the screen shows a sample code for the concept of enums we learned in the previous slide. The example shows a contract defined as test, which contains an enum called action choices, with elements like go left, go right, go straight, and sit still. Structs. A struct in Solidity is a custom-defined type that can group several variables. The struct comprises of a name, and associated properties are placed inside the struct. The struct can comprise of similar or different data types, all placed inside the same definition. The maximum number of variables inside a struct is 16. However, one can define one struct inside another struct in order to increase the variables. Mapping. In Solidity, mapping is referred to a hash table that consists of key type and value type pairs. Mapping is defined like any other variable type. Mappings are declared using the mapping keyword followed by data types for both key and value and separated by equal to or greater than notation. It is similar to a hash table and dictionary. Solidity does not allow iterating through mapping. A value from mapping can be retrieved if the key is known. Mapping are declared as mapping underscore key type equal to or greater than underscore value type. Underscore key type can be any type except for a dynamically sized array, a contract, an enum, and a struct. Underscore value type can be any type, including mappings. Example code of mapping. The example on the screen shows a sample code for the concept of mapping we learned in the previous slide. The example shows a contract defined as myContract, which contains a hash map which maps an unsigned integer to a structure. Function declaration. A function can be declared as pure, in which it promises not to read from or modify the state. The return type of the function cannot be empty. If the function does not return the whole contract, it will be omitted. The function can also be declared with view, in which they can be used for entirely viewing the state variables. The particular value can be returned instead of the whole contract. The examples shown here on the slide is of function declaration using pure and view keywords. Function calls and return types. In the example code above, you can note that the name of the contract and the name of the function is the same. This is called a constructor. In Solidity, if you wanted to ensure that a particular function in the contract should be executed before any other function, you can define it using the same name as that of the contract. Such a function will be the first one to be executed. This is defined as a constructor. This is a continuation of the previous slide. Fallback function. The fallback function is a special type of function available only in Ethereum. Solidity helps in writing fallback functions. A fallback function is invoked when no function name matches the called function. The fallback function does not have an identifier or function name. It is defined without a name and doesn't accept any arguments or return any value. Function modifiers. Modifiers are another concept unique to Solidity. Modifiers help in modifying the behavior of a function. The code remains the same, but the execution path of the function changes. Modifiers can only be applied to functions. Thus, modifiers enable you to control the behavior of your smart contract. Function modifiers example code. The example shows the use of a function modifier. Inheritance. Solidity supports multiple inheritances in the form of copying code, which includes polymorphism. Inheritance is similar to any other object-oriented programming language. The new contract inherits the functionality of the base class. Every function call is virtual. When inheriting from multiple contracts, only one contract gets generated on the blockchain. The code from all base contracts gets copied into the final contract, which is created. Inheritance example code. The above example shows an inheritance code where the contract title fun is inherited into the contract title solidity using the is keyword. Abstract contracts. Some contracts cannot be compiled by themselves because the function lacks implementation but can be used as a base. If the contract inherits from an abstract contract, it must implement all functions that lack implementation, else it becomes abstract itself. Abstract contracts example code. The above example shows an abstract contract called abstract contract, which is inherited into another contract called new contract. Events. Events are known as event-driven programs. Events refer to certain change in contracts that raise events and notify each other such that they can act and execute other functions. Events help the developers and programmers write asynchronous applications. Events are the part of a contract inheritance where a child contract can invoke events. Event data is stored along with block data. Events don't have anybody to define. They work exactly like functions. Events allow the use of EVM logging for calling front-end callbacks inside the dApps interface for the users to listen to the events. Events example code. In the example shown here on the slide, I have passed two types that represent name and age. When the event is successfully returned in the UI, these values can be accessed. Creating contracts using new operator. A contract can create a new contract using the new keyword. Recursive creation dependencies are not viable. The contract sample new is being created, and when it is initialized, it creates another contract with new keyword. Globally available variables and functions. Solidity provides two types of units, ether units and time units. Ether units are numeric literal and may take a suffix of Szabo, Fini, Wei, or Ether for converting between the Ether's sub-denominations. Following are the variables and functions that always exist in the global namespace. ERC20 tokens. ERC20 tokens are tokens that are designed and used solely on the Ethereum platform. These tokens follow certain standards so they can be shared and exchanged for other tokens or transferred to a crypto wallet. These tokens are created by the Ethereum community. Smart contracts are used to create ERC20 tokens. They are also used for transactions of tokens and record balances of tokens in the account. After a token is created, these tokens can be traded with any other. ERC stands for Ethereum Requests for Comments, and 20 stands for a unique ID number to distinguish this standard from others. ERC20 Token Standard. The Ethereum community created these standards with 3 optional rules and 6 mandatory. Optional, token name, symbol, decimal up to 18, mandatory, total supply, balance of, transfer, transfer from, approve, allowance. 1. Getting the total supply of tokens with the usage of total supply function. 2. Retrieving the token balance of another account associated with the _owner address via the balance of address _owner constant returns uint 256 balance function. 3. Sending a specific amount of tokens to a given address through the transfer address _to uint 256 value returns bool success function. 4. Sending a specific amount of tokens from one token contract address to another token contract address via the transfer from address _from address _to uint 256 value returns bool success function. 5. Enabling a specific account to withdraw tokens from one's account repeatedly while predefining the upper limit for the amount of tokens to be withdrawn with the _value parameter. This can be achieved via the approve address _spender uint 256 value returns bool success. The upper limit for withdrawal, i.e. the _value parameter, can be overwritten when the function is recalled. 6. Returning the residual amount of tokens within the preset amount defined by the upper limit allowed to be spent by the _spender to withdraw from the account of the _owner. This can be executed via the allowance address *_owner address *_spender constant returns uint 256 remaining function. Create a smart contract to issue your own digital token. In this demo, we're going to develop a tradable token with a fixed supply that can be utilized as a currency, share, or an asset. All right, let's get straight to coding. Let's go to the lab and open Remix IDE in the browser. Let's create a new file named ERC20 token. And as always, let's begin the contract with Pragma Solidity and the version. Let's declare an interface named token recipient so that any contract that implements receive approval function counts as a token recipient. Next, we're going to create a contract named token ERC20 and declare public variables of the token. Let's create mapping with all balances. Next, let's generate a public event on the blockchain that will notify clients. Another general event to notify client. an event that notifies clients about the amount burnt. Let's create a constructor function which initializes contract with initial supply tokens to the creator of the contract. Update total supply with the decimal amount. Give the creator all initial tokens. Set the name for display purposes. Set the symbol for display purposes. Let's create an internal transfer function that can only be called by this contract. Prevent transfer to 0x0 address. Use burn open close parentheses instead. Check if the sender has enough. Check for overflows. Save this for an assertion in the future. Subtract from the sender. Add the same to the recipient. Asserts are used to use static analysis to find bugs in your code. They should never fail. Now we're going to create a transfer function. Send underscore value tokens to underscore 2 from your account. Underscore 2, the address of the recipient. Underscore value, the amount to send. Another function named transfer from is created which transfer tokens from other address. Send underscore value tokens to underscore to on behalf of underscore from. Underscore from, the address of the sender. Underscore to, the address of the recipient. Underscore value, the amount to send. Let's set allowances for other address. Allows underscore spender to spend no more than underscore value tokens on your behalf. Underscore spender, the address authorized to spend. Underscore value, the max amount they can spend. Let's set allowance for other address and notify. Allows underscore spender to spend no more than underscore value tokens on your behalf, and then ping the contract about it. Underscore spender, the address authorized to spend. Underscore value, the max amount they can spend. Underscore extra data, some extra information to send to the approved contract. Create a function names burn which destroy the tokens. Remove underscore value tokens from the system irreversibly. Underscore value the amount of money to burn. Check if the sender has enough. Subtract from the sender. Updates total supply. Now we'll create a function that destroy tokens from other accounts. Remove underscore value tokens from the system irreversibly on behalf of allowance. Subtract from the targeted balance. Subtract from the sender's allowance. Update total supply. All right, our contract is ready to be deployed. I'm going to deploy the contract on Ropsten Test Network. If you are using Ropsten 2, ensure that you have Test Ether in your account. If you don't have it, get some ethers from faucet.metamask.io. There, click on Request 1 Ether from the Faucet button. A MetaMask notification will pop up. Click Connect. Check the account after a few hours. You will get 1 test Ether in the address. All right, let's resume back to the deployment. I'm going to use account 1 and click Deploy. A MetaMask notification will pop up asking for confirmation. Click Confirm, and the contract gets deployed. So that's how you can create your own cryptocurrency on Ethereum. Let me quickly give you a recap of the steps now. Step 1. Open Remix IDE to write the Solidity code. Step 2. Write the contract code in the Remix IDE. Step 3. Open MetaMask extension and connect to Ropsten Test Network. Step 4. Create an account in the Ropsten Test Network. Step 5. Create free Ether from https://faucet.metamask.io. Step 6. Click Run. Step 7. Select Injected Web3 Ropsten under Environment tab. Step 8. Click on Create button. Step 9. Click Submit in MetaMask. Step 10. Click Contract Deployment in MetaMask extension. Step 11. Review your transaction details for the deployed contract on the Etherscan page. Solidity Smart Contract Design Pattern. Important smart contract design notes. As Solidity is still in development, there are a number of changes and issues that have to be considered in order to have a perfect smart contract so as to ensure security of your sensitive data on smart contract. There are some important points that have to be considered in order to ensure the same. Obfuscation. All variables are publicly viewable on blockchain, so anything that is private needs to be obfuscated. Storage optimization. Smart contract should be carefully developed because writing to blockchain is expensive as data is stored forever. Cron job. Contracts must be manually called to handle time-based scheduling. Cost of gas. Almost every instruction in a smart contract costs gas, so always write a cost-effective smart contract. Smart contract design patterns. Design patterns are proven to be the go-to solution in addressing Ethereum smart contract design challenges. Following are common design patterns: contract self-destruction, factory contract, name registry, mapping iterator, withdrawal pattern. In the coming slides, we will learn about each of these design patterns in detail. Smart contract design patterns. This is used for terminating the contract entirely from the blockchain. Once destroyed, it is not possible to invoke functions on the contract, and transactions will be logged in the ledger. Before destroying the contract, it is important to consider that transactions will fail. Any funds sent to the contract will be lost. Factory contract. Factory contract is used to create and deploy the child contracts. They are referred to as assets. Mostly, the factory is used for storing the child contracts' addresses as they can be extracted whenever necessary. A common use case for the factory contract is selling assets and keeping track of those assets. The addresses of these child contracts are stored in the factory and can be extracted whenever necessary. Name registry. This allows you to keep the address in one contract instead of tens, hundreds, or even thousands of addresses. They use mapping methods such that each address can be looked up for the particular DApp. Name registry is useful when your contract is dependent on multiple contracts. Mapping iterator. There are times when iteration takes place multiple times, but since mapping in Solidity cannot be iterated and they only store values, the mapping iterator pattern turns out to be extremely useful. Withdrawal pattern. After the contract is created and the asset is bought by the buyer, if, due to some fallback problem, the contract has to be withdrawn from the network, all the tokens of the contract has to be withdrawn and refunded. The goal of withdrawal pattern is to keep track of balances internally and force each user to withdraw their funds immediately. Solidity Smart Contract to develop property transfer system. In this demo, we're going to create and deploy a smart contract for decentralized property transfer system. The scenario is such that government agrees to put land records on the public blockchain. Each development authority, DA, becomes the de facto owner of the property that exists under their constituency legislative body. When all the above conditions are met, then DA, owner, can easily attach the respective property to the rightful owner after thorough verification. All right, let's start our demo. Let's open the Simplilearn's lab for this demo. There it is. The lab is ready. Let's set up the development environment now. As I have shown to you earlier, I'm going to use Ganache again. Then I'll open the MetaMask and connect it to the port. Now I'll open Remix IDE to write and deploy smart contract. Let's create a new file, property_transfer. All right, now let's begin coding. All right, as I had taught you previously in the class, that every contract starts with a version name. So let's write the first line of the code. Pragma solidity caret 0.4.18 semicolon. Then we need to give name to our contract. Let's call it property transfer. DA shall be the owner. We shall be initiating this variable's value by the address of the user who's going to deploy it, e.g., let's say DA itself. Let's define the total number of property under DA at any point of time. Unit 256, public, total no of property. They should increase as per the allotment to their respective owner after verification. Let's define a constructor whose code is run only when the contract is created. Function property transfer. Let's define a structure for storing property against each address. Bool is sold. We're keeping the count as well for each address. We shall have the properties mapped against each address by its name and its individual count. We shall also have another mapping on how many property does a particular person hold. Then we're going to declare event. This shall give us the exact property count which any address own at any point in time. Let's declare a function. This function shall be called by DA only after verification. Let's check whether the owner had the said property or not. If yes, return the index flag equals strings equal properties owner check owner address I dot name underscore property name if flag equals true. Break. If flag equals true, return I. Else, return 999999999. We're expecting that no individual shall be owning this much properties. We're expecting that no individual shall be owning this much properties. Let's have a functionality to check the equality of two strings in Solidity. Transfer the property to the new owner. If check owner equals 999999999 and properties owner message sender check owner dot is sold equals false, step 1, remove the property from the current owner and decrease the counter. Step 2, assign the property to the new owner and increase the counter. Property transferred, message sender _2 _ property name, owner has been changed, else flag equals false. Property transferred, message.sender _2 _ property name, owner doesn't own the property. Return flag check owner. All right, now we have written the code for property transfer. I'm going to click run and change the environment to Web3 provider and hit deploy button. Now check the log. You'll see the transaction gets logged. Check transactions in Ganache, which shows the deploy of contract. Now let's use allot property function to allot the property. Copy and paste the address to which you wish to allot property and give it a name. The property gets allotted when you hit the button. Similarly, you can transfer the property to new address using transfer property field and check whether the property is getting shown under the new address or not. All right, that's how you can replicate the real estate on blockchain and make the real estate transactions visible to all parties: banks, brokers, government officials, buyers, and seller.
So let's start with the coding journey to our first Ethereum smart contract. But before diving into the development and deployment of Ethereum smart contracts, it's critical to first grasp the Ethereum platform and how it functions. So the first thing that we learn is what is smart contract in the first place. So smart contracts are essentially programs that run when criteria are fulfilled and are stored on a blockchain. They are usually used to automate the execution of an agreement so that all parties can be certain of the results right away. So without the need of any intermediaries or time waste. They can also automate a workflow starting the following step when certain circumstances are satisfied. So now that we know what is smart contract, let's move ahead and see how it works. So step 1, smart contracts are made up of basic if, when, then phrases encoded in code on a blockchain. Step 2, when preset conditions are satisfied and validated, the activities are carried out by a network of computers. These measures could include sending notifications, releasing funds to the proper persons, or issuing a ticket. Step 3, when the transaction is completed, the blockchain is updated. That means the transaction can't be modified and the results are only visible to those who have been granted access. There can be as many stipulations as needed. Convince the participants that the task will be executed correctly. Participants must agree on how transactions and associated data are represented on the blockchain. Agree on the if, when, then rules actually govern those transactions. Investigate all conceivable exceptions and design a framework for resolving disputes in order to set the terms. The smart contract can then be coded by a developer. The firms that use blockchain or business are increasingly providing templates, web interfaces, and other online tools to make smart contract construction even more easier. And here also we will be using one such tool to create our very first Ethereum smart contract. So now that we know all the required knowledge about smart contract, let's start with how to create our very first Ethereum smart contract. So let's get started. Now let's start with the first smart contract. So the first thing that we need to do is to navigate to this website, which is remix.ethereum.org. So this is going to lead us to a Remix IDE, as you can see, which is an integrated development environment for Solidity programming. And it runs from the browser itself, so it does not need to be installed, and you can access it in any operating system. So it's a lot more convenient, and you can also use it to interact with the Ganache or testnet over RPC port. So basically RPC or remote procedure call interface is provided by the blockchains for the execution of the functions that you'll store or that you'll insert as a criteria in your Solidity smart contracts. So here we will be using Ganache to deploy our smart contracts. So let me give you a quick introduction to Ganache. Basically, it's a personal blockchain that enables the building of Ethereum and CODA distributed applications quickly. And it may be used throughout the development cycle, allowing you to develop, deploy, and test your decentralized applications in a secure and a very predictable environment. But before deploying our smart contract on Ganache, we will deploy a smart contract on the default blockchain provided by the Remix itself. So let's get started with the code. So the first thing that we need to do is to create a file with .sol extension. So you can see here I have already created my workspace with the name of demo smart contract workspace. Now I just need to create a file. You can click on this icon and you can give it a name according to your convenience or whatever program you're gonna store in your smart contract. So basically .sol is the extension to our smart contract since we are using Solidity programming to create our smart contract. So I'll just give it a name. So here I have given it a name called democontract.sol, and that is it. Now you can see here you have directed to a section where you have to actually write your code. So basically in this video, we will be creating a smart contract for the implementation of cryptocurrency in its most basic form. So this smart contract will allow you to create or mint new coins and send them to other blockchain addresses. So let's start with our code. So the first thing that we will write is pragma directive. So let's write pragma solidity 0.5.1. So this is basically a range of our minimum margin for our Solidity server. Then we will declare the contract. So let's just write contract. So basically the core contract code starts with a keyword, the contract followed by the name of the contract according to your convenience. So here I am giving it a name mint your coins. And then the braces, which employ the entire contract state and its functions. So now that we have declared our contract scope, let's start with the variables and functions that we need to declare in our smart contract as per our need. So here I am declaring our variables. So the first variable is for addresses. The first one is minter, and second is balance, so these are known as state variables, or this mapping can be thought of as hash tables that are virtually initialized so that every potential key exists right away and is mapped to a value with a byte representation of all zeros. So this map will store every address with its balance. So now that we are done with the declaration of our variables, let's create a constructor that will be the address for creating new coins. So constructor, we'll make it public, minter dot msg dot sender. So this line ensures that only the creator can mint new coins. Next, we will set a condition for creating new coin and storing them in the hash table. So now to store our created new coins into a hash table, we'll declare a function mint. So let's start with the code. Function address of the receiver and the amount to be received. We'll also declare this public, and we just need to mention our conditions here. So this is our first condition. Second, we'll mention a limit for the maximum number of coins to be created, or for the maximum number of, the amount to be received or sent. This is done. So the next function is going to be sent, which simply examines the transaction's feasibility. So let's declare that function as well. So again, let's input our parameters, address of the receiver, and
the amount. We'll make this function public as well. Mention our criteria. So the first one is this is for you to check if there's sufficient balance or insufficient balance in the account. So if the transaction is possible, the function will generate a send event. So we also need to mention an event here. To know all the details like who has the address of the sender and the receiver as well as the amount. So here we have created the event. Now let's get back to the criteria in our send function. So as I was saying, if the transaction is possible, the function will generate a send event, which is a declaration for the transactions to be broadcasted. So let's just get done with our criteria here. Amount. So the clients using Ethereum can listen to these events on the blockchain for free. The listener receives the arguments from or to an amount as soon as the event is emitted right here in the send function. Sorry, I forgot to mention too. Yeah. So as soon as the event is emitted, the transactions is tracked and then the next function is executed, which is to get the balance of the address. Also, when the transaction is completed, the transaction is then added to the blockchain itself with all the data of who has sent those coins and who has received it along with their addresses. So let's create one more function to know the balance. So that will be, let's give it the argument external view returns for the return value, that will be integer. Return balances, the argument we just mentioned. So this function is to get the balance of our account. So this was our code. Now we need to compile this code, see if there is any error or not. So to compile this, you need to click on this icon and just click on compile. So here you can see that there is no error and it's successfully compiled. So once it's compiled, you need to deploy this code. So click on this icon. Here you can see this is the by default environments provided by Remix itself. So here we will just select the default one, JavaScript virtual machine. So like we discussed before deploying our smart contract over Ganache blockchain, we will be deploying it over the blockchain that is by default provided by Remix itself. So here we have selected the environment. These are the accounts with the dummy coins already stored. Obviously you can't use them for your actual purposes, but these are the dummy accounts provided by the Remix for analyzing your smart contracts and keeping the track of the transactions.
So you can simply select any of these accounts according to your choice. And as you can see, there is currently no contract deployed here. So simply we'll just click on deploy. So here you can see it's successfully deployed. We'll just click on this drop down menu, and after scrolling it down, we can see all the options with the functions like mint, send, balance, balances, and the minter. So when you click on minter, it will generate an address, current user's address. So just copy it. So once you have copied, you can just click on balance. So here you can see you're getting error because right now you have not transacted any amount of coins yet. So we'll just paste the address here and then provide the second argument, which is the amount that you want to mint. Just click on mint, and here you can see its success. You have successfully minted 500 coins. So now when you check the balances, we are still getting error. Sorry, I forgot to provide the address. So we'll just provide the address and click on balance. Here you can see the function is already called, and here you can see the amount you just minted. Same as for here. Click on it, the amount you just minted. Now to send, you can just click the address, comma, 250. So for demonstration, I have provided the address of obviously the sender right now because I don't know the address of the receiver. But what you can do is you can provide any other address and just put the amount and click on send, and when you'll check the balance, there will be a change in it. Right now there is no change because both the addresses are already same. So this was all. This was the code, and this is how you can just compile and deploy your code on any blockchain. So now that we have checked it over the default blockchain provided by Remix, let's have a look at the Ganache one. So to use Ganache, you need to first download it. So by clicking here, you can just download it for Windows. So I have already installed this, so we'll just jump to that step directly. So once you're done with the installation of Ganache, you'll get a page like this, and then you have to create a workspace. So you don't need to create a workspace here. You can simply click on Quick Start, and it will give you a list of accounts and all the details of the blockchain that you can simply connect with your IDE, and to which you can simply deploy your smart contract into. So let's just wait for it to download all the information. So now here you can see all the default accounts provided by the balance information by the Ganache itself. What we need to focus on is RPC server. So basically this is the address provided to every Ganache account or blockchain by default itself. So we just need to copy this and click on Ethereum IDE and go to the environment and select Web3 provider. So when you'll click on it, you'll get this pop-up, and at the end point, you have to paste the address you copied from your Ganache portal and just click on OK. So now you can see again there is no contract deployed to it because now you're simply connected to the custom network, which is your Ganache network. Now these are the accounts provided to you by Ganache itself, the list of accounts that you saw on the portal. Now the same process you need to repeat here. Just click on any account of your choice, select it, and click on deploy. So here you can see it's successfully deployed. And again, we're going to repeat the same process. So you can see the address is completely different from the previous one. Just copy this, paste it here. Let's have a different amount this time. Let's put it 750. So, and just click on mint. You can see it's successfully minted, and when you will paste the address here and click on balance, you can see it's showing 750. Same you can do for balances. It's 750. And the same you can do with the sent also. As I'm using the same address, there will be no change in the balance. But obviously it's not popping any error and showing it's successfully done. So you can use it with somebody else's address too. First, let's have a look at the topics that we are going to cover in this video. First, we will have an understanding of what Hyperledger Fabric is. Following that, we will have a look at some of the benefits of Hyperledger Fabric. After that, we will understand the working of Hyperledger Fabric. Following that, we will explore the transaction flow of Hyperledger Fabric. And at the end, we will have a look at some of the industry use cases of Hyperledger Fabric. So let's start with what is Hyperledger Fabric. Now, the Linux Foundation launched Hyperledger Fabric in 2015 as an open source permission blockchain technology. Now, it is a general purpose modular framework that provides distinctive identity management and access control features. As a result, it is appropriate for a range of business applications, including trade finance, loyalty and reward programs, track and trace of supply chains, and clearing and settlement of financial assets. So, technically speaking, it enables plug-and-play compatibility for components like membership services and consensus. So now that we have the understanding of Hyperledger Fabric, let's have a look at some of its benefits to better understand its functionality. So first is open source. The Linux Foundation is the host of the open source Hyperledger Fabric technology, which is a blockchain framework. The developer community is vibrant and expanding. Second is permissioned. Fabric network, which means that the identities of every individual who participates are known and verified. This advantage is especially beneficial in sectors like healthcare, supply chain management, finance, and insurance, where data cannot be accessible to unidentified parties. For instance, to protect consumer privacy, an insurance provider on an Hyperledger Fabric blockchain network can share customer claim data with authorized parties. Third is governance and access control. Fabric networks are made up of channels, which are private subnets of communication between two or more particular network members. Through these channels, network users can conduct confidential and private business. Every transaction on the blockchain network takes place on a channel where each person involved must be verified and given permission to conduct business. This adds an extra degree of access control and is particularly helpful when members want to restrict how much information is made public, for instance, when rivals are on the same network. Fourth is performance. Because of its consensus mechanism, Hyperledger Fabric can support high transaction throughput for enterprise-grade use cases. Fabric is a permission blockchain system. Therefore, it does not have to deal with Byzantine fault tolerance, which might result in slower network transaction validation performance. So now let's move on and have a look at the working of Fabric network. So an open, tested, enterprise-grade distributed ledger platform is Hyperledger Fabric. It proposes unique privacy control so that only the information you want to share is shared with the permitted network users. The business processes you want to automate are documented in smart contracts with self-executing clauses between the parties that are written in lines of code. The code and the agreements contained therein exist across the distributed decentralized blockchain network. Because transactions are retraceable and irreversible, organizations can trust one another. Due to this ability to quickly make better judgments, organizations can save time, money, and risk. So now that we know the working of Hyperledger Fabric, let's understand its transaction flow. So first, when a client application sends a transaction proposal to peers in each organization for approval, the transaction flow starts. Second, the peers confirm the identity and legitimacy of the submitting client to submit the transaction. After that, they simulate the result of the proposed transaction, and if they match what was anticipated, they send the customer an endorsement signature. Third, once it has the required number of endorsements as specified in the endorsement policy, the client gathers recommendation from peers and transmits the transaction to the ordering service. And lastly, in order to comply with the endorsement policy, the ordering service verifies that the transaction has the required number of endorsements. The accepted transaction are then chronologically ordered, bundled into blocks, and sent to peer within each organization. The ordering service sends new blocks of transaction to peer nodes, who subsequently do a final validation on the transactions in that block. As soon as this is finished, the ledger state is updated and the new block is added. The fresh deals have been committed now. So that we have covered all the necessary details regarding Hyperledger Fabric, let's have a look at some of the industrial use cases of Hyperledger Fabric. The first one is supply chains. Now, supply chains are vast, dispersed network of suppliers, producers, and retailers. By boosting the transparency and traceability of transaction within the network, Hyperledger Fabric networks can enhance supply chain procedures. Companies who have access to the ledger on a Fabric network can see the same unchangeable data, enforcing responsibility and lowering the possibility of counterfeiting. Then comes trading. Now, importers, exporters, banks, shipping companies, and customer offices are just a few of many institutions that must collaborate in order for trade to take place. Now, financially and trading consortiums can simply build a blockchain network using Hyperledger Fabric, where all the participants can conduct business and handle trade-related documents electronically without the need for a central trusted authority. In fact, contrary to other processes which require players to exchange trade-related documents back and forth, taking 5-10 days to complete. Next is insurance. Now the insurance sector loses billions of dollars each year to fraud, but using Hyperledger Fabric, insurance companies can use transaction data stored on the ledger to spot duplicate and fabricated claims. By leveraging smart contracts to automate payment from the at-fault party back to the insurance company, blockchain can help speed up the processing of multi-party subrogation claims.
Finn is part of the management team in an MNC, and he has come up with some profitable investment policies for his company and his employees. Before its implementation, he needs to pitch his idea in front of the board of directors. But the board of directors didn't approve of his idea, and that too without any explanation for their decision. Disappointed by this, he started browsing the internet, looking for a solution that could benefit everyone and where every member gets to have their say. And that is when he came across the concept of DAO, which is a decentralized organization that is collectively owned by its members, and wherein decisions are voted upon by themselves, which runs on blockchain technology. But to understand its concept in depth, we went to his friend Sam, who is a blockchain expert. Finn explained to him his situation, how he came across the DAO, and why he wants to know more about it. On realizing his excitement and curiosity, Sam decided to take him through the DAO and how it functions. He explained that before understanding what DAO is, let's understand a bit about what blockchain is. Blockchain is a system of storing data that makes it difficult or impossible to change, hack, or manipulate the data. It's basically a digital log of transactions that are duplicated and spread across the blockchain's whole network of computers. And the DAO is something that makes use of its rules and policies for its proper functioning. He further added a DAO, or decentralized autonomous organization, is a blockchain-based organization that is collectively owned and controlled by its members. They have built-in resources that no one can access without the group's permission. All proposals are implemented using voting processes to make decisions upon its rules and policies, ensuring that everyone in the organization gets a say. And this whole system majorly runs on Ethereum blockchain. Sam further added that back in 2016, the developers of the DAO believe that by putting decision-making power in the hands of automated technology, that will eliminate the decision-making power driven by an individual or by body. It was created to allow investors to send money anonymously from anywhere globally, and they would issue tokens to those owners, letting them vote on potential initiatives or proposals. Finn was fascinated and asked Sam how exactly it works and how this can be the solution for his situation. Sam explained, basically, smart contracts are the backbone of DAO. Smart contracts are programs that run when certain conditions are met and are stored on a blockchain. Let's understand this stepwise. Step 1 is when the documentation of the idea takes place in the similar way in DAO. A group of people write these smart contracts to administer the organization. Once the contract goes live on the Ethereum network, changes to its rules can be proposed only by voting. The contract automatically fails if the rules are violated. Then comes step 2, which is a funding period, in which pitching of ideas takes place in front of the selected members and investors of the organization. Similarly, people in the DAO organization contribute money to the DAO by purchasing tokens that signify their membership in the organization. And when the funding period ends, it proceeds to step 3. That is when the approval and implementation process of the idea takes place, or say the DAO starts to operate. People can now make proposals to the DAO on how to spend the money and how the members can vote to approve those proposals. This is how the first ever DAO was launched by Slockit. Now the question arises, what led the DAO towards criticism? This is due to the infamous DAO hack. Back in June 2016, hackers used DAO's vulnerabilities to assault its treasury. The hackers were able to gain access to 3.6 million Ethereum, valued around $50 million. This sparked a divisive debate among DAO investors, with some demanding for the DAO to be permanently dismantled. Initially, Vitalik Buterin, the founder of Ethereum, advocated a soft fork of the Ethereum network, which included a piece of code that would effectively blacklist the attacker and prohibit them from moving the stolen cash. But soon after, a problem was detected in its code, putting it vulnerable to assault. After great debate, a second alternative, a hard fork, was suggested and subsequently implemented. The hard fork effectively reset the Ethereum network's history and moved the DAO's Ether to a different smart contract, allowing investors to withdraw their assets. And as a result of the hard fork, two competing and now distinct Ethereum blockchains emerged. Those who opposed the hard fork, which wiped back the blockchain's history, backed the soft fork version, which is now known as Ethereum Classic, ETC. The Ethereum blockchain is the blockchain that implemented the hard fork, changing the blockchain's history. Ria is a phenomenal baker who runs a bakery in New York. On seeing the great success of her business, she thought of growing it even bigger and launching a new franchise of her bakery in LA. So for the funds, she applied for a loan of $50,000 from the central bank. After completing her documentation for the loan, she comes to know that the bank is rejecting her loan application due to her loan borrowing limit of the amount decided by the central financial system. Furious with this situation, she talked to a friend Lisa, a finance expert, to understand how this whole centralized financial system of banks works. And why did her loan get rejected? Lisa explained to her that in centralized finance, banks and businesses use the money that you invest or lend to make profits, and their overriding objective is to make money. Third parties or merchants like debit, credit card providers control money transfers between the two end parties in the financial system, each charging a fee for their services. And that is why her loan got rejected, because the loan amount exceeded the limit decided by the bank or third parties for her. Ria was upset with the thought of not being able to grow her business, and that is when Lisa suggested Ria to opt for decentralized finance, or DeFi. Ria got a little confused by the term, and asked, "What is decentralized finance?" Lisa answered that decentralized finance is a piece of code that eliminates middlemen or banks by allowing individuals, business merchants, and corporations to perform financial transactions using developing technologies. Peer-to-peer financial networks that provide security protocols and connectivity to the transactions are used to accomplish this. Stablecoin is a cryptocurrency backed by an asset or tied to a fiat currency like the dollar, is at the concept's core. Ria was fascinated and asked how it works and how exactly DeFi could help her get her loan approved. Lisa further added that DeFi uses the consensus mechanism to eliminate centralized finance models by allowing anyone or everyone to utilize financial services, regardless of who they are or where they are. A consensus mechanism refers to the methods used to achieve agreement, trust, and security across a decentralized computer network. Now, this DeFi mechanism runs in a decentralized environment. And this is where blockchain comes into the picture. It provides the environment where you can simply create your decentralized programs, or dApps, according to your requirement. In the blockchain network, transactions are stored in blocks, and other users in that network can verify them. If a transaction is verified by all its verifiers, the block is closed and encrypted, and a new block is created containing information from the previous block, thus creating a chain of blocks. And these transactions are handled by decentralized applications, or say, dApps. Lisa further explained that Ria's loan got rejected due to the lower limit by the centralized financial system. But in DeFi, she can submit her loan requirements into a decentralized finance application, dApp, and an algorithm would match her up with peers who could help her. After that, she'll have to agree to the lender's terms to get her loan. The transaction is then recorded in the blockchain, where it will be securely stored in a ledger that will make it impossible to hack, or any kind of malicious intervention. And after that, she'll receive her required amount of money once it is verified by the consensus mechanism. The lender can also then begin collecting their payments at the agreed upon intervals from her. When she makes the payment using her dApp, it goes through the same blockchain process, and the money is transferred to the lender. Ria was impressed and relieved that she now could grow her business in a much more secure and cheaper way, all thanks to DeFi. DeFi is meant to conduct transactions using cryptocurrency. Because technology is still evolving, it's difficult to say how, if at all, existing cryptocurrencies will be applied.
This video, at first, we will see some of the use cases of Merkle tree. And then we will understand what is a Merkle tree, followed by what is a Merkle root, after which we will explore about cryptographic hash functions in blockchain, and then we will understand how Merkle tree exactly works. After which, we will discuss the benefits of Merkle tree, and at last we will explore why is it essential to blockchain. So without much delay, let's get started with the video. But before starting, let's have a quick look at some general use cases of Merkle tree. Of course, there are more Merkle trees implementations out there. Git, a distributed version control system, is one of the most widely used. It is used to handle projects by programmers from all around the world. Interplanetary file system, a peer-to-peer distributed protocol, is another suitable implementation. It's also open source, allowing computers to join and use a centralized file system. Merkle trees are used to the benefit of certificate authorities as well. It's part of the technique that generates verifiable certificate transparency logs. The final use case we look at is database systems like Amazon DynamoDB and Apache Cassandra. During the data replication process, Merkle trees are used by these NoSQL distributed databases to control discrepancies. Now, the very first thing we will discuss is what is a Merkle tree. Merkle trees, also defined as binary hash trees, are a type of data structure commonly used in computer science. Merkle trees are used to encrypt blockchain data more effectively and securely in Bitcoin and other cryptocurrencies. It's a mathematical data structure made up of hashes of various transactions of various data blocks in a particular blockchain network, which acts as a summary of all the transactions in a block. It also enables quick and secure content verification across big data sets. It also helps to verify the consistency and content of the data. Now that we know about the Merkle tree, let's explore what is a Merkle root. A Merkle root is a simple mathematical method for confirming the facts on a Merkle tree. They are used in cryptocurrency to ensure that data blocks sent through a peer-to-peer network are whole, undamaged, and unaltered. Merkle roots play a crucial role in the computation required to keep cryptocurrencies like Bitcoin and Ether running. Now that we know hash is a big part of Merkle tree, let's dive down and have a look at some of the cryptographic hash functions. A hash function maps any type of arbitrary data of any length to a fixed size output. It is commonly used in cryptography since it is a cryptographic hash function. The hash functions are efficiently known for one property: they can't be reversed. It's a one-way function that's only meant to work in one direction. Message direct, secure hash function, and RIPE message direct are some of the hash families available. Now let's take an example. If you use the SHA-256 hash algorithm and pass 101 blockchains as input, you will get the following output. This concludes that hash functions have the following key properties: deterministic, pre-image resistant, computationally efficient, cannot be reverse engineered, and collision resistant. Now that we know about various aspects of the Merkle tree, let's understand how the Merkle tree works. Now that we have a basic understanding of hash functions, we can move on to the working of Merkle trees. A Merkle tree totals all transactions in a block and generates a digital fingerprint of the entire set of operations, allowing the user to verify whether a transaction is included in the block. Merkle trees are made by hashing pairs of nodes repeatedly until only one hash remains. This hash is known as the Merkle root or the root hash. They are built from the bottom using transaction IDs, which are hashes of individual transactions. Each non-leaf node is a hash of its previous hash, and every leaf node is a hash of transactional data of each block. Here's an example of a Merkle tree to help you understand the concept. Consider the following scenario. A, B, C, and D are 4 transactions, all executed on the same block. Each transaction is then hashed, leaving us with hash A, hash B, hash C, and hash D. Now the hashes are paired together, resulting in hash AB and hash CD. A Merkle root is formed by combining these two hashes, hash A, B, C, D. In reality, a Merkle tree is much more complicated, especially when each transaction ID is 64 characters long. But this should give you a good concept of how the algorithms work and why they are so effective. Now, let's explore the benefits of Merkle tree. Merkle trees provide 4 significant advantages. Validate the data's integrity. It can be used to effectively validate the data's integrity. Takes little disk space. When compared to other data structures, the Merkle tree takes up very little disk space. Tiny information across networks. Merkle trees can be broken down into small pieces of data for verification. And efficient verification. The data format is efficient, and verifying the data's integrity takes only a few moments. Now that we know the benefits of Merkle tree, let's explore how it is essential to blockchain. Let's imagine a blockchain without Merkle tree. To get a sense of how vital they are for blockchain technology, we'll focus on Bitcoin because its use of Merkle trees is not only important for the cryptocurrency, but also simple to grasp. If Bitcoin didn't include Merkle trees, for example, every node on the network would have to retain a complete copy of every single Bitcoin transaction ever made You can imagine how much information that would be. Any authentication request on Bitcoin would require an enormous amount of data to be transferred over the network. Therefore, you'll need to validate the data on your own. To confirm that there were no modifications, a computer used for validation would need a lot of computing power to compare ledgers. Well, Merkle-free are a solution to this issue. They hash records in accounting, thereby separating the proof of data from the data itself, proving that giving tiny amounts of information across the network is all that is required for a transaction to be valid. Furthermore, it enables you to demonstrate that both ledger variations are identical in terms of nominal computer power and network bandwidth.
So let's get started and let's see what's in store for us today. So what's in it for you today? We're going to understand why do we need blockchain wallet? What is a blockchain wallet? How do these wallets work? What are the different types of blockchain wallets? Their comparisons and a demo on the usage of these blockchain wallets. And we will try to do certain transactions using these wallets. Now, before these blockchain wallets came into existence, what were the means in order for us to do the transactions and what were the drawbacks? In the old days, the transactions with whatever medium and channels we had, the problems were that the transactions were slow and banks were the central point of failure. Basically, any transaction which has to go through some intermediary channels and has to pass through certain intermediaries like bank, which makes them a single point of failure. Also, there are issues in keeping track of all accounts and balances. Data get jeopardized, manipulated, or even get corrupted across multiple systems where the accounts and balances are maintained. Now here comes into existence what is called as blockchain wallet. Now what is blockchain wallet? A blockchain wallet is a cryptocurrency wallet that allows users to manage different kind of cryptocurrencies, for example, Bitcoin, Ethereum, etc. Now, a blockchain wallet helps exchanging of funds easily. Transactions are secure as they are cryptographically signed. The wallet is accessible from web or mobile devices, and the privacy and identity of the user is maintained. So therefore, a blockchain wallet provides all the features which are necessary for a safe and secure transfer and exchange of funds between different parties. A blockchain wallet is a typical cryptocurrency wallet that allows users to manage cryptocurrencies. It is very similar to the process of sending or receiving money through PayPal or any other gateway which you use today. But now you can use cryptocurrency instead, similar to PayPal, which you're using for making transactions with your fiat currency. Now let's take a look at the ecosystem of blockchain wallets. Here are certain examples like Electrum, blockchain.info, Jax, Mycelium, Samurai, and Bitcoin Paper Wallet. These are just to name a few blockchain wallets which are existing in the market, but there are many more based on the requirement you have, based on the security you require, and based on the kind of wallet which suffices your need. So we will see what are the categorizations of these kind of wallets are. Now, how do blockchain wallets work? Let's take a look. So before we move on to how blockchain wallets work, let's understand what a private and a public key is and how are these keys related to a blockchain wallet. Now, whenever you create a blockchain wallet, you are also provided a private and a public key which is associated with your wallet. Now, let's take an example in order to understand this. Imagine a person knowing your email address is sending you an email. So in our regular day-to-day activity, if we want to receive an email from someone, we give him or her our email ID and expect an email from them. Now, what if an unknown person is able to send emails through my account? So I am giving my email address for receiving emails, but when I am disclosing my email ID, I'm not assuming that someone will be able to send emails through my account, because then for that he has to be aware of my email account password. So knowing your email address will not give a person the ability to send an email from your account. You are not giving your password to the person to send an email. You're just giving the email address. To send an email from a particular email address, an individual has to be aware of the password associated with it. Now, blockchain wallet follows a similar process using public key and private key both together. Public key is similar to your email address. So basically, whenever your wallet is generated, a public key is generated, you can share that public key with anyone in order to receive funds. Private key is top secret. It's similar to your password. It should not get hacked or you should not disclose it to anyone. And you use this private key to spend your funds. Now, instead of sending an email, imagine you want to transfer money to your friend. This transfer process is done through your blockchain wallet. With blockchain wallets, you can now send and receive cryptocurrencies. So as I said, a blockchain wallet has two keys, a public key and a private key. Public key is shared with everyone, just like an email address. Private key is just like your password, which should be kept secret with the sender. So with blockchain wallet, no one will be able to send crypto coins just like emails through your public key until they know your private key. But if someone gets access to your private key, there is a high possibility that your account is hacked and you might end up losing all the cryptocurrency deposits in your account. Now let's take a look. What are the typical features of a blockchain wallet? It's easy to use. It's just like any other software or a wallet which you use for your day-to-day transactions. It is highly secure. It is just a matter of you securing your private key, and it allows instant transactions across geographies, barrier-free, without intermediaries, and also these transactions charges you low cost fee. And these wallets help you do transactions across multiple cryptocurrencies. So you can make payments across cryptocurrencies, which helps you do easy currency conversions. Now let's talk about what are the different types of blockchain wallets. Now basically there are two types of blockchain wallets based on the private keys. One is hot wallet and another is the cold wallet. Hot wallets are like normal wallets which we carry for day-to-day transactions, and these wallets are user-friendly. Cold wallets are similar to a vault where cryptocurrencies are stored with a high level of security. Now let's take a look at the differences. Hot wallets are online wallets through which cryptocurrencies can be transferred quickly. They are available online on internet. Example, Coinbase, blockchain.info. Cold wallets, they are digital offline wallets where the transactions are signed offline and then later disclosed online. So they are not maintained on the cloud on the internet. They are maintained offline to have high security. And the examples of cold wallet are Trezor and Ledger. Now, in case of hot wallets, private keys are stored in the cloud for faster transfer. In case of cold wallets, private keys are stored in a separate hardware which are disconnected from the internet or the cloud, or are stored in a paper-based document. Hot wallets, they are easy to access, available online 24/7. It can be accessed through desktop or mobile, but has a risk of unrecoverable theft when hacked. Cold wallet, this method of transaction helps in protecting the wallet from unauthorized access, from hacking and other online vulnerabilities. Now, the wallet can be further distinguished on these criterias. There can be software wallets, there can be hardware wallets, which are like kind of USB driven and you plug into your USB drive and your hardware wallet can be used, or they are a typical paper-based wallet where you print your public key and a private key on a paper and keep it in a secure place. So let's talk about software wallet. A software wallet is an application that is downloaded on a device. Either it could be a desktop or a mobile, or it could be a web-based wallet which can be accessed online. Now, here are certain examples. Dax, Bread Wallet, and Copay are the popular software wallets. So software wallet can be further categorized into desktop wallet, online, or we can call it web wallets or mobile wallets. Now desktop wallets are like cold wallets in which the private keys are stored in cold servers. Basically, the desktop wallets, the private keys are stored in your desktop. You can unplug it from the internet, do some offline transactions, and then bring it back online. Now, in case the main server is lost, then a cold server, basically your desktop, is used as a backup server. These wallets can be downloaded on any computer but can only be accessed from the system they are installed on. So you make sure the desktop or the machine on which you have downloaded the desktop wallet is safe, has a backup, you're maintaining the hardware, you're not letting the machine go anywhere, and it is on a secure location. Now these wallets are definitely cost efficient, and one of the examples is Electrum and is one of the most popular desktop wallets. Online wallets are the other kind of hot wallets that run on the cloud, that are available on the internet. Now here users have the benefit of accessing these wallets across any device. It could be tablet, desktop, or you can use it from your mobile browser. The private keys are stored online and are managed by a third party. You have to be dependent on a third party service. Now, for example, Green Address is a Bitcoin wallet which is available on the web, has an Android app, is available on a desktop, and also is available on iOS, Apple. Mobile wallets. Mobile wallets are like similar to online wallets, except that they are built only for mobile phone usage and accessibility. These wallets are also user-friendly and they have a user-friendly interface which helps you in doing transactions easily. The example is Mycelium, which is the best available mobile wallet. Hardware wallets. Hardware wallet is a type of a cold storage device, typically like a USB, which stores the user's private key in a protected hardware device. These wallets are similar to portable devices that can be connected to the computer, can be plugged in. As I said earlier, it is less prone to malware attacks, malicious attacks, and it is hack-proof. Examples are NanoLedger, Trezor, and KeyKey are the top hardware wallets available in the market. To make a transaction from your hardware wallet, you have to ensure the hardware wallet is plugged into your computer system before you can do a transaction from your hardware wallet. Paper wallet. A paper wallet is an offline process for storing cryptocurrencies. This wallet is a printed paper consisting of both your private key and a public key, which are accessed using a QR code. Now, since these wallets are safe, they are widely used for storing large amounts of cryptocurrencies. Now, examples are Bitcoin paper wallet and MyEther wallet are one of the widely used paper wallets. But the question arises, how do I add cryptocurrency in my paper wallet? In order to make a transaction with your paper wallet works with your software wallets, the online wallets, to transfer funds from your software wallet to the public address shown on your paper wallet. So basically, first you park your funds in a software wallet, then you transfer the funds from your software wallet to the public address printed on your paper wallet. Now let's do the comparison. Blockchain Info. Blockchain Info is a cryptocurrency wallet which supports Bitcoin and Ethereum. It is easy to use and has a low transaction fee. It has its APIs exposed. You can easily use them in order to make your own custom wallets also. Ledger Nano. Ledger Nano is a hardware wallet which offers a high security to your account. It is available for Bitcoin, Ethereum, and Litecoin users. It is also possible to maintain multiple accounts and access them anytime. Bitcoin Paper Wallet. Paper Wallet helps you to print your own tamper-resistant Bitcoin wallet. It minimizes the threat of hacking. Jax is a software wallet which enables a user to exchange currencies within the wallet. It is available for Bitcoin, Ethereum, Litecoin, and many other cryptocurrencies. With Jax, a user can view his updated balance as soon as the processing is complete. Now let's take a look at certain demos for the different kind of wallets we have talked about. So let's first take an example of paper wallet. So bitaddress.org provides you a paper wallet. It uses the client-side JavaScript in order to generate a random hash for your wallet. So you keep moving your mouse and it will generate a hash, public and private key. It is recommended that when you are doing this process, you should be disconnected from the internet, and once these keys are generated, you can print it and keep it secure and clear the cache of your browser. So as you can see on the screen, this is my public key for receiving my Bitcoins, and this is the private key for me to spend it. I can print it and keep it handy with me. But of course, the safety of these physical documents cannot be entirely guaranteed. If a hacker discovers the location of your paper wallet and physically steals it, then they can access your Bitcoin holdings. So basically, it is of high importance that you keep the paper wallet in a very, very secure location. Some users hide or disguise the paper wallet. It should be protected from physical damage. If the keys fade or can no longer be scanned, then the user will never again be able to access the Bitcoin which are parked in that address. Also take care if you are using an incorrect type of printer, that also may damage the paper wallet. Now let's take a look for our second example of online wallet. Here we are taking an example of BitPay. So you can download BitPay online and create your account over here. You can create a personal wallet, you can create a shared wallet or a joint share wallet. Once you create a wallet, like if you see the example over here, this is my personal wallet and I have 3.645 test Bitcoins over here. Now, in order to receive test Bitcoins in my account, you can receive these test Bitcoins from testnet.coinfaucet.eu-in. Now, in order to receive it, you just need to copy your Bitcoin address in the testnet address. So the test net has given me 0.87 Bitcoin. So now my balance has increased from 3.5 to 3.64 and I can see this transaction. See, 3 minutes ago, I just received 0.872287 Bitcoin. The transaction is still in process, but in a while, as this transaction is getting mined on the testnet, I will receive it. Now, as I have received it, I can even make a transaction and send it to someone. So from my personal account, I can send Bitcoin to someone whose Bitcoin address I have, and I have to just paste it over here. Transfer to Bitcoin wallet. Either I can select one of my own wallets or I can search for any other Bitcoin address which someone has shared with me and I can send it to that particular address. Now let's take an example of our hardware wallet. How does hardware wallet works with the online wallets? So here we have MetaMask, which has a feature of connecting with hardware wallet. So once you have MetaMask installed, you will see this option of connect hardware wallet. Now MetaMask has provided support for Trezor. So now once you connect your hardware wallet, the USB with your computer, you can select an account you want to view on that particular hardware wallet and you can only choose one at a time, and then you can start using that particular wallet for your decentralized apps. So basically, once you have your hardware connected, it is integrated with your MetaMask, and then you can start running your decentralized apps so that they can start using the tokens or the currency in the particular hardware wallet. So use your hardware account like you would with any Ethereum account. Log into dApps and send Ethereum's buy and store ERC20 tokens and non-fungible tokens like CryptoKitties. So if you click connect to Trezor over here, MetaMask will start looking out for the connected Trezor device.
In this video, we will explore Ethereum dApps and will go through some of the fascinating concepts revolving around it. First, we will understand what are dApps or decentralized applications. Then, we will explore what are smart contracts. Then, we will look into the features of dApps. After that, we will figure out why use Ethereum network for building dApps. Then, we will explore the difference between web applications and decentralized applications. After which, we will understand the benefits of dApps development. Then, we will have a look at the dApp tools. After that, we will explore limitations of dApps development.
And at last, we will explore top 5 Ethereum dApps projects. So without further delay, let's get started with the video. So what are dApps or decentralized applications? Decentralized applications are applications built on open source peer-to-peer network of Ethereum blockchain technology, which uses smart contracts and front-end user interfaces to create platforms that are launched and streamlined without intermediaries and centralized authorities. In terms of user experience, it appears to be similar to other available web applications, but they have a lot of differences. What are smart contracts? A smart contract is a form of code that lives on the Ethereum blockchain that runs and functions exactly as programmed, quite similarly to normal contracts. Once these contracts are deployed on the network, you cannot alter them, which means you can't modify or change them. dApps are decentralized because they are controlled only by the logic written into the contract and by not any individual or company, which also means you need to design your contracts very sensibly and carefully. Let's discuss features of dApps which makes them so unique and popular. First is decentralized. This means dApps are independent and cannot be controlled by any centralized authority. Second is Turing complete. dApps can perform any task or action provided by required resources. Third is deterministic. Irrespective of the environment, dApps perform the same function everywhere. And the last one is isolated, which means they are executed in the Ethereum virtual machine, a virtual environment, so that if there's any kind of bug in the smart contract, it won't hamper the normal functioning of the Ethereum network. That makes me wonder why Ethereum, above all blockchain networks, is majorly used for creating dApps. There are several reasons why Ethereum is dominating the majority of dApp development. First, Ethereum is capable of implementing a development interface that can reduce programming time as well as helps in quickly launching to projects. Second, the Ethereum network consists of a remarkably growing developers community since the platform's launch. Third, Ethereum retains tremendous network effects from its global coalition of technologists who continue to pursue the network and actively develop user resources to encourage adoption. And at last, but not the least, the ability to monetize dApp projects adequately stimulates the participation of the others in the Ethereum network. But what makes dApps different from other web applications? Let's have a look at the difference between web apps and dApps. In web applications architecture, there is a front-end client and a back-end server. The front-end is majorly written using HTML, CSS, and JavaScript, and the back-end is written in Django, Node, or Rails. For dApps, the architecture is the same. The front-end is written in the same language as of the web applications, but for back-end, blockchain technology like Ethereum is used. In web apps and dApps, they both interact with each other with JSON messages. Web apps store user information at the company headquarters on a separate server usually. However, dApps consist of data created by the users. The nodes are used to verify the exchange when a user makes a transaction on the dApp. Now let's have a look at the benefits of dApps. First is privacy. dApp maintains the privacy or anonymity of the user, which means you don't need to provide any kind of personal information to deploy or interact with the dApp. Second is complete data integrity. Data stored on the Ethereum blockchain is immutable due to cryptographic primitives. No one can change, forge, or manipulate transactions or other data stored in the blockchain. Third is verifiable behavior. Smart contracts can be analyzed and are bound to execute in directed ways without the need to trust a central authority. Fourth is zero downtime. Once the app is deployed on the blockchain, the network as a whole will always be able to serve its client looking to interact with the contract of the dApp. Now let's dive down and have a look at the dApp tools. Rumble UI, adaptable components and design standards for decentralized applications. One-click dApp. It is a fast tool for generating dApp frontend from an ABI. Etherflow. It is also a fast tool for Ethereum developers to test their nodes and compose and debug RPC calls from the browser. So now when we know everything about the dApps, let's understand the limitations of dApps development. Maintaining dApps can be a tough job because code and data published to the blockchain network is very hard to modify. To achieve the high levels of security, integrity, transparency, and reliability that Ethereum aspires to, every node of its network needs to run and store every transaction, which leads to huge performance overhead. The entire Ethereum network gets backed up if a single dApp is using too many computational resources. And sometimes it may be harder to engineer and configure user-friendly experiences. Sometimes the average user might find it too difficult to set up a tool stack necessary to interact with the blockchain in a truly secure manner. Now let me take you through the 5 best Ethereum dApps projects. MakerDAO, an Ethereum-based protocol that creates the DAI stablecoin and allows for collateral backend loans to be made without the use of a middleman. Uniswap, a decentralized cryptocurrency exchange protocol. Chainlink, a blockchain oracle network that is completely decentralized. Axie Infinity, a blockchain-based trading and battling game that lets its players gather, breed, raise, battle, and trade token-based entities called Axies. And Aave, an Ethereum-based decentralized money market that allows users to lend and borrow a variety of crypto assets. First, we will look into the origin of Ethereum Classic. Then, we will understand what is Ethereum Classic, followed by why is Ethereum Classic used, what are the goals of Ethereum Classic, and after that we will see the difference between Ethereum Classic and Ethereum. After that, we will look at some of the limitations of the Ethereum Classic, and at the end we will explore what is the future of Ethereum Classic. So, without any further ado, let's get started with the video. So let's start with the origin of Ethereum Classic. Slock.it, a German business, created the DAO, a decentralized autonomous organization or DAO initiative on Ethereum in 2016. While the project earned over $150 million through crowdfunding, hackers took advantage of a flaw in its smart contract and stole $50 million. Most Ethereum users, including creators Vitalik Buterin and Gavin Wood, favored a hard fork, or a major modification in the blockchain's underlying protocol, to recover the assets, resulting in the formation of the new Ethereum chain. However, certain members of the community opposed to the fork, preferring to follow the principle of code is law, and remained on the old chain, renaming it Ethereum Classic. They commonly refer to Ethereum Classic as the original Ethereum coin, since it preserves the ancient core of the Ethereum blockchain as it existed before the DAO assault. That brings us to the next concern, which is to understand what is Ethereum Classic. Ethereum Classic is a blockchain-based open source, decentralized distributed cryptocurrency platform that runs smart contracts. Ethereum Classic is a decentralized governance platform that leverages smart contracts embedded within a distributed ledger or blockchain network. It splits the original Ethereum blockchain into 2 parts, with Ethereum Classic being the older of the 2 and Ethereum being the newer one. Now let's proceed further and have a look at the uses of Ethereum Classic. Ethereum Classic has 3 major uses. The ETC, or Ethereum Classic, like other cryptocurrencies, is primarily used to pay for decentralized computations on the Ethereum network. ETC is used to pay for executing transactions and smart contract functions on the Ethereum blockchain. This is referred to as gas, and the fee associated with these actions are known as gas costs. ETC is also a native token with a monetary policy that creates a predictable disinflationary emission schedule with a fixed market supply cap. Now, let's move ahead and have a look at the goals of Ethereum Classic. The Ethereum Classic project has seen several modifications and additions since the split. The project's purpose is to develop a global payment network based on smart contracts that can operate with no centralized authority. Ethereum Classic, like other cryptocurrencies, will most likely aspire to be a digital store of value, meaning you can save and exchange it while maintaining its worth. A crypto's digital store of value includes its purchasing power, which may be swiftly converted to cash or used to purchase another asset, just like money.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now that we know all the major components of Ethereum Classic, let's dive down and have a look at how Ethereum Classic differs from Ethereum. ETC, or Ethereum Classic, is a speculative digital asset that investors may trade. But the Ethereum token, or ETH, is the more genuine and extensively traded of the two. With a market capitalization of $3.9 billion, ETC has 116.3 million coins in circulation, while ETH, on the other hand, has a market capitalization of more than $304.9 billion and around 115.6 million coins in circulation. ETC trades at $33.65, whereas ETH trades for more than $2,600 per coin. Now let's have a look at the limitations of Ethereum Classic. Although Ethereum Classic, like Ethereum, enables smart contracts and targets the same market, Ethereum has grown in popularity as the more trustworthy of the two networks. Despite numerous software upgrades, the scalability of Ethereum Classic's payment mechanism remains one of the project's largest concerns in the future. Furthermore, security is likely to be an issue with smart contracts, especially because Ethereum Classic has already been hacked and millions of dollars stolen. So this brings us to the very important question, that is, what future Ethereum Classic holds for itself. Because Ethereum is considered the more authentic of the two networks, Ethereum Classic's future appears to be less bright than Ethereum, especially given Ethereum Classic's security concerns. Ethereum Classic may have difficulties until it can modify its code and software to prevent future hacks. Well, this was all about Ethereum Classic. In this video, we will explore Ethereum 2.0 and will go through some of the fascinating concepts and components revolving around it. First, we will have a quick introduction of what is Ethereum network. Then, we will look into what Ethereum 2.0 is. Then, we will understand what led to the origin of Ethereum 2.0. Then, we will understand the changes in Ethereum 2.0. Then, we will look into the current status of Ethereum 2.0 research. And at last, what future we expect for Ethereum 2.0. So without doing much ado, let's get started with the video. So what is the Ethereum network? Ethereum is defined as a blockchain-based computing platform that enables its developers to build and deploy decentralized applications. Ether is the cryptocurrency for Ethereum, used to build decentralized applications, smart contracts, and make standard peer-to-peer payments. It tracks and facilitates all the transactions and makes sure they are cryptographically secure in the network. Ether basically acts as a fuel for the Ethereum network. So what is Ethereum 2.0? Ethereum 2.0 is a set of interrelated upgrades that will make the Ethereum network more secure, scalable, and sustainable. Multiple teams from across the Ethereum ecosystem have come together to work on these upgrades in Ethereum 2.0. Then, what led to the origin of Ethereum 2.0? With growing popularity, Ether and the Ethereum network has gotten more blocked by transactions. Currently, it is capable of handling 15 to 45 transactions per second, which is comparatively impressive, but it is not enough to handle all of Ethereum's users worldwide. Also, the high demand is affecting the driving up of transaction fees. Nodes power the Ethereum blockchain network, but currently its nodes are experiencing too much volume. Although the programmers working on the upgrade have claimed that making its nodes bigger wouldn't be practical. Ethereum 2.0 intends to make the network more scalable to handle all of the activities on the Ethereum network. That makes us wonder, what are the changes in Ethereum 2.0?
The two significant changes that will come with the upgrade are adopting proof of stake and sharding. Adopting proof of stake, Ethereum blockchain implementations suffer from performance issues because they rely on a processing power intensive process known as proof of work to record and validate their transactions. The problem with proof of work's design is that it's very inefficient. Ethereum 2.0 will solve these issues by transitioning its blockchain to a more efficient proof of stake system. It will decrease the complexities faced by the network, leading to massive throughput gains for the whole network. Sharding is a process that intends to enhance Ethereum's efficiency and ability to scale. In the current version of Ethereum blockchain, all data that is added to the chain undergoes verification by all participating nodes. That means that the speed of its slowest participant limits the processing speed of the entire network. Sharding will increase the efficiency of the network resources by breaking data verification tasks among its set of nodes. And each of them will be responsible for validating and verifying just the data allotted to them. This will increase the network's overall capacity and make it much faster and efficient than its outdated version. So what is the current status of Ethereum 2.0 research? While Ethereum 2.0 has been in research and development since 2014, it has actually been making some progress. The Beacon chain went live in December 2020, introducing the staking concept, but still there is no official claim for the completion of this transition. The next phase is mainnet, merging the Beacon chain into the current Ethereum network. Mining Ethereum tokens will officially end in this phase, and staking will become the primary way to create new tokens in the Ethereum network. The last part of the transition is expected to unfold in multiple phases, like adding the shard chains to give the Ethereum blockchain network more capacity and efficiency to handle all of the demand and increase transactions per second. Although it has been a long road and there is still a good deal of uncertainty around the timing, the Ethereum developers do seem to be motivated and on their way to completing the whole transition. So, what is the future of Ethereum 2.0? If executed properly, this transition to Ethereum 2.0 could be a total game changer. It will create a modified network that could potentially process 1 lakh transactions per second and a much more sustainable network without the energy-intensive mining process. And it will introduce smart contracts worldwide, increasing the Ethereum's network utility. Furthermore, Ethereum co-founder Vitalik Buterin once said that the issuance of new token should be highly reduced under Ethereum 2.0, which could increase its demand. Given all these factors, Ethereum 2.0 seems to hold a bright future for Ethereum blockchain network.
Let's proceed further and have a look at how they both differ from each other. Did you know there are more than 1600 cryptocurrencies worldwide? And among them, Bitcoin and Ethereum have always been the top two most popular cryptocurrencies in the world by market cap. Also, recently, Ethereum as well as Bitcoin reached its all-time peak in worldwide trading. According to Decrypt.co, every day new companies like Me2 and PayPal are coming forward to invest in Bitcoin and Ethereum. On March 7, 2021, Me2 confirmed that it had purchased 40 million in Bitcoin and Ethereum. On the other hand, PayPal is about to launch a scheme where the public can purchase and sell cryptocurrencies, initially featuring Bitcoin and Ethereum via PayPal digital wallet. But have you all ever wondered how they compare based on their similarities and differences in various aspects? Well, before moving any further, let's have a quick look at how Bitcoin and Ethereum originated and made a benchmark in the economic system worldwide. Bitcoin was first introduced in 2009 by Satoshi Nakamoto to resolve cyber attacks, double spending, and eliminate the middleman between the transaction. It led the first revolution of digital money, which enables transparent and decentralized peer-to-peer transaction. On the other hand, Ethereum came into the picture years after Bitcoin. It was first introduced in the late 2013 by Vitalik Buterin. After that, it was very quickly and widely adopted because it offered a platform to build and run applications without any downtime, fraud, or interference of any third party. Ethereum serves as a computing platform that enables its developers to build and deploy their decentralized application. Now, let's move ahead and see the difference between them which make them compete with each other in this economy. This video will cover individual aspects for comparing Ethereum and Bitcoin's performance in that particular field. First, we will look into the introduction of Ethereum and Bitcoin. Then the algorithm they follow, the programming language, mining process of Ethereum and Bitcoin, monetary policy, transaction, and availability of these two cryptocurrencies. By time, Bitcoin has proved itself as a well-known cryptocurrency. However, Ethereum with different functionalities is giving a quite tough competition to Bitcoin. But before moving ahead, let's have an introduction to Ethereum and Bitcoin. Ethereum is a platform that builds immutable smart contracts, an application for its users without any centralized interference. For Bitcoin, it is an alternative to fiat money or physical currency. The main function of Ethereum is to provide its users or developers with a platform to build smart contracts using dApps or decentralized application. On the other side, Bitcoin only intends to be a medium of exchange of money and value stored in its blockchain network. Now let's get started and move towards the first comparison, which is algorithm. Ethereum uses the Ethash cryptographic algorithm for mining blocks in the Ethereum network. On the other hand, Bitcoin uses the SHA-256 hashing algorithm for mining blocks in the Bitcoin network. Ethash algorithm is mainly used during the proof of work function. Proof of work is a small piece of data that is difficult to generate but easy to validate and satisfies certain network requirements. SHA-256 algorithm helps Bitcoin users to protect all their sensitive data like private keys. Moving on, the programming language of Ethereum and Bitcoin. Ethereum uses Solidity. Solidity is a high-level programming language used by Ethereum for implementing smart contracts. But in terms of programming language, Bitcoin keeps it simple. Bitcoin uses C++ as its programming language. It is a stack-based programming language used to give Bitcoin software instructions on how to make transactions. As we have covered the algorithm and programming language of both cryptocurrencies, now let's take a look at the mining process of both. Mining is a process in which transactions made are validated and added to blockchain public ledger in blocks, and the people mining these blocks are called miners. Ethereum miners mine the unvalidated transaction using the proof of work method, but it aims to switch to proof of stake because it will make its network more immune to centralization, energy efficient, and stronger support for its shared chain. On the other hand, similar to Ethereum, Bitcoin miners also use the proof of work method to mine unvalidated transactions. These method is enough to function in Bitcoin network worldwide. Now let's proceed towards the monetary policy of both cryptocurrencies. But let's first understand what monetary policy is. Monetary policy is known as the process of drafting, announcing, and implementing the plan of actions taken by the competent monetary authority to control the money supply and achieve goals that promote sustainable economic growth. So, Ethereum's policy is defined by the reward paid out by its protocol. Ethereum's monetary policies are best described as minimum issuance to secure the network. Therefore, there is a constant trade-off between the transaction speed and security. But Bitcoin's monetary policy comprises of two parts, halving and block frequency. Halving event is when the reward of mining Bitcoin is cut in half, and it also cuts the inflation rate. And the block reward is the number of Bitcoins you get if you successfully mine a blockchain block. The current block reward for Ethereum is 2 Ether per block, and for Bitcoin, the block reward is 12.5 Bitcoins per block. Also, every 14 seconds, a block of Ethereum is generated, and one block of Bitcoin takes 10 minutes to generate. Monetary policies are considered to be fixed and non-inflationary. Due to this, over time, mining blocks will become more difficult. Next is transactions. Ethereum is a little bit faster than Bitcoin. with 30 transactions per second, and it takes just a few minutes to confirm it. On the other side, Bitcoin's transaction speed is 5 transactions per second, and it can take up to 60 minutes or more to confirm. Ether, the currency of Ethereum, acts as the fuel for Ethereum networks, and Bitcoin is only used as the value for real-world transactions. To compete with already present electronic cash like credit cards and Google Pay, Ethereum and Bitcoin require higher productivity to attain widespread adoption. Now, talking about the availability of both cryptocurrencies, Ethereum is not limited, but it can occasionally reduce due to large network upgrades. However, Bitcoin is limited to 21 million coins, and as of today, 18 million Bitcoin is already used. But in the end, both Bitcoin and Ethereum, being the top cryptocurrencies, share a few similarities. Like both are decentralized and can be used to have a peer-to-peer transaction, proof of work. Also, both have a large network of independent nodes.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now, let's have a demo. Now, let's have a look at the media outlet website CoinDesk, where we will see all stats related to Bitcoin and Ethereum in detail. CoinDesk is a site specialized in digital currencies. It is used to explore the news and price data related to cryptocurrencies, and also explains how cryptocurrencies contribute to the evolution of financial system worldwide. Now, see this graph. This graph shows the change in Bitcoin price in 24 hours duration. This graph shows the gradual change in the price of Bitcoin. It started from $64,439.29 on April 14 at 12 p.m. And right now, by April 15 at 6 a.m., it is at $63,189. The rate of change is minus 0.46%, which shows the change in the price of Bitcoin per hour. Let's have a look at this graph of Ethereum too. The value of Ethereum started at $2,388.13 on April 14 at 12 p.m. and the current status on April 15 is positive with a value of $2,442.37 with an increasing rate of 4.67%. Down below, we have a metrics table that shows the change between the starting and ending value of Ethereum, the total supply of a cryptocurrency in 24 hours, the total number of transactions that occurred, and the average transaction fee for all these transactions. Now, this graph shows the current status of cryptocurrency in USD dollars. We can also see its value according to any centralized currency like Euro or INR. This graph shows the constant trading change in the value of cryptocurrencies every moment. We can also access the data of trading from an hour to its lifetime.
Blockchain prospects. Let's have a look at the objectives of this lesson. By the end of this lesson, you will be able to identify the use cases of blockchain in healthcare industry, identify the use cases of blockchain in government organization, identify the use cases of blockchain in finance industry, identify the use cases of blockchain in other industries worldwide. Do we need blockchain? Our first concern must be whether the traditional database system can meet our use case needs. In case it does, we wouldn't need fast, secure transactions, and thus we won't require a blockchain. Always in the ledger system, there would be many people involved. And if they are not ready to trust a third party and need to keep their data private, then the best option would be to go for a permissioned blockchain. Permissioned blockchain would also allow to control the permissions in blockchain software. In case redundant copies are required to be saved in multiple distributed computers and do not have the need to keep the data private, we could have a public blockchain. Challenges in blockchain. Following are some of the challenges in blockchain. Initial cost. Miners use giant computer rigs with several servers to keep the network ticking over, and that consumes a lot of electricity, which is not affordable. Second major factor is the energy consumption. Proof of work consensus mechanism is very wasteful as a computing algorithm. The year 2017 saw a significant increase in Bitcoin network activity, and estimates show a combined yearly energy consumption rate of 70 terawatt hours for Bitcoin. Blockchain security issues. A blockchain pulls its security profits from the decentralized nature of its nodes that verify transactions on the blockchain. But owing to the design of blockchain technology, all public blockchains are exposed to 51% attacks. Blockchain privacy issues. If a blockchain is public, anyone could look at the transaction recorded on the blockchain. The information available in the public domain runs against long-standing norms, especially in healthcare, legal, and financial sectors, which have the typical privacy requirements. Public perception. The biggest disadvantage of blockchain has been the perception it holds in the eyes of the people. People don't see it as a part of conventional functioning. Most don't believe that blockchain technology will last for long. Integration with legacy systems. The integration barrier with legacy systems is also a main issue with adopting blockchain. All the traditional systems would be using different data formats and models for storing data and would be working in isolation. Most of these systems are tightly packed and would have very less models of integration with blockchain. Identifying a blockchain use case. So we need to understand what kind of use cases could be used for blockchain. It should have a business problem that requires blockchain technology to solve it. Blockchain provides a real-time view of the data to people who can join the network as a participant to verify the transactions and data. A business use case for data exchange that has trust issues. Thus, an identifiable business network needs to be chosen. To establish the trust, there are often manual bunch of business verification processes which are established. Verification steps result in additional operational cost and time. Verification time delays the consequent business processes that are depending on this data. So a blockchain could be used where the verification could be done by consensus algorithms. Healthcare use cases. Patient data management. Here's how it goes. The user agrees to share its health data by giving permission. The health wallet would create an address which stores as smart contract on blockchain. When researchers wish to access data, they check the permissions in smart contracts to check whether the use of the health records is allowed. If yes, then they access the data, record the transaction on blockchain, and make the payment to the patient's health wallet. HealthCoin payments is transformed to money, which could be used to purchase medical services. Drug traceability. Blockchain could also be used in drug traceability. When the manufacturer manufactures the drug, it marks it with a unique code. The information is stored on blockchain and a hash is produced. It sends the drug to the wholesaler. The wholesaler then verifies the origin of the product, and this transaction is stored on the blockchain. The wholesaler further sends the drugs to the pharmacist and then later verifies the origin of the product again. Like all other transactions, even this transaction is stored on the blockchain. The pharmacist delivers the origin of the product. So this way, the drug could be traced effectively using blockchain. Government use cases. Blockchain in voting. In this application, the voter logs into the user interface to cast its vote. The identity verifier receives the ID, verifies that it is unique, and authorizes the ID key to vote on a certain ballot type. By casting votes in the form of transactions, we can create a blockchain which keeps a track of the tallying of votes. This way, everyone can agree on the final count of votes based on a consensus because they can count the votes on their own, and because of the blockchain audit trail, they could easily verify that no votes were changed or tampered with and no dishonest votes were added. Using this solution, the voter would be authorized to cast its vote by the registrar and ID verifier. Using VoteKey, the voting booth UI generates the ballot for the voter to cast their vote. All right, that was how blockchain can be used in voting. Let's have a look at another interesting example. Tax processing. Let's see how a tax processing GST without blockchain works. A GST invoice is issued by the seller. Buyer pays the bill with GST. Seller pays to the supplier. Information of payment is recorded on GST portal. Final tax goes to the government. Additional payment is adjusted. So that's how the tax processing works without blockchain. Now we'll see how blockchain could be implemented in such a system. During the payment for a good or service, blockchain smart contract can calculate the invoice based on the tax amount that is already levied during the production process. Smart contract directly transfers the tax amount to tax authority. The refund, if any, is directly paid to the customer's account. Blockchain in land registry. Citizen initiates a request to sell hall or notary. Now, if you go by the current scenario, the centralized database is used, which has risk of data manipulation. Also, since there is a paperwork involved, there are chances of risk or loss, damage, and forgery. But if you use a blockchain-based platform like Is Fantom, there is a guarantee of further immutability, and the public data can be changed only by the owner. So these were some of the use cases in government organizations. Blockchain in KYC. Here's how blockchain can help in KYC system. It permits for the secure transfer of a KYC verification stamp from one entity to another, as it is unparalleled in distributed version control of ledger contents. It offers highly immutable and detailed audit trail on all actions on KYC files. Centralized blockchain-based KYC. Banks could also be linked to a centralized KYC repository along with the lines of the current KYC registry system. In this arrangement, customer data and documents are stored in the distributed ledger, and the bank that performs the KYC stores all the relevant details and generates a unique KYC number. When another bank wants to perform due to persistence on the same customer, it can use the unique KYC number to access the central registry and download customer details from the blockchain. Blockchain in trade finance. By applying blockchain technology to trade finance, technology infrastructure companies could reduce the complexity and increase efficiency in large scale. Here's how blockchain can be implemented in trade finance. Upon purchase, the agreement of sale between the importer and the exporter is shared with the import bank using a smart contract on the blockchain. In real time, the import bank will have capability to review purchase agreement, draft terms of credit, and submit obligation to pay to the export bank. The export bank will review the provided payment obligation, and once approved, a smart contract will be generated on the blockchain to cover terms and conditions and lock in obligations. After receiving the obligations, the exporter will digitally sign blockchain equivalent letter of credit within the smart contract to initiate shipment. Goods will be inspected by third parties and the custom agents in the exporting country, and their actions will have a digital signature of approval on the smart contract. During transit, goods will be transported from country A to country B. Upon delivery, importer will digitally acknowledge receipt of goods and trigger payment. Using provided acknowledgement, smart contract will automate payment from importer to exporter via a smart contract. Next, we have blockchain in mortgage industry. Blockchain in mortgage industry. Here's how blockchain can improve the system. The process flow for mortgages is given in the steps below. 1. Buyer applies for property valuation to mortgage solutions. 2. Property valuation report is validated according to business rules using smart contracts and is submitted to Mortgage Solutions. 3. Mortgage Solutions forwards the request to the buyer. 4. Buyer applies for a loan to the bank. 5. Bank requests the generation of a report from title search and municipality. 6. Mortgage smart contract redirects requests automatically to the respective parties. A. Title search report is created and submitted back to Mortgage Solutions. B. Tax report is prepared and submitted to Mortgage Solutions. 7. Smart contract checks the reports and forwards it to the bank. 8. If all the conditions are valid, the bank approves the loan. 9. Buyer and seller sign the required agreements. 10. Agreements are submitted to the bank. 11. Sales proceeds and loan is dispersed to the seller's bank. 12. Seller's bank credits the seller's account. Blockchain in loan management. The use of blockchain technology allows much faster approval for loan applications and credit cards, something that is presently long-winded and expensive for lenders to do. The use of credit scores, paychecks, and bank statements might become less important to approve a loan. Thanks to the availability of smart contracts, lenders are able to authorize transactions, confirm if the counterparties are legit, and perform routine account administration tasks from time to time, making it cost-effective and accelerating the process. Blockchain in Estonia. Blockchain secures the health records in estonia.com by taking account of every update and keeps a record of all the transactions of the stock market. It stores information of birth certificates, business contracts, and also marriage registrations. Blockchain in energy markets. Blockchain facilitates secure transactions of power between individuals on a distributed network who do not have an existing relationship. Grid is based on an open source, cryptographically secure, decentralized application platform. All energy transactions are logged. Prosumers generate power beyond their needs and feed it into the grid using blockchain. Smart contracts automate agreed trading relationships. Commercial transactions are auditable, improving trust. Pre-trade agreement can be arrived using blockchain. Carbon credit certificates can be issued in blockchain, which incentivizes green energy creation. Blockchain in media. Ujo Music. Following are problems in media. Comprehensive database of music copyright doesn't exist. Royalty amount takes longer than usual to reach the music makers. Blockchain can be used in media platforms where the royalties could be calculated in a fast, transparent, and secure manner, especially using blockchain platforms like Quorum, where thousands of transactions could be processed in a second. Even Ethereum-like public blockchain platforms could be used to make decentralized music platforms that make it tamper-proof and an easily auditable database. Blockchain in travel. Locktrip. Locktrip. It is a blockchain-powered marketplace where property owners can rent their property globally, collect money, and manage bookings without paying any commissions to middlemen. Blockchain in travel industry has also revolutionized the way hotel booking payments work by not giving any commission to the hotel or third-party vendor, unlike the traditional travel agency systems. The blockchain would be a decentralized system and would be free to use, thus reducing the cost and additional overheads. Blockchain in supply chain. Let's have a look at the traditional approach of order placement. In a traditional approach of placing order, the following steps are involved. Customer places an order on the website. A member of the sales team receives the order and dispatches it to the shipping department. A member of the sales team receives the order and dispatches it to the shipping department. The shipping clerk picks the order and proceeds for shipment. Your order gets boxed and shipped to your address. Customer gets satisfied and submits the product review on the website. Now comes the blockchain in supply chain. Introducing blockchain smart contracts in supply chain modifies the traditional ecosystem of transport goods from the wholesaler to retailer and then to the end user. The transactions of supplier, order, invoice, and shipment would be stored in the blockchain database, which makes it tamper-proof and a secure way of managing shipments. Blockchain for network security, Korea Telecom. Blockchain could also be used to improve cybersecurity. Blockchain would provide permissioned access control, traceability of transactions, and also data recovery by the usage of smart contracts. Data provider can use encrypted data transmission for 1. Registration of data attributes and ID information, 2. Setting of access rights and automation of processes, which can then be integrated with blockchain API. Data exchange can take place on blockchain. This will prevent fraud and data theft. Bigger blockchain networks with more users have a substantially lower risk of being prone to hacks because of the complexity required to penetrate such a network. Data can be accessed by the users via a secured channel with data access authentication over a wide area network.
That is the reason to learn blockchain. So at the 10th position, we have entertainment for all. Blockchain is the ideal technology for eliminating middlemen from the content distribution process. For example, an artist may use blockchain to upload their song to the cloud as an encrypted file. The song can then be requested directly by an interested listener for a fee. The creator can directly distribute a copy of their content to the consumer thanks to the peer-to-peer networking infrastructure. For example, we now utilize Spotify and Saavn to stream and listen to music. These apps too serve as intermediaries. Now, every time you listen to a Taylor Swift song, money goes to Spotify, leaving the singer with a very small royalty. To avoid this, the artist can submit their music to the cloud as an encrypted file using blockchain. The song can then be requested directly by an interested listener for a little fee. Then, at the 9th position comes transparency and improved governance. A transparent and responsible government is the most critical aspect of any country's ability to function. Almost the majority of the country's governance is opaque, meaning citizens are not involved in the procedures or decision making. So transparency and legitimacy can be achieved by incorporating blockchain into governance systems such as taxes, elections, welfare, healthcare, and so on. Countries such as Germany, the United Kingdom, and Australia are already developing plans to include blockchain into their governing operations in order to verify tax compliance, keep digital documents, and make welfare payments, among other things. Dubai, on the other hand, has already successfully integrated blockchain into its official activities, making it the first government to do so. After that, at the 8th position, we have cryptocurrencies and ICOs. If you have a genuine interest in investing in cryptocurrency, you must have a solid understanding of the blockchain and distributed ledger technology systems. This is due to the fact that blockchain is the underlying mechanism for such currencies. Hence, dealing with them necessities and the use of blockchain. If you understand how blockchain works, you can make wise investments. Learning blockchain will also help you better understand and shortlist ICOs. Then at the 7th position comes career in cybersecurity. An individual can also claim greater ownership and control over their digital identity using the digitally encrypted key, because cybersecurity is one of the most important needs in the tech industry. Learning blockchain can help you understand your cybersecurity profession. And one of the most compelling reasons to understand blockchain is its role in cybersecurity, blockchain technology's decentralized structure make it impervious to hacker attempts aimed at compromising sensitive data. Blockchain delivers superior security than traditional storage options, which rely on centralized and highly secure storage. Then comes at the sixth position, we have high demand for blockchain technology. Since its inception, blockchain has continued to attract attention, credibility, and appeal. The market need for blockchain has increased every year according to statistics. This indicates that blockchain will continue to be a domain with career possibilities and business application in the coming years. Now, at the fifth position comes digital identity. Now, except for our grandparents and great-grandparents, there must be very few among us who do not utilize digital banking or transaction services. This digital revolution has also provided infamous hackers with millions of opportunities to commit cybercrime. As a result, our digital identities were put into jeopardy. Now, blockchain will establish a strict cryptographic system that will make hacking and accessing information difficult. Additionally, a person's digital identity is preserved, i.e., there will be just one online identity that may be used wherever. Identity will be validated and documented in a blockchain, and no one can commit digital fraud by generating bogus identities. After that, at the fourth position comes new age technology information. Blockchain provides a universal architecture that can be easily integrated with both old and new technologies. It can be used for voting, banking, commodity trading, and supply chain management, among other things. Furthermore, the blockchain smart contracts and distributed ledger system concepts are ideal for the Internet of Things. Now we have reached the top 3 reasons in which at the third position we have the inflection point of an era. Blockchain is said to create an inflection point of an era where many significant players such as Citibank, MasterCard, CIBC, Visa, SBI, Standard Chartered, Western Union, Accenture, JP Morgan, and others are believed to have integrated blockchain technology. This signifies that blockchain will become a widely acknowledged technology in no time. It will also open the floodgates to a slew of new job openings. As a result, it is preferable to ride the trending wave and enjoy it while it lasts. Now, the second position, we have diversity of job roles. The second key point to consider when learning blockchain is the wide range of blockchain-based employment. Blockchain encompasses a wide range of sector as well as technical skills. As a result, blockchain talents not only boost an individual's proficiency in a certain technical function, but also their ability to produce business value. A closer look at the several major employment titles in the blockchain landscape might help to clear up any misconceptions about whether or not blockchain is worth learning. Now comes the first and foremost reason to learn blockchain, and that is promising career. Since its introduction as a new concept of running a cryptocurrency network, blockchain has grown in popularity. As a result, there are an increasing number of employment openings for blockchain experts. Blockchain professionals have titles such as blockchain developer, cryptocurrency analyst, blockchain consultant, blockchain solution architect, senior software engineer, research analyst, and so on. As of 2021, a blockchain professional's average compensation ranges from 1,21,875 USD to 1,85,250 USD. Now, blockchain will become more mainstream in the future years, offering even more work prospects for people. To sum up, blockchain has a massive global impact. The benefits of learning blockchain go beyond professional potential and include opportunities to gain new skills. So by understanding blockchain, you can get a job in a variety of professions and build a reputation as a blockchain cybersecurity expert. Photochromic. As we move into the Web3 and Metaverse eras, online identity is becoming just as vital as offline identity, and blockchain is inevitably playing a role. Take Photochromic, or for example, which develops a biometrically controlled form of self-sovereign identities on the blockchain by merging NFTs with user identity. Photochromic's goal is to make identification programmable, verifiable, universally addressable, and digitally secure. Photochromic addresses the current challenges that individuals around the world are facing as they seek ownership of their identity and the capacity to protect it. Photochromic returns control and ownership of a user's identity to the person who created it. So next in the list we have Phemex. While blockchain and cryptocurrency are global concepts, there are a number of intriguing regional ventures. In just 2 years, Phemex has amazed over 1.5 million users, making it the most popular crypto trading platform in the world. The company is also known for its viral promotions such as the Era of Zero, which provided zero-fee trading for spot orders in 2019, and Bitcoin Pizza Guy, which was launched in 2020. Phemex popularity will only increase in 2022, and we can anticipate more innovative trading and viral promotions in the future. Then we have is AIOZ network. On the emerging Web3 scene in 2022, we will see more use of blockchain apps. Projects like AIOZ network, a Web 3.0 media infrastructure, will help to achieve this. Artificial intelligence is used to optimize this network's decentralized content distribution network, which is powered by peer-to-peer edge nodes. Decentralized application for videos, audio, live, and metaverse streaming can use the blockchain infrastructure because of these features. Following that, we have Flare Finance. The decentralized finance field is rapidly expanding, but there is still a need for a solution that can link all of the ecosystem together. Flare Finance, which will be the first DeFi platform on the Flare network, might soon evolve into a full-fledged DeFi platform. The Flare Finance ecosystem will connect communities together and return the power of finance to the people through F assets and Y assets. Moving on, we have Scallop. As the use of Bitcoin becomes more common, more services like Scallop are developing to make the transition easier. Scallop is a 10-product next-generation banking platform that includes banking, accounts, wallets, and NFT marketplace. Scallop is a one-stop shop for banking and cryptocurrency solutions. Scallop allows for any form of transaction with full banking accounts for fiat currency, cryptocurrency wallets, and an inbuilt exchange. Scallop also has a native blockchain that will go live in the coming months and will be used to underpin its banking environment. The Scallop app will be available in Europe on November 29, 2022. Next coming on the list, we have SpaceY. Let me tell you, this project has my personal interest as well. So these days, blockchain technologies are also being used in the gaming industry. Take for example SpaceY 2025, the first 3A tower defense blockchain game themed on colonizing and protecting Mars, with the backstory based on Elon Musk's Mars mission. It is being built by a Blockfish team, which was behind such blockchain and gaming services as Tencent and EA Studio, as well as titles like Roblox, Death Stranding, and The Sims 3, and is a fan favorite since its launch. Not only have numerous influencers, players, and community supporters been thrilled about SpaceY 2025,
but so have high-profile investors like Ash WSB, Draper Dragon, Formless Capital, UB Ventures, and Magnus Capital. Spacefy 2025 has Blockfish's first 3-year flagship game, might usher in a new era of chain game creation in 2022 and beyond. Next up is Sushiverse. Non-fungible tokens and blockchain gaming are two areas of the blockchain business that have taken off. Sushiverse combine all of these elements in a blockchain-based online game that pits virtual sushi avatars against each other in battle and contest. All of the sushis in the Sushiverse ecosystem are one-of-a-kind NFTs with the potential to appreciate in value as they compete. It has gained thousands of members since its start, released a limited edition collection with renowned digital artist Laya Matikshara, and is expected to develop even more in 2022. And the last but not the least, we have Extend Agency. Because of agencies like Extend Agency, there is much more order and professionalism around product launch, as more initiatives are launched in the more mature blockchain and crypto market. Extend is a marketing and public relations firm that focuses on assisting entrepreneurs with the launch of DeFi, STO, and NFT. Extend seeks to offer credible and usable assessments on industry trends, as much of the crypto and blockchain sector is based on conjecture about the next big thing.
In this video, we will come across some of the very important aspects needed to become a blockchain developer. Like, first of all, we will understand who is a blockchain developer. Then we will understand what are the types of blockchain developer. After that, we will look into the technical skills needed to become a blockchain developer. And then we will understand what are the roles and responsibilities of a blockchain developer. Then we will have a look at the companies hiring blockchain developers. And at last, what is the average salary of a blockchain developer in both the USA and India? So let's get started with who is a blockchain developer. A blockchain developer is a person who is responsible for developing and hence enhancing blockchain-related applications, famously known as dApps, smart contracts, architecture, and protocols. For those who don't know what blockchain is a system of recording details of transactions in a block taking place in the blockchain network. That makes it difficult or impossible to change or hack, which means they are immutable. A blockchain is essentially a digital public ledger of transactions that is copied and distributed across the entire network of computer systems on the blockchain. Basically, blockchain developers enable secure digital transactions by creating systems and applications to record and store blockchain data and prevent external changes or hacks. That brings us to what are the types of blockchain developers. There are two types of blockchain developers: core blockchain developers and blockchain software developers. Each type has its specific type of role. Let's go through them in more detail. The core blockchain developers design the protocols required to run a blockchain solution successfully, which means they are majorly responsible for the architecture development of blockchain. They are also responsible for designing consensus protocols and making high-level decisions. Blockchain software developers develop and implement the blockchain using the designs and solutions created by the core blockchain developers. They are majorly responsible for designing and implementing smart contracts and developing decentralized applications or dApps. Now let's understand what are the technical skills required to become a blockchain developer. To become a blockchain developer, you need to have a specific set of technical skills. Let's take a look at them. Understanding blockchain architecture. For starters, you should have a complete understanding of blockchain technology, its architecture, how it works, and its critical concepts like hash functions, distributed ledger technology, and consensus protocols. Next, data structure and coding. Data structures and coding are considered the most basic and essential skills required to be a fine developer. It is a must-have skill to become a blockchain developer, as it enhances your ability to play and configure blockchain according to your requirements. Development of smart contracts. Smart contracts is the most vital part of blockchain technology. The programming language Solidity is used to create smart contracts. Ethereum is the best example for smart contracts. It helps you set up the business and develop and deploy dApps using smart contracts. And at last, basic knowledge of cryptography. Blockchain secures its data by using highly effective cryptography algorithms. Cryptography helps you implement dApps and other blockchain services. Now we have covered the technical skills required to become a blockchain developer. Let's explore the roles and responsibilities of a blockchain developer. Both core blockchain developer and blockchain software developer have different roles and responsibilities. First, we will discuss the roles and responsibilities of core blockchain developer. Core blockchain developer understand and implement the features and functionalities of blockchain. They design protocols and consensus protocols for blockchain networks. They create solutions for providing security to the data stored in the blockchain network. And they make sure that the blockchain network functions smoothly and securely. Now, blockchain software developer design and implement smart contracts. They develop and deploy decentralized application or dApps as per the requirements. Also, they look after the integration with other applications and services. Now let's dive down and explore the companies hiring blockchain developers. There is a massive demand for blockchain developers, and if you know your skills well, you will surely get a good start with your career as blockchain developer. Joining a programmers community and working on real projects will help you learn, grow, and upskill yourself. According to 2021, SignSoft, a software development company, Ripple Labs Incorporation, an American technology company that deals with the Ripple payment, Leeway a software development company for startup and enterprises, Chromaway, a blockchain technology company, OpenLedger, a decentralized financial platform used to convert bitcoins to smart coins, and IntellectSoft, a company specialized in providing software products and integrated solutions, are a few top companies who hired blockchain developers to work on blockchain technology. Now that we know about the demand of blockchain developers worldwide, let's figure out the average salary of a blockchain developer in both the USA and India.
Imagine paying your pizza bill using bitcoins. Sounds crazy, right? But you see, back in 2010, when Bitcoin was just a new digital currency, a person named Laszlo did something that would go down in history. Imagine this. This guy Laszlo sitting at his computer craving some pizza. Instead of grabbing his wallet, he had a wild idea. He wanted to see what he could do with this new thing called Bitcoin. So he said, I'll pay for 2 pizzas with Bitcoin. At that time, Bitcoin wasn't worth that much. But someone else who liked Bitcoin said, sure. And just like that, Laszlo got 2 hot pizzas all because of his digital coins. But get this, Laszlo didn't use just a few Bitcoins. Nope. He actually used 10,000 Bitcoins for those pizzas. Now those same Bitcoins would be worth over 800 millions today. That's some expensive pizza. Alongside Bitcoin's journey, another new tech is catching attention. Pi Network. It's quite a promising project and has over 100 million users. So in this video, we will cover what is Pi Network, what makes Pi different from others, how Pi works, Pi Network's price, and what is the future of Pi coin. Alright, so let's first understand what is Pi Network. So imagine you are playing a game on your phone, and the more you play, the more coins you earn. These coins can be used to buy cool stuff within the game or even trade with your friends who are also playing. That's kind of like how Pi Network works. You do simple tasks on your phone and in return you earn Pi coins. Then, when Pi Network is fully up and running, you will be able to use those coins for different things. Just like in the game. Pi Network, created by Dr. Nicholas and Dr. Shingadio in 2019, is a cryptocurrency project. It wants to let anyone mine and own cryptocurrency using a phone app. People can mine Pi cryptocurrency on their phones without causing much slowdown. This method is unlike regular mining, which needs a lot of computer power and energy. So you don't need a fancy and power-hungry mining machines. But hold on, this app is like a new store that's still being built. So you can't actually spend the Pi coins yet. The more people who join, the more valuable the Pi coins might become someday. But it's not for sure. Just like the new store might not have many things to buy yet. Alright, so this was about the Pi network. Now let's understand what makes Pi different from others. So Pi network stands out from others cryptocurrency in few ways. First is mobile mining. You can mine Pi coins using your phone app, unlike most cryptocurrencies that require strong computers. It's like finding gold nuggets with your phone instead of a pickaxe. The next is early stage. However, Pi network is still in its early stages of development. Think of it as brand new gold mine that's still being built. You can't spend the Pi coins you mine yet because the system isn't fully operational. Alright, now the next is focus on users. So Pi network aims to be more accessible by focusing on user growth. The idea is that the more people join, like more miners finding gold, the more valuable Pi coins might become in the future. Alright, next is uncertainty. So there's uncertainty about the future value of Pi coins, similar to how there's no guarantee a new gold mine will strike it rich. Additionally, Pi coins is under investigation by some authorities, adding another layer of caution. So this was about how is Pi different from others. Now let's understand how the Pi network works. So Pi coin works as the currency for the Pi network, a platform for digital money. You can mine Pi coins on your phone using the Pi network app. The creators who are from Stanford made it so that users known as pioneers can mine Pi by tapping a button on the app once every day. This mining process doesn't use much energy or your phone's resources like other cryptocurrencies. Users tap a lighting button to start mining Pi, which initiates a 24-hour countdown. After the countdown ends, user must check in and tap the button again to continue mining. Unlike some cryptocurrency mining processes, Pi mining doesn't require leaving the app open. Simply opening the app and tapping the button every 24 hours is sufficient. The hourly mining rate varies based on when a user signs up, with earlier members earning at a higher rate than the later ones. Users can increase their mining rate by inviting new users to join Pi or by building a security circle within the app. Right now, Pi coins doesn't have a set value because it's not on any exchanges, but its availability is controlled by halving mining rewards. The network is still getting ready for a full launch, and users have to complete the certain procedures to join it, which helps keep things legit and safe. The goal of Pi network is to create a strong system where Pi coins have real uses in the world. Alright, this was about how Pi network works. Now let's talk about the pricing, that is the Pi network price. Alright, as of the latest update, the price of Pi stands at a roughly $40.58 US with a 24-hour trading volume of approximately 143k US dollars. In Indian rupees, the price translates to around 3,500. So the Pi network, a digital currency aiming for widespread adoption through its unique mining approach on mobile devices, has seen fluctuations in its value since its inception. Like any cryptocurrency, its price is subject to market demand and various factors influencing investor sentiments and adoption. Users continue to monitor its value as the project evolves and gains traction within the crypto community. Alright, so this was about Pi network price. Now let's move on to the next topic, which is what is the future of Pi coin? So the future of Pi coins looks promising as its creators plan to roll out several phases, aiming for its mainnet to become fully operational. Once this happens, they intend for Pi coin to be usable for buying things from different stores, not just for investing or trading like some other cryptocurrencies. However, for Pi to become widely accepted, it needs to transition to the mainnet and become available for trading on cryptocurrency exchanges. This transition is crucial for establishing Pi as a real and valuable cryptocurrency. If Pi achieves these milestones, it could gain legitimacy and widespread adoption, potentially becoming a popular choice for everyday transaction. But since the project is still in development, its success will depend on how well it progresses through its planned phases and how the cryptocurrency community responds to it. So in conclusion, Pi network is a developing project with the goal of making cryptocurrency accessible to everyone through mobile mining, while its future value and success depend on achieving a fully functional mainnet and tradability. It presents a unique approach to cryptocurrency by focusing on usability and everyday transactions. However, it's important to remember that due to its current stage of development, Pi network remains a speculative investment.
And with that, we have come to the end of our full course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply to you as soon as possible. Thank you and keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.